distribution, the technical distribution they need comes from kind of the physical realities. So local first really is not about architectures or technologies, but it's really about communities and their problems. And if we want to serve the needs of a diverse set of communities, which includes individuals and companies, then we do need a lot of applications, right? And we need people that are experts in these communities, in these domains, to write these applications. And we do not want these people to become experts. And this is where programming languages come in. Because programming languages really are the best vehicle to make complex solutions available to non-experts. And I have this belief based on our own experience in the REScala project, which basically is a library extension to Scala that brings function-oriented programming into Scala. But the important point I want to make here is that since we started working on REScala as a programming model, we added transactions, optimal parallel execution, pipelining, distributed transactions, crash restoration, high availability replication, compilation to microclusters, and transparent encryption. Now, the details of this list are not important. What I want to say here is that really each language-based project has this kind of list of advanced features that it makes available to programmers at no additional cost. I think having these things is really important because this allows languages to make these complex solutions available to non-experts. No one needs to know specifically how multiprocessor programming works to make that happen with REScala. And I think this making these things available to non-experts is really important for one of the main goals of this workshop, and it is to make local first to be the default paradigm to develop any new kind of application in, at least any suitable application. And I think we'll have a great workshop on that. It seems very promising. And Peter, you're going to tell us towards the road or the path to local first software.
All right. Well, thank you, Ragnar, for inviting me. Thank you all for coming. Let's see, is this going to work? Oh. I think, is the stream frozen? There we go. So yeah, hi, my name is Peter van Hardenberg. I live in Western Canada. It's been a long flight to get here. I'm happy to see everybody. It makes it worth the trip. I'm the present director of a small industrial research lab called Ink and Switch. Say a few words about it just to give a little context to our interest. Our interest is in creative computing and intelligence augmentation, not science fiction stuff so much as just, you know, the daily work of making computers that are more useful for us to think and do things. This is a picture of John Conway's office. He was a mathematician. You can see he has a computer, but there's a lot of computation happening in the space around him, geometric forms, a messy desk full of papers. Right? This is the broader context. Most of our work is done through a series of prototypes where we build short, intense technical experiments where we attempt to prove a concept through implementation, and then we write about them. Several of those projects were the input to the local first paper, which Martin, Adam, and I co-authored. Was Mark on that one? And Mark as well, yes. In addition to our interest in local first software, we also have some other more esoteric interests. This, for example, is a recent project we did called Crosscut, which is computation on a canvas, but not through the traditional node and wire graph, sort of drawing solutions to your problems. But that's for another workshop or another day. We're just going to talk about local first. And honestly, I'm mostly going to talk about CRDTs because my view is that that's sort of the underpinning of a lot of this work. In addition to doing sort of more pure research and writing papers, we also both industrialize or commercialize some of our work. We have the Muse team here today, or part of it anyway, and that's a spin out from the lab, and we've been working with Martin Kleppmann on AutoMerge since the beginning, 5 years ago or so. So that's another project we've got out there. So okay, enough of that. Let's talk about local first software. We're gonna have a few sort of movements in this story today. We're gonna open by defining local first software, try and nail it down a little bit, make sure we're all on the same page. We're gonna talk about the state of local first software, And then I'm just going to tell you all the things that I hope somebody else will solve for me for a while. So if you're thinking about like next year at the workshop, I would love some of these things to show up. But let's get to that. So I just want to open by saying we live in the cloud era, right? This is not the local first era, not yet. We're in the cloud era, and the cloud era has some problems. If you see one of these icons, you might as well just close the lid on your computer. It doesn't do anything. It's just sort of a brick if you see that icon. You'll see a lot of this icon. That's the spinner. You know, there's a lot of waiting in the cloud era. We've all been pwned. I don't know if you've ever been to this website and put your email in. I looked this morning. I have been pwned 16 times, 16 different data breaches with my email. And of course, you know, none of the software we use from this era has any temporal stability either. There's a whole website called Killed by Google that collects just Google's dead products. And there's dozens. There's another great Tumblr I like. It's Our Incredible Journey, which is a compilation of all of the blog posts people put up where they talk about what an incredible journey this startup they had has been and how much they value all of their users. But by the way, we've been acquired by, you know, Applesoft, and our product is being shut down in 3 weeks. Here's a JSON file with your data. All of this together is problematic. Maybe even more problematic is that we're entering a digital dark age. This is the Domesday Project by the BBC in 1996, where they attempted to replicate a digital equivalent to the Domesday Book, which is still legible 900 years later. Apparently this Laserdisc no longer works. But 1996 is still pretty good by the standards of the cloud. If you want to get data out of services that are 10 years old now, you're lucky if they still exist. So, okay, well, these are a bunch of problems. You know, it's easy to be, you know, old man yells at cloud. So, but you know, we shifted from something else to this. So what did we get? And the answer is we got everything everywhere all the time. And that's pretty good, right? The cloud has really changed what's possible with computers. We don't want to go back to this, right? You can have local-only software, sure. You can get a lot of nice benefits from it, but we're not willing to pay the price. So I'm going to quickly walk through what we believe are the 7 ideals of local-first software. So, you know, number 1, no spinners. You know, we want your work at your fingertips. Number 2, your work should not be trapped on one device. We all have lots of computers now. You know, there's nothing worse than going and realizing you forgot to push a patch or the file's on another machine. That's no good. We want the network to be optional. We want to take advantage of the network, but we don't want to rely on it. This little spot there, that's my kitchen in my last apartment. That spot was always open. And so if I was cooking, my laptop or tablet or something would always wind up there. But the refrigerator creates a perfect shield for the Wi-Fi signal. And so often, you know, you would go, you'd open up the lid, and you'd see the recipe for a moment, and then it would disappear, and you'd get the dinosaur. Also, sort of non-negotiable, though, is we want to keep this kind of seamless collaboration that's become the default in the cloud. It's, you know, we can't go back. And in fact, this is such a killer benefit that, you know, whole categories of products have basically been redefined by a new entrant that does the same thing as the old entrant, but, you know, with a collaborative interface. I mentioned briefly that, you know, longevity of software is important. In particular, for our research, we take a deep interest in the durability of software, because when you have an academic career or writing career or many kinds of creative scientific careers, you have a corpus that spans decades, not quarters. And it's really problematic if you rely on cloud tools that are retired out from under you that hold important information. I had a great conversation with Amit Patel of Red Blob Games, who maintains a database of game development algorithms and information. And he said he does everything on his laptop from Emacs, because any cloud software he's adopted, he's been at this 25 years, eventually it goes away and he has to rewrite. So now he just keeps it all on his own machine. You know, backs it up somewhere, but we'll come back to that. Of course, you know, it would be nice if things were secure and private by default. I, in a past life, ran 1 million Postgres databases. The default for Postgres is, you know, you put data in it and then you can read the data out. That's a big, sweet target for hackers and intrusion. We spent a lot of time and energy trying not to get hacked. We never had any major embarrassing breaches, but that's as much good luck as hard work. So it'd be nice to not have the default be this sort of open system. And last, I think this is maybe a more subtle point, but we really believe that users deserve to have ownership and agency with their software, right? We should choose what we adopt and what tools we use when we want to upgrade on a time that's good for us, and not to have sort of this shifting space underneath us where the tools we use and the way they behave is not something that's in our control. It'd be very strange if you went into your kitchen and the cutlery drawer had been moved because some product manager in Cupertino decided that it should be on the other side of the kitchen. But that's the reality of the world that we live in with software today. So just to summarize it there. I also want to talk a little bit about, and this isn't in the local first paper, but there's also a strong case, I think, for why this is good for developers and development in particular. The kind of cloud architecture, kind of the archetypal imagined cloud app, is a 3-tier architecture typically. You have a front end, whether it's templated on the server or not, delivered out of a single page app as a React app. You have an API, it might speak REST or GraphQL, and then you have some kind of data store in the back end, whether it's a bad database like Mongo or a good database like Postgres. But this is only kind of like schematically true as well. And what happens is as your software grows, you inevitably grow out of one of these elements after another. And over time, you get one of these, right? And this is your architecture diagram. This is the cloud native cloud foundation landscape map. And like we've all seen, many of us in industry have had pages on our wiki that resemble this, showing all the different microservices and cloud services and monitoring products and everything else that power our infrastructure. And it's not only mind-bendingly complicated, it's incredibly difficult to maintain and operate, and it's very expensive. Sorry, a little lag on the stream. So local first software instead can be self-contained. Because the system needs to be able to work offline, you can't have pieces of it somewhere else. So that means that you get this wonderful kind of package of functionality that travels with your device. And for someone who spent so much time working on cloud infrastructure that spans not only dozens or thousands of computers, but also multiple programming languages and teams and so on, to then bring all that into a much smaller place and simplify the architecture down to something that you can reason about is incredibly empowering. And it's honestly a joy to work on this kind of software as a result. And so the result of doing this kind of work is that we wind up changing the relationship we have with the cloud, right? The sort of cloud era model is that the cloud is this sort of omnipresent energy force that animates everything. And we are supplicants before it. We take our small takings from the cloud, but the cloud is where everything lives and we just visit it. And what we propose instead is that we don't want to do away with the cloud. Certainly I would be ashamed if all my data disappeared from the internet when I closed the lid on my laptop. But we want the cloud to participate as another peer with a different role, right? So if I have my software and you have your software, well, maybe the cloud is more like a warehouse where we can keep our data when we're not using it. So to sort of simplify this down and kind of distill it to a single sentence, with local first software, it should reside on a user's device and it should collaborate with others. You need both pieces. If it doesn't reside on your device, it's not local first. And if you don't have collaboration, it's just local only. It's just, you're going back to the MS-DOS era. It's not competitive. Okay, so we've talked a little bit about what local first is and what we're trying to accomplish. And I'm going to maybe take a little bit of time now to talk about some interesting consequences that I would like more people to think about as they're building local first software, thinking about these kinds of programming language questions. One is this sort of notion of conflict resolution or conflict management. So let's begin from the assumption that if you have local first software, it needs to work when there's no internet. So if you have data on your computer, you can edit it. maybe you shouldn't. If you have a bank statement and you start editing it, well, that won't put more money in your account, of course. But you could, and you can. And if you're collaborating with somebody else on a document and you edit it, they might be doing the same thing, and you wouldn't know because you're offline. So in the general case, we can't always prevent conflicts, right? Like no amount of cleverness, no clever algorithm, no subtle conflict resolution system can always prevent conflicts. But the conflicts will always vary in scale and impact depending on the magnitude of change. Now, a single comma might change the meaning of a sentence, but what we've found in our prototypes and through observing users and interviews is that you kind of have different orders of magnitude as time horizons increase, which affect people's expectations and experience of resolving change. So if your, say, latency in a system is under 300 milliseconds, users experience this as basically real time. Maybe not for a real-time video game, you need better than 300 millisecond ping, but if you're typing with someone and you only have 300 milliseconds of lag, you're both typing in the same place, you don't think like, oh, I'm getting weird conflicts here. You think, oh, I should move my cursor out of the way. Now, as that starts to expand, right, and I've sort of just bucketed this 300 millis to 30 seconds, if you have conflicts or problems, your reaction is not, oh, I need a tool to fix this. Like, I fixed a word and then I hit submit, and then you fixed a different word and hit submit, say in Notion or something, which doesn't have the block level conflict resolution. Oh, my change is gone. Oh, that's annoying, I'll just fix it. So the default reaction at this sort of middle scale to conflicts is to just rework. But as developers know, as the scope of change increases, the cost of rework increases, and so the need for tooling increases. And what we have observed is that, in fact, offline mode is quite similar to just having extreme latency, which is also basically equivalent to working in private as on a Git branch or in a draft by yourself. And so you see the same problems emerge in all those different cases. And so there's no hard line between synchronous and asynchronous collaboration. But there's also no moment where we can say, oh, now we need these version control tools. Sorry, it's like that. Now, in environments where you only have a single author, you can kind of get away with ignoring this. I only have two hands. I can only use one computer at a time. I'm aware of which computers I have. So if I'm working on a document in iCloud, maybe I edit it on my laptop and then I forget and I edit it on my desktop and then it says, oh, my laptop when I open it up says, oh, there's conflict here. And this is so upsetting to me. You have this modal dialogue with this tiny little thumbnail of your work, and all you know is the timestamp, which in this example from Apple's documentation is the same time. Whichever option you pick, there's no going back. Choose wisely. So I think this is a problem, and we need tooling and infrastructure to improve on it. But tooling and infrastructure can only go so far. In the CRDT kind of world, we spend a lot of time trying to find better invariants, but we can still produce what I call consistent nonsense. So Martin wrote a good paper a while ago, which was, you have this, someone wrote hello, and then Alice says hello mom, and Bob says hello pop. And so we can merge that and get hello poop. And this is obviously wrong, right? We can do better than that. Like, we could prevent the interleaving of characters. This is clearly a much better outcome. But it's wrong. You're not saying hello mom pop. That's ridiculous. At least ungrammatical, right? And so, yeah, okay, we've improved on the invariants, we've ensured, integrity of the change, but it's still wrong. And in a lot of our CRDTs that we've written and implemented and talked about, the default behavior is to just blithely say, well, this is a good merge, there's no conflicts here. But there is a conflict here, right? Now, what we've observed in our user testing and watching people use our prototypes is that, for the most part, humans have good intuitions about conflicts. And if I know that you're working on the intro, I'm not going to wade in there and start fixing things, right? We have informal coordination tools that we use. But no matter how good our invariant preservation is in our sort of technical infrastructure, the human embedded context will always have unmodeled or even unmodelable constraints in it. And so we need to be aware of that as we're working on these algorithms for collaboration. We need to be thinking more about, how can we help the user recognize that these problems that we can't see are happening, and what tools can we give them to resolve them? In particular, when we talk to journalists and lawyers, they have a lot of really sophisticated workflows and requirements. So for example, at the New York Times, if you are publishing a politically sensitive piece, you not only have to be fast to print, you have to be absolutely correct. The journalistic integrity of the publication is something they hold in extremely high esteem, and it's through very careful, hard work with workflows that have been developed over a period of a century or more in some cases. So it's really important to get this right. Similarly, lawyers, they like to have change tracking. That really helps them do their job. They don't want to miss changes in the contract. But they really don't want to leak all the intermediate states in between the two endpoints, between when they got the contract, edited it for a while, and sent it back to opposing counsel. There's a lot of interesting needs there. So the conclusion of this is, there's no getting away from it. If you're building local first software, we need these user-facing merge tools to understand what's happening. And not all the time, but particularly if you want to support people working in disconnected states and with multiple authors, I think this is unavoidable. All right, so that's my little spiel. Let's talk a little bit about where we're at today as a community and as a project. Local first software, despite all of my doom-mongering at the beginning about the cloud era and everything being broken, it's actually pretty common. On your phone, most of the first-party apps by Apple or Android, whichever camp you fall in, are pretty good local first apps, right? There are some problems with certain syncing systems and so on, but for the most part, these are built by well-resourced teams who take the time to solve all these problems, and your notes will sync back and forth. You can edit in your desktop and your phone, and it'll mostly merge pretty well. And again, these tend to be single author kind of environments, so the problems that you have, you tend to avoid on your own. Other places where we see local first style techniques widely deployed, video games, right? It's just sort of expected that you can download the game and play it offline. Obviously, Dropbox and those kind of folder sync tools have a lot in common, or sort of, I think of this as a spectrum rather than a Boolean, right? They're more local first-ish for obvious reasons. Calendar and to-do apps, those communities have a lot of demand for this kind of thinking, so they do that well. And of course, it's worth noting that all of us as developers would never work in a pure cloud environment. Can you imagine if you were trying to work on a code base like we work in a Google Doc where everybody else is typing in at the same time as you? It's kind of unthinkable to imagine doing anything at scale that way. Clemens is maybe going to come up and show me that you can do this later, but we'll look forward to that. And so we have some things that are going pretty well. CRDTs have made a transition from academic curiosities and early prototypes into production. Kevin Jahns is here from YJS. I think Y is probably the most adopted and most successful CRDT implementation on the market today, but we have people using AutoMerge in production, and there are other people, Muse is going to talk about what they're doing, and there are other people as well, Actual Budget, Figma, doing CRDT or CRDT-like things, and that's going pretty well. So, what's happening, what's working? We got real-time collaboration. We have kind of like aggressive merging of offline work, like most of these systems will merge offline work, but you tend to just kind of get like, here's the new thing, good luck. And we have fairly decent storage and synchronization systems. Mobile devices have reasonably credible offline capabilities for obvious reasons. And even the browser has improved quite a bit in recent years. Chrome recently introduced a file system access API to help manage persistence, for example. If you're thinking about writing a piece of software and you're like, well, should I do this in a local first style or just sort of stick with the easy cloud thing? If your data is modest in scale and mostly the users of the program are allowed to read and edit all of that data, it's probably okay. If your software has a huge amount of data, or is managing external resources, or has a lot of like sensitive privacy and ACL kind of needs, I think we can get there. We'll talk a bit about the problems we want to solve to get there. But I think that those are harder cases to make to an engineering manager, for example, today. Though if you're a solo founder, let me know how it goes. When I talk to people about, founders and engineering folk about, who want to build these things, what the challenges they face today are, one of the most common refrains is just, I read the paper, I looked at the libraries, this looks great, I'm in. What do I do? And you can go to the YJS and yeah, I've got a CRDT now, but then it's like, we don't have, this corpus of knowledge and sort of starter projects and everything like that that are the whole package with, databases and storage layers and everything like that off the shelf. So it's still very much kind of like early adopter territory. There are relatively few cross-platform options. Both AutoMerge and YJS have been working on Rust implementations, which should allow us to extend these technologies to mobile platforms better, but those are early. And in the cross-platform world, you kind of really have three platforms: the browser, which is also desktop now, and then iOS and Android. And so if you only do JavaScript, then you are only in one of those. And if you don't do JavaScript, then you're kind of siloed to just iOS the way Muse is. One of the things that we have found, and we'll return to later, is that you really can't do peer-to-peer networking and get any kind of end-user product reliability. You tend to see software is still in kind of either asynchronous or synchronous collaboration done well, but you don't see the sort of combined modes very much. Browser performance is really problematic. If you want to run at 60 frames a second, and you should, then it's hard to do that with the browser stack. And then I think, very important, but maybe further afield from the PL theme of this session, there's just such a good understanding of how to build a business using SaaS business models. And anything that sort of transfers control of the software or data away from these cloud services and down to the user leaves businesses in a position where they feel quite exposed. It's very hard to make a business in software, despite what you may have heard. And anything that increases the risk is something that is concerning to the business interests of software companies. And I think that there are great reasons why building local first software could actually be a real strength for a business, but these are undeniably things that we see out there today. And I talked a little bit about this before. They call it a browser, not a keeper, right? Like the main platform where we run most of our apps, including where I'm running this slideshow right now, was originally invented to allow you to just like surf the web, not to be the operating system that all of our software lives on. And so all of this like modern app development infrastructure that's been built into the browser has kind of arrived in fits and starts and piece by piece over the years, and from a company primarily that thinks about the cloud. So it's still kind of slow going and getting good, robust user experiences and support for offline experiences out of the browser vendors. Okay, so I want to cover a few other things that we've learned in building local first products. One, which I think we'll hear more about from the Muse team later, is that you kind of have this crossover between synchronization and persistence. In early experiments, we thought, okay, well, we've got the CRDT, we're just going to merge all the data, but there's data that you don't want to share because it's either not relevant or private. And then there's also data that you want to share, but it's ephemeral, and you might not want to keep it around forever. So, the shared persistent stuff is actually pretty easy, right? That's whatever your app, core logic is. But when you're typing into the text box a message before you hit send, one, you don't want that to appear in everybody else's text box. And two, it's not really valuable to have those intermediate states around. You don't want to commit to it until you press enter in a chat, for example. And similarly, if you have a cursor position or a partial ink stroke or something like that in your app, it doesn't make sense to produce, hundreds of transactions per minute of where somebody's mouse is on screen that you then save forevermore. And so this is the kind of two axes. One other metaphor that I think is important to think about is that if you go back and look at the history of computing, we began with data having sort of very strong thing-like properties, data as object, data as thing. So if I download a file, then it becomes mine, and I have a copy, and if I give a copy to you, then you have a copy and I have a copy, and it's now yours. There's this sort of clear transfer. The cloud model is data as place. If I invite you to a Google Doc, I can then later close the door and you can no longer come in, right? You don't have a copy, you have temporary access. You come to the data. And there's benefits to both, right? If I send you an email and you get the email, I don't have to worry about the email going away later. I can find emails from 15 years ago and see, I guess, what I bought on Amazon or something. But for local first documents, we want properties of both, right? We want to have this ownership where we can keep the thing, where we can really rely on it being ours and that it will be there later. But we also want to have some of these cloud-like benefits that we get from the data as place model, where we can have multiple collaborators either synchronously or asynchronously working together on things. And so this remains an open and interesting problem. One other thing I hear a lot when I talk to people about local first software is they say, but how are you going to do ACLs? How do you handle permissions? And instead of giving people permission to do things in a local first world, you actually need to decide who you pay attention to. This is the US Constitution. I can print this out and write, Peter is in charge now, everyone do what he says. But that doesn't change the law of the land because nobody recognizes this contribution, right? So if you have the data locally, you can do whatever you want. And there might be all kinds of different reasons why people send bad data, but you need to think about not in terms of who has permission to do X, but who do I pay attention to when we do X? All right, so this is, we've gotten through the parts that I think I know. And now this is just my quick pitches for somebody go write a paper about this. Or maybe you already have and I haven't read it, or maybe you have solutions, come and tell me. And if you have more problems, we can talk about those too. How am I doing for time here? Okay, I've got some time. But we're going to move quickly so I don't glaze your eyes over too badly. Okay, problem 1, networking. This is Pitfall. This is long now software. Pitfall came out, as I did, in 1982. It's the long now people will tell you should have 5 digits on your dates. This is only 40 years old, but you can run it. And note that it's running in a Windows 95 emulator. So you could even emulate Windows 95 and then emulate an Atari 2600 inside of that. You can't really do that with cloud software. And also, in the modern world, our software is broken if the network is down. Even local first software, right? We think collaboration is a killer feature. So if the networking is broken, then the software is broken. It's as simple as that. But cloud services cost money to operate. They take operational resources. So they're very unlikely, any of them, for any reason, to still be around in 40 years. So if you care, like I do, about not having a digital dark age where everything that we did is lost and nothing that we do has any longevity, this is a real problem. How do you build a piece of software that you could still use 40 years from now? Probably in an emulator or something, but still, right? Like, I can go and download an Atari 2600 ROM and play Pitfall. I can't download a Google Reader ROM and re-experience the social media world of whatever, 2005. And peer-to-peer networking doesn't really work. And we talked a lot about this in the Pushpin paper. The kind of really brief summary is that due to the history of networks in professional contexts, there was a period where there was a lot of NFS file shares where people were accidentally sharing data they didn't mean to, or BitTorrent and people pushing viruses over networks onto Windows computers. So most institutional settings block all local network traffic. Some, peer-to-peer, some networks will allow you to do what's called a hairpin NAT traversal, which is where you go to the NAT and then tell it to come right back in immediately, and some don't. And it kind of comes down to what brand of router is where you're at. And that's not something we can fix, or at least that we know how to fix. And as far as I can tell, there's just no solution. So you need these relaying servers. I mean, one possibility is we just need to engineer more, right? Like the solution here is like, think harder, do more. Like, we'll start a foundation. We'll make it easy to deploy relay servers. We'll create a global DHT of relay servers and fund it through Patreon with an endowment. I don't know. We could do a lot anyway, is kind of what I'm getting at. I don't know what, but that's one approach. The other approach is the like, if you can't win, change the game. So maybe what we need to do is find ways to redefine the scope and relationship of our software to the network, where we kind of move the network out of scope, right? Like if I have a SQLite file, I can put it on a USB thumb drive and mail it to you, or we could send it over FTP, or we could probably stream it with some new WASM thing. So there's kind of two models here. I don't know what's going to work. Let me know if you figure it out. We'll have a little summary slide on each of these. I won't read them to you, but we'll put the slides up later so you can look at these things if you're interested. Okay, problem 2, schemas. Yeah. Okay, yeah. This is Moxie Marlinspike, co-founder of Signal, who said, you know, oh, if something's truly decentralized, it becomes very difficult to change and remain stuck in time. You know, that's true of IRC and a number of protocols. I don't think this is necessarily true, but it is evidently true. And I think that, you know, you kind of have to take a model where you need to think about carefully about how you deal with data that you don't trust. And there might be a lot of reasons why a program gets data it doesn't know how to deal with. It might be that the user you're getting data from has an older version of the software, or they have a newer version of the software, or they forked the software and they're running a different branch of the software. Maybe they're mean and they're just deliberately trying to poison your app by sending, you know, bogus data. Maybe there's a bug, or yeah, you could invent reasons all day. I'll spare you. But the sort of path forward, I think, for this is that classical database wisdom says, well, we maintain the integrity of the database, which is a joke, by the way. If you've ever worked on a large operational system, there is always weird stuff in your database. But the idea is that you guard the entrance for data. You say, we will ensure that no bad data comes in, and so when we read, we don't have to worry about it. But in a decentralized world where anyone could be sending any writes from anywhere, and you want to have live collaboration and asynchronous collaboration, you can't actually assume or trust other peers. So you need to have read time guarantees. And so, you know, maintaining these invariants and preserving the integrity of the data as presented to your software is something that we do through, you know, various tricks with CRDTs. There are other kinds of tricks you can do. We wrote a paper about this called the Cambria paper last year with Geoffrey Litt. And the idea here was that sort of to flip around the idea of a database migration. So with a database migration, you know, you write a one-time change to the schema and then propagate that through all the written data. And with a Cambria edit lens, which you kind of invert that. So you say, well, from now on, I'm going to be sending data in this format, and it relates to the old version in this way. I've renamed this field now. So if you're running the old version and you want to read my data, you just have to rename this field. So we kind of leave these markers. And you can do this pretty efficiently. We've only scratched the surface of this. I think there's a lot of potential here, but it might all fall apart once we push it a bit further. We got some good early initial results. But the potential, if you can pull this off, is huge. If nothing else, just not getting weird runtime errors when you get bogus data and being able to say that with confidence would be a real step change in terms of like working in distributed systems, right? Having that agility, that sort of flexibility in terms of network protocols would be amazing. I mean, I call this problem 3 here out of 9. Really, this is like 6 talks. I'm just going to skim across it. I love this quote from Leah Kuessner. Crypto is a tool for turning a whole swathe of problems into key management problems. Yes, great, you've encrypted the data. Where's the key? Okay. But sort of at its core, a lot of this is about knowing what you're sharing and with whom, and having control over that over time and through a distributed system where they might have different answers to those questions. You know, I can email you something and say, please don't forward this to anyone else, and then you might do it anyway. So if we have a live collaborative system and somebody does that, what happens? I don't know. Of course, we also don't, in local first systems, we need offline authentication. There's a lot of neat problems here. I'm going to sort of skim across. We want to be able to have these sort of like cloud warehouse servers, which are just dumb data stores, shared resources potentially, like S3. How do you use those efficiently? The Scuttlebutt people have done a bunch of good work with this, with FlumeDB and like pub servers. Lots of neat questions to ask here. There's also really interesting questions about group membership. You invite someone to the group, and then somebody else leaves the group, but then someone who's still in the group loses their phone, and you realize that the messages you got this Monday were from a bogus source, but now everybody else is built on that. So in CRDTs, we just have these vector clocks. There's no way to excise those bad messages and carry. It's a mess. Herb Cottle, who unfortunately missed his flight, has been working on some interesting work around being able to calculate who at least you want to be in the group when you have a decentralized system. If I remove someone and somebody else adds them back, and then I remove them, how do you get consistent views of who's in the group and who has what permissions? Really tricky, subtle stuff. We tried a prototype also last year, I think, called Backchannel, where we just decided to try and cheat and not have accounts at all. So the idea is there's no usernames, there's no central registry. You just introduce with a PAKE key, that's a one-time use key, meet at that rendezvous key. I say, yeah, that's Jenny. They say, oh, that's Peter. And then we just have a shared secret from then on for exchanging data. And that's cool because you just kind of can skip a lot of these problems, but it really, at least as far as we push it, was just direct one-to-one communication. Okay, so we've talked a lot about version control. There's even more complexity to this. But I think I would love to see more folk working on CRDTs and these data structures who are thinking about what are the affordances that we need to use these things kind of a level up. It's not enough to just merge everything. But there's other interesting problems as well, like how do you cherry pick some changes, right? Like in Google Docs, if someone makes a bunch of suggestions to you, you can pick and choose which ones you want to keep. What does that look like 2 layers down in the CRDT? Fun fact, Google uses OT for Google Docs, but suggestions are just a formatting type. It feels like we should be able to do better. And there's neat stuff there around sort of consolidating changes and figuring out if you can apply them and what the dependencies are. Right now, we just sort of have a maximalist view. Everything is dependent on everything. And again, now we have these sort of 2 paradigms. We're seeing this again and again, the synchronous and the asynchronous, the cloud and the like offline decentralized model. And we want to hybridize them. Indexing of CRDTs is pretty cool. Do we have anyone from Data Hike here? Any folk from that world? Not today? Okay. I guess if you already have a database, this is easier. But if you have, like Y or AutoMerge has a whole bunch of different documents, and you want to be able to say, like, is this keyword in any of these without reloading everything? We have an incremental view maintenance problem that's made more complicated by all the different versions of the documents that might exist. I don't know. It seems hard. Let me know if you figure it out. Well, hopefully somebody else will get to this before us. This is always my hope with this stuff, which is I'm like, if I just keep telling people about this stuff, maybe somebody will build these things before I need them. Decentralized search kind of builds on this index question, right? Like, what does a local first search engine look like? Like, not just searching your own documents, but with Notion, when you do a search, it only works on the server. So even if you're in offline mode, you can't search your local data. I had a great conversation with a Slack employee who was like, oh yeah, I see how you could do local first for all of the like actual chat rooms, but how do you handle all the complicated ACLs for search? Like, oh, you can't get this search result back because you're not in that room. So we talked a little bit about that and imagined a world where like each room would have its own full text search index, and then you would have access to the indices for the rooms that you were in, and then you'd aggregate those down and you could query across them all. And you could fetch updates just for, I mean, it sounds interesting, but again, I don't know if anybody's tried it or done it or written anything about it. If you have, please come tell me. Sounds fun. I think it'd be a lot of fun to work on. I kind of want to do it just because it'd be neat. Cool, getting there. This is a non-CRDT one, just for fun. We've got this big computer in the sky, right? I was complaining about it before, but like, what should it be doing? Well, it should be working for me, right? Like, you know, you read these science fiction books where they're like, oh yeah, like, you know, the character puts their laptop in and they send something up to the cloud and it's suddenly running on millions of computers and super fast, and you're like, oh yeah, no, what, it's using Docker for that? No, we don't have the model for that. So how do we actually take these workloads that are computationally expensive, divide them up and distribute them to the cloud, but in a way where we can run them offline and locally if we don't have those resources available or don't want to pay for them? You know, ideally, if you're doing map tile generation of like OpenStreetMap data, not only should you be able to do that if you have that data cached on your device, but you should be able to say like, oh yeah, I'm going to, you know, Berlin, like go render me all the tiles that I might see and cache them offline for me for later. And even better, if there are people you trust who are doing this data, I should be able to coordinate with you and download your tiles, and they should be signed by you and have markers for the upstream data they're derived from, and I should be able to, kind of like a makefile distributed compute farm setup. I mean, it sounds like science fiction because we have never tried to build anything like this to my knowledge, but you know, I'd like to see it. You know, once we got all these cool data files, programs are data, man, let's get on it. What are we doing with all this like plain text Git? You know, I've got this live streaming version CRDT, and then I'm pushing code up to GitHub and deploying it to Netlify to load my cool streaming CRDT data. Well, I want to put the program in there. I want to be editing live, and you know, like I want to have all the benefits that I've been talking about for our data and our applications, but for the program itself. And I think this is a really fun and exciting place to consider exploring. It's not clear to me whether this needs a special CRDT or whether it's just a data modeling problem. You know, you can represent a program as an AST and you know, have references for variable names so that if you rename the variable, you know, all the references are updated. But maybe there's, you know, other interesting things. Does the type system need to be represented in there? What kind of metadata do we need to store? Can you, no, I'm sorry to say I'm pretty skeptical about structural editing. I kind of feel like if it was going to work, it would by now. Or at least there seems to be some kind of path dependence on it. So whatever we do in this space is going to have to interoperate with like, you know, VI. So like, what does that mean? How do you diff the VI text buffer and turn it into a magical syntax tree CRDT? I don't know. Seems fun. You know, but anyway, we've kind of gone through all of these things. I hope someone in this audience is thinking, I could do that. So, and you will. But I want to talk a little bit about programming models around CRDTs because that's kind of the theme of the event here. The present state of the art, you know, this is kind of a Muhammad must go to the mountain kind of thing. When people were first researching CRDTs, there were a lot of implementations in like Erlang and Haskell and C++. And it doesn't matter how many of those you write. I guess WASM changes things a little bit. But unfortunately, most developers are writing JavaScript. And so, you know, Kevin and myself and Martin and Orion, we, you know, took one for the team and wrote a lot of JavaScript. And it was pretty bad. I'm not going to lie. You know, no matter how long I go in my career, I still have not escaped JavaScript. Try as I might. And like idiomatic JavaScript is based around this like event model. And the event model is the pits, right? This is a little view maintenance here. I've got this array of peers, and whenever a new peer comes online, I push them into the array, and if I see a disconnect message, then I filter them out of the array. Why am I doing this by hand? It's ridiculous, right? The Elm architecture is a functional reactive programming environment where the motto is, if it compiles, it works, right? And so Elm at compile time looks at all the possible messages and signals that can flow through the program, and it has a very constrained program execution model, frustratingly so. But it's really amazing to write software where if it compiles, it works. And they really, really do a good job of making that true. If it compiles, it doesn't necessarily look good because I'm not great with CSS, but it does do what I intended, and that's cool. I think that simplicity is a prerequisite for reliability. And we might hear more about this kind of premise from the Muse team and their implementation of their sync system. I think that it's impossible to write simple code with this event model. And what we need is something that's a richer and more sophisticated model. I take a lot of inspiration from Microsoft's Orleans project and Paul Chiusano and team's Unison project. Both of these are programming models that are based around more sort of traditional transactional semantics and online programs, but they look like relatively straightforward imperative programs, but if you write using their model, it will distribute the work over a whole bunch of different computers or compute environments and scale it based on your needs. I think that if we're going to see something like that for CRDTs, it's probably going to be based on this incremental view maintenance or differential data flow model. I don't know if anybody's working on this yet, but I feel like this model of flowing changes through the system in a reliable way and not having to constantly be adding and removing things manually from sets and arrays everywhere in your application is really the way forward. And we have spent a lot of time at Ink and Switch very, very carefully connecting prose mirror to auto merge or other CRDTs so that every single time the messages get correctly plumbed through and then you miss some weird edge case and then everything just goes weird and you spend days tracking it down. It'd be really nice to have a programming environment that just guaranteed you didn't get those kinds of skews introduced. How you build that in real life, who knows? And there's lots more, right? Like maybe all of this stuff with CRDTs based on documents and maps and lists is wrong and we should be doing an event sourcing model. Maybe we need to figure out how to do hidden information so you can do things like mental poker and prove that you had something but don't share it yet. All of this stuff is happening in the browser. Lucky for the Muse team, they're on iOS where at least things are fast and people care about frame rate. We probably need different rendering engines that are better suited to these programming models. I could go on. And I've missed other problems, I know. And maybe you have solutions to them, but even more important, maybe we don't need to solve some of them. But it's hard to tell which ones. So we should probably just try things. That was a lot. Thank you for riding through the weirder parts of my long backlog of possible projects at the lab. It's pretty clear there's a lot of work to do. We are in the very early days. But if we can get this right, we could have a pretty great software development world again. I don't know about you, but I find it pretty unpleasant to write software in the sort of current paradigm. You've got to get Docker containers and stand up servers and install all these different daemons. And when I work on this local first software, even at sort of early nascent state, it's just so satisfying and predictable and understandable and legible. And it's a real joy. This software could cost less, right? Like just a simple economics argument for businesses. It costs a lot of money, not just to license Kafka, but to hire the team of people who will get woken up at 3 in the morning to figure out why it's not working today, right? It's just hard to build software because we're building it wrong, Maybe we can have better, faster, and cheaper, just like NASA did with all those semi-successful rover missions. But I think maybe we can, because I think, honestly, this is from the paper by Engelbart about augmenting human intelligence, where he shows that, you can certainly de-augment human capabilities. Maybe we're just programming with a brick tied to our pencil. So if we just take the brick off, if we stop doing all these complicated, ridiculous things, it's not implausible that things could just be better. You can't take the brick off twice, obviously. Once you've taken the brick off, it's just a pencil, and making it lighter, eventually it's just floating away from you, and now you have a new problem. So, I'm not saying we should assume that this is an unlimited ability, but it seems pretty bad out there, so I think it's at least plausible that there could be some global improvements. This is the USS Nimitz. It's a U.S. aircraft carrier. Cruise 5,000, costs $8.5 billion. This is that same graph of a cloud architecture diagram to scale, the same one-to-one. This is a bicycle. It has a crew of 1. It costs substantially less than $8.5 billion. It doesn't do what an aircraft carrier can do. But an aircraft carrier can't do what a bicycle can do. And it feels like most of the software that we're writing today, even when what we need is a bicycle, we're building it like an aircraft carrier. And I just think we can do better. Sometimes I feel like we've just landed on Mars, like nothing is built. There's no reference points, there's no Stack Overflow article you can go to explain how to do something. You know, we're inventing a lot of things from scratch, and there's going to be false starts, there's going to be wrong directions, people are going to get lost along the way. But to me, that's kind of why I take so much joy in working in this, is that, you know, I see the potential, right? We have moved from the mainframe era through the personal computing era. Now we're in this cloud era. Each of these sort of epochs of computing has been built around a particular paradigm of software development. And to me, this local first direction feels like it could unleash an incredible Cambrian era of innovation, changes in business models, changes in, you know, the kinds of software that can be built, the kinds of people who build software, the kinds of, you know, problems that we can solve. And I just get so excited when I think about that. I hope that we can get there together. I hope that this has given you some ideas about problems to solve or things that we can work on. There's a whole bunch of links to Ink and Switch, and you can email me or Twitter me or look at our GitHub or anything else. And I thank you so much for coming. It's so wonderful to see a room full of people who share these interests.
Thank you very much. Do we have some quick questions? Please.
If I want to build local first software today, what's the best or least bad programming language to use?
It's JavaScript. Well, it's TypeScript, but yeah, sorry. Maybe Rust? Probably JavaScript.
Further questions? Yeah?
I would like to sort of be devil's advocate
Please.
for a second, and because you were talking at the beginning, we're talking about, you know, being forgotten and data being lost. But isn't that also kind of nice? You know, in certain circumstances that, like.
So we talk about the Dark Ages. The Dark Ages are a period not describing an era of misery and suffering, though misery and suffering have been constants throughout human history. But it's an era that is lost to history. We don't know what happened. Everything that happened then is gone because there were no records. I think that when we let people have their own data, when we put it in their hands, then they get to make those choices. And it's not about whether, you know, your programs get used by GitHub to build an AI to automatically produce mediocre code, you know, when you press tab, whether you like it or not. But it's your agency and your decision what happens, whether it's forgotten or remembered. And right now, those choices are not in our hands. They're in the hands of large corporations whose interests are at least disjoint from ours. I saw there was another question at the back. Yeah.
So I guess CRDTs are known to have some limitations, like namely you can't use them to enforce strong consistency. Right?
To do what?
You can't use them to enforce strong consistency.
You cannot use them to enforce strong consistency. Okay.
So I'm asking, are they a silver bullet or are there limitations?
There are, of course, no silver bullets, so that's a trick. I saw what you were going for there, and I saw through it. As I mentioned in an earlier section, you know, there are certain use cases where CRDTs are just kind of a slam dunk. But you can still do consistency with POSIX files, which also don't have transactional semantics, right? That you have to build, if you want those properties, when you need them, you have to build them on top. And there's no reason why you can't do that. You could implement a database, you could store just run Postgres and store all the pages in a CRDT and, you know, like have locks, you know, use a semaphore or run another system for that part of your thing, right? Like the point is one, we can do it in awkward, clunky ways when we need it, or two, we can use other systems in those rare cases. But I think, in my opinion, there is an awful lot of software to be written that doesn't need those things, or at least not all the time.
You touched on this briefly, but how likely do you think we're not in the local first age, but in the cloud age, not because of technical challenges, but because of business challenges? Like having a cloud app gives you protection from piracy, gives you a moat, which could go away if you actually give people back access to their own data.
This is, yes. Yes, of course. The question was, are we in the cloud age for business reasons or technical reasons? The answer is, of course, both. A few brief observations. We have thought a lot about this, but I haven't written about it because I don't like to write about things we haven't tested rigorously. But briefly, software had a 95% piracy rate. Cloud services are very happy with a 5% conversion rate. These are the same number, but with a different feeling. And piracy does not cost the developer any money in operational costs, whereas freemium users, I speak from firsthand experience, can be very expensive to support. So I think that's one lens on it. Another lens is that we don't know what the economic models will be. And in fact, if you look at the history of software, each of these epochs has gone through growth periods where the model developed. When the iPhone launched, it did not have an app store. And shareware was something that emerged during the personal computing era as people experimented with different ways of convincing people to buy their software other than putting it in a store in a box with a nice label. Okay, I'm probably over time with these questions. We're only 5.
I think we have technical issues, so take one more question and then
Great, yeah.
we'll just plug it in directly. Okay?
Yeah, so I love your picture with the bicycle.
It's apples, but yes.
I mean, the
Yes.
metaphor.
Thank you.
But I'm concerned, or I question, so what's your prediction? Are we with the bicycle now? Because the things that we're doing with local first are rather simple, but when we add things like I want the data to be interchangeable, I mean, the schema problem that you mentioned, I want to have the same, I want to have mobile, I mean, the code be distributed across the devices, participating devices.
So
I end up with a complexity
Yeah.
in the local first setting.
So just for the stream, the question is, are things better because we're not doing hard things yet?
Very good summary.
Out of the tar pit, there's this concept of accidental versus essential complexity. I think a very large fraction of the complexity in scaling software today is accidental. It is not intrinsic. Slack has all of these engineers running Kafka. How much data can my fingers make in an hour by pressing switches? This is not a big data problem. It's a small data problem. But when you put everybody's data together, you have a big data problem. Whose interests does that serve? Honestly, I don't think it's the development teams, and it's not the users. And I'm also not convinced it's the business people's. The cost of operating these services puts businesses into these cycles of incredible operational and financial carry just to build things. I have known companies that have closed because their burn rates were so high just to operate that their business models wouldn't work. So I think, I've said earlier, I think, yes, as we do more things, there will be more challenges. Good abstractions, robust design can go a long way to providing good guarantees that prevent problems from cropping up and propagating. So that's one part of it. And the other one is just, I think we eliminate a lot of accidental complexity by having a different model that's more manageable. But we'll see.
Thank you again.
All right, well, thank you, everybody.
Great keynote. I'm sorry for the technical questions. That was all my fault. But now we have to talk by Jim and Elisa. Please go ahead.
Hello, everybody. So my name is Elisa Gonzales Boix, and I work at the Software Languages Lab at the Vrije Universiteit Brussels. And I'm going to explain you a bit about our research on programming language for basically distributed systems with replicated state. And actually, I am leading a small team of 7 people, and we are looking at programming abstractions as well as language implementation techniques for distributed and concurrent systems. And there is also a part of the group that works on tool support, and specifically about debuggers and dynamic analysis tools. But today I'm going to only focus on the language aspects because that's the main core of this workshop. So before I can explain you what we are looking into, I want to backtrack a little bit to the late 2000s. That's where I started my research, because many of the things that we are looking into actually got motivated as well by the experiences there. And I worked, my PhD was conducted in a research group on the project of a language called Ambient Talk. And there we were looking into how to program distributed applications that will be wirelessly connected, will run on mobile devices or on fixed infrastructure, will be collaborative, and basically will have to store data in a decentralized way. So the scenarios that I am talking about that we were programming is like this little demo, where basically what you see, it's a demo that we gave at CES in 2012 as a result of the research, in which you see, well, it's a poker application in which a number of devices are going to collaborate. And the bigger device is going to become the poker table, and the rest of the devices are basically going to join this session. Well, it's a game because it's fun. So what you see here is that there is a QR code on the table, and then there is a device which is going to scan this QR code. It's going to join this adult network that is being created by the tablet, and basically that allows to start playing poker. There were colleagues doing fancy stuff on the user interface. That's not so important here. The nice thing is that you could basically run this without cloud infrastructure. You could pass via NFC the credentials for the network to join the poker session and then collaborate. So by building these kind of applications, actually, what we had is like we wanted a high-level language that will facilitate the distributed aspects and the collaborative aspects, and try to hide as much as possible about things like the networking layer. So it's not really important that you look at the syntax or that you like it or not. The thing is, like, the programming language has high-level constructs to be able to discover other devices nearby. So for example, you could export an object with a given type tag that's, well, this is just like something like an empty Java interface. And like this, the interpreter will actually have some mechanisms to see around other kind of objects that you will be able to discover also in a high-level way. So you could use a whenever discover, this kind of type tag, and then basically start a collaboration between different devices. So the idea was that in this setting, all the operations that will go through devices will be asynchronous, and we had kind of special semantics for partial failures. Partial failures was a given for us because basically you are running on a wireless network, and because basically it was in a very ad hoc manner. And the thing is that at the beginning, well, all the data was stored at the owner, and then you will communicate asynchronously. But as we start building more and more applications, what we saw is that there was this need to basically have the data decentralized on all the devices, and we did have kind of some highly available objects. We also move as well to look, yeah?
Sorry, what programming language is that?
Ambient Talk. So this is this logo. This is still the old website. Now it's only being used for academic. So basically I teach with this language distributed programming and concurrency, but all the research artifacts we have moved on. But it is being used for basically, because it's so nice to write and convey the concepts to build distributed systems. Okay? Well, I know that maybe the syntax looks right, but you can ask me later about if you don't get something of the, it should be quite readable what's going on here, 2 devices, discover, send a ping message, and that's it. Okay, so then we started looking like beginning of 2010s, like, yeah, but nowadays you have all the mobile clients are running on the web, right, on web browsers, and then you interact with a cloud. Could we also have similar kind of high-level programming abstractions for more cloud-related environments, mobile cloud? And well, we could build, for example, a voting application for some kind of nation within a nation or region called Catalonia, where I come from, in which you will basically have different servers where you will update the votes for different parties, and that basically you will make sure that these different counters that are replicated will synchronize. We did have some highly available objects. These were called isolates. They will pass by copy. But the issues that we had there is that basically me as an ambient talk programmer, I had to manually deal with conflicts. I had to do basically all the replica management so that to make them synchronize and deal with the conflicts. And that's not really the spirit, right? I should have a high-level programming abstraction that will be able to hide some of these issues with conflicts and replication behind the scenes. That's why in 2011 we had a look, or we started having a look about RDTs. Because that's very nice from the programming perspective, because you give to the program a very easy API, or let's say familiar API, because programmers know about data structures. So if you see here, this is basically taken from Shapiro's paper, the operation-based counter. And you see a specification, and you see the implementation in ambient talk. This is only the RDT. This is only basically implementing. There is a one-to-one mapping. If you don't know about CRDTs, don't worry. But basically, there is, because the language was quite high level, there was almost a one-to-one mapping with a specification. This is one aspect, because you still need to build some software to actually make it run in a decentralized way. You need to tackle the distributed concerns. But that's ambient talk was good at, so actually what we could do is to make that this RDT, now it's going to be distributed and replicated to all a different number of replicas by actually importing a trait. So a trait as in Scala traits, stateful objects that you can mix in. And this trait actually, still in a high-level way, will allow me to take care about broadcasting asynchronously the operations, and basically use the same kind of constructs, high-level constructs, to export my CRDT with some type that some other devices could discover, and then that will mean that all the devices that discovering are actually sharing conceptually the same, in this case, counter. And then the thing is, like, we were building different kind of applications, and what we wanted is to have data structures that you can use in your concrete application. But many of the designs require a dedicated implementation for each data type. And so that is where my actual talk starts, because the things that we have been looking at has been like, how can we make simplifying the development of application-specific RDTs so that you don't need to basically have like an ad hoc implementation for every data type, and that it allows developers to easily combine them, create existing ones, and more importantly, you need to always make sure that those designs converge, that they are correct, right? But this is like the first line, and what we are also working is on actually automatically proving the correctness, or automatically proving the consistency model from the RDT implementation, because these models are proof for the specification. But what you are deploying on the systems are real RDT implementations. So we wanted that from the RDT implementation that you are building and that you will put in your distributed key value store or use directly in the application, you can automatically prove that they are correct. Then we are also looking into how can we make efficient CRDT implementations, but not in an non-ad hoc way, actually. So with departure with the work, if you are familiar with pure op-based CRDTs, to actually try to look at language implementations aspects, like, for example, memory management or network usage. And then the last two are about applying this kind of efficient CRDTs that was for CRDTs into really that it works for constrained basically environments, and that open up to new use cases, for example, to implement edge applications or applications on IoT environments. And the last one actually is some work with a master's student of Jim, which is about how could we guide collaborative text setting to converge with NLP. That, in principle, could help this kind of issue that Peter was explaining about having this automatic merge where you get the hello, whoa kind of of things. Obviously, I don't have the time to go over all this. So what we did is that I will explain you some of the results in the language abstractions. So basically in how we have been working on simplifying the development of application-specific RDTs. And then Jim is going to show you some demo that on how his research has been applied to small devices like SP32s that I have here, and he will let you play with. Okay, so let me give you a brief look into ECROS. Just a second. So, with the work of, this is work that we have also been doing together with our colleagues in Novalinks in Lisboa. And actually, if you look at where we were looking at the distributed programming toolbox, if you look at one application, most of the time, sometimes you need some part that is strongly consistent and some part that is eventual consistent. And you know that eventual consistency, you have like better performance, better scalability, but sometimes you can, it doesn't provide basically safeness warranties in the sense that application invariants might be violated. On the other hand, a strong consistency, we all know that, okay, it might be a bit easier to reason about, but it has these scalability issues. Still, some applications might need it. So when you look at the programming toolbox, we were inspired, as I was saying, by these replicated data types. This part of the spectrum, it is well known how to do it. You could use some consensus algorithms, distributed logs. And there is also something in between the two of them, which is hybrid models. And here there has been research about basically try to have a consistency model in which you mark some operations that can be done without coordination, fast operations, and some of them that require coordination, so that you can provide some application invariants. And what we see is that this work here was done more in the consistency models, and then the question was, how do we bring this into a programming abstraction that can be used by programmers? Because what I want is actually an application-specific replicated data type that it's going to be fast whenever it's possible, so not use coordination, but if it's going to break some invariants, I would like that it coordinates. And that's how we reach into studying what we called an explicit consistent replicated object, which is an ECRO, which is basically an RDT that provides a hybrid consistency model. So what an ECRO will do is that you as a programmer will start from a sequential specification. This is well known, you know your data structure, you can implement your sequential data type, and then the programmer will have to specify in a distributed specification what are the invariants that need to maintain when you have concurrent operations, so in phase of concurrency, which is what will happen when you distribute it in a replicated environment. And then the system will make sure that you get a replicated data type that then it has an algorithm behind the scenes that will uphold to basically, will try to do sequential consistency, so basically be fast and have uncoordinated operations. But if there is some operations that are going to basically create a conflict that cannot be resolved, then it's going to coordinate. So how does this work? If we start from the programming perspective, as you see here, this is not going to be written in ambient talk, but actually my student, which is a Scala lover, implemented as an extension to Scala. So what you see is that, imagine that you want to implement an application when you need a set. So you will start with implementing a sequential set. But if you put this set in a replicated environment, what you could have is that there are operations that will happen concurrently. And in this case, if you have a set have add and removes, so if you have add and removes concurrently, you will need to decide what happens when these two run concurrently. So you can either choose, okay, let the add wins, so after an add and a remove concurrently, the element is in the set, or you could choose for a remove wins in which the element will not be there. So imagine that I want to do an add wins. So I will have my sequential implementation in Scala, and I leverage it on the data types that I already know that are in Scala. So I leverage it into a set. And I will have my add and remove, and basically what you see here is that it's pure functional because basically it will return you a new set where you have added the element or you remove the element. The contains you just basically give it to the underlying set. And now he had a small DLS in REScala in which you could write the distributed specification, which basically boils down to write a first order logic formula about the invariance that needs to be upheld. So what you see here is not so important, basically the complete code, but the important part is that he will have the post conditions that specifying the effects of the operation. So you have a post condition for add, one for remove that says it should be the element in the set or should be removed. And the important part is the invariant. In the invariant is basically where you are going to decide which policy do you want for concurrency. So in this case, there is an invariant on add that says that after all concurrent operations with add, the element should be in the set. This is very important because this allows us that if, for example, an application requires a remove wins, then I don't need to change my data type. I will change my specification to add an invariant on the remove and basically say that it should not contain. So actually our conjecture was that we don't need to re-implement the whole data type, but what we will need to do is that to make the programmer think about what are the invariants that wants him that his RDT upholds when there is concurrency between operations and express them in an invariant. Based on this, what the approach does is that this is what we say it's the ECRO data type, and it will translate it into a replicated data type that you can deploy. The thing is that the specification is also very important because it's basically helping us to have this efficient data type that tries to avoid coordination. So for this, the specification is fed into our analysis tool that we call Ordana, that behind the uses an SMT solver, Z3. And what it does is that Ordana is going to try to derive some information statically before runtime about the specification. So what it does is that it will tell you which operations commute, it will tell you which operations conflict, and then what we do is that we ask Ordana, give me a conflict-free solution for that operation. So it can tell you, for example, that if you reorder some operation, you could basically let concurrency go, and you don't need to basically coordinate. So, yeah.
Of course, in some cases you won't find, the SMT solver won't find solution.
And in this case, we fall back to sequential consistency, and we use a fine-grained blocks, indeed. So when Ordana fails to find me a reordering of operations that you can do uncoordinated, that they don't lead to a conflict, then it's when we synchronize, indeed. So I don't have the time to explain you the whole algorithm. There are many other things that you need to make it really efficiency, like causal stability, etc. But the overall idea is that basically every time that there is an operation, it gets propagated to the replicas. Every replica gets a graph of operations in which there are relations between them, being like an operation happened before another one, and also with the information of Ordana. So these two operations conflict. And basically what will mean is that it will try to provide serialization of operations that require the minimum coordination. But indeed, if it doesn't find it, then it will coordinate. What does it mean that they conflict? Well, they have to uphold to the invariants. So if they don't uphold to the invariant that was put in the specification, it will be considered that then you need to coordinate. So what we did is that we tried to see, okay, can we do what it's already present there? So my student implemented like known CRDTs as ECROs. So you have like counters, flags, sets, maps. Then we also implemented something like that will be considered hybrid because you cannot do it without coordination, an RDT like a stack or a queue. And our goal, finally, we wanted to have an application-specific RDT that basically could be built with a specification. And this is the Ruby's RDT, which is based on a auction-based kind of benchmark that was used in the context of databases. And what you see is that we use it to compare with the existing consistency models, hybrid consistency models. So the Ruby has a number of operations, like place bit, close action, register user, store, and buy. And what lower means better, what you see is operations and the latency. And what you are seeing here, actually, is that thanks to, in these two operations, thanks to the analysis on Ordana, it can know that actually you have a problem with concurrent stores or concurrent registrations of users only for one user. While the previous analysis, they were actually requiring a log for all users. So because we can only detect that it's only when it's this operation, when the argument is the same, it's a problem, then we could reduce because we use more fine-grained logs. A log for one user, a log for one item. What you see here is that actually Ordana tells that I can find a reordering when I have a concurrent bit and a close action for the same action. Because basically it knows that it will be fine as long as the place bit comes before the close. So if in case that it got propagated the other way around, it will reorder the operation. So that's why you see that it goes down, because it didn't require coordination, while other approaches, the analysis thought, I need to coordinate these two because they don't basically commute and lead to a conflict. So this is like, as a, let's say, super burst perspective, so we are going to be around. If you happen to be next week in PLDI in San Diego, you can go and listen to the long version to Kevin, that will be there. We also have the artifact in case that you want to see how does it look like for the programmer, the ECROS, so all the portfolio of data types. And we are a bit running late, but we also started later. So Jim has the cool demo, so I should still give you the 5 minutes, 10 minutes.
Yeah, so I will try to do a live demo now. We all know that that's not always the most fun thing to do, as they always go around. But I will demonstrate, actually, I will explain in slides, some advanced set running on some low resource hardware, and let you guys play with it. But let me just connect some stuff here.
So should I give some devices or
not yet, not yet. First I will just give the presentation.
So
and,
the context of Jim's work is that he was looking into how to reduce the memory overhead of CRDTs, and what it started as being like a more academic project. Then he basically wanted to have it actually running on ESP and try to experiment with IoT. So, but you will explain what
yeah, I will explain exactly everything, but I'm just setting up before I start so that there are no surprises.
So in the meantime, you
All right.
have any question? You are already set up?
Yeah, that's fine. So as part of my research, I am trying to improve some parts of that are typically difficult in CRDTs, like how to deal with memory management, do some constraints and so. And all of this I am doing in a framework I built called FLAC. And basically FLAC incorporates some of the concepts you saw earlier from ambient talk, but then in a TypeScript setting. TypeScript, assembly script, with the idea of that I will be able to compile this to WebAssembly or use it in a JavaScript VM. So very similar to what Elisa showed earlier, you can create a ping pong example where you can do an export of, let's see, get my mouse, where you can do an export of a particular object, and you can discover this object on another node. You can get a for reference to this object, and then start performing asynchronously operations on this object. And this makes it very easily to do network discovery of devices without that you have to think about the underlying layer. Now, the interesting part of the framework here is that I have this host platform in place where I can change the communication layer. So I have this concept of channels in my framework, which can be replaced. So for example, here I'll use UDP, but you can use TCP. I have an implementation with MQTT for hardware. So these channels make it sure that this platform can ideally run on different environments, devices, systems. And on top of this, I have built actually a CRDT layer, so where I can build CRDTs, experiment with CRDTs, see what happens when I change the network interface, etc., etc. But so I have here two simple examples in my language to create, in my framework, to create a new CRDT, you'd create a counter CRDT, for example, here, with a particular tag. This is automatically linked with all other replicas in the network. They will discover each other. You can set some update handler, which makes that a callback will be invoked when they get an update. You can perform some operations. And here I have an add-win set, so a set which upholds add-win semantics for concurrent updates. Again, I can set some update handlers, do some stuff, but I'll show that more in concrete with an actual implementation. So I'll give a demo where I'm using the M5 Stick C platform, using and this uses an ESP32, which is a very commonly used IoT platform. It has a 240 megahertz CPU, 520 kilobytes of RAM, a bit of flash, Wi-Fi, Bluetooth, and a small display. So the application we'll show is running FLAC in a VM. Actually, it's running on duct tape, which is a small JavaScript, very lightweight JavaScript VM. And GUI itself, which you will soon see, is written in C++. So basically, the application is really simple. I have a list where I could keep colors in. So just to get this working, I instantiate a new add-win set on a particular tag name. So that means these devices, when I start them and they have the same tag name, they will link with each other. I can set my update handler, which will call update display, which actually calls back to in the end, to the C port. When I have a new replica, I call the blink LEDs. So maybe you saw some LEDs blinking here around. It's because they discovered each other. In the end, the C port calls the onUpdate handler, which adds just to my set. So this is the code without the GUI part. The device that I will be handing out soon is basically you have a very simple command prompt where you can add colors. So for example, I can add here a color, and you just saw it blink. So I have a visual representation on a LED strip as well on another device without the node. But yeah, it's red because I added red. But to prove, I will show that I can add blue as well. So the thing is that it's a very simple add-win set running devices. It's using UDP packets to broadcast the operations. On top of this, I have some layers to add reliable causal broadcasting and some small stuff. But the idea is actually that I could switch this to MQTT, TCP, whatever. But so basically, on this device, you have two buttons. You have one on the top to apply an action. So this would apply the add. You can press the big button to change the color, and you can long press the button to change the action. So for example, you could go to remove and then remove stuff. Or to test, you can disconnect the device, which then shows with a box that is disconnected. And then you can start adding stuff, and you can do stuff, and you will see that it will not be replicated. But once you reconnect, everything will succeed. So I will share some of these devices. If you guys want to play around, you will see the colors in front change. So I will just give it I hope that the network is long enough. I have my own hotspot because I do not trust the network here. But it's all offline. There's no servers working, so I have some more here.
You should have taken a longer LED because
yeah.
What's going to happen now?
Well, it's a set, so obviously colors can only be once in the set, so it doesn't go.
Okay, so which colors you want to get?
So you will just see the top, the first colors.
Oh. Did somebody disconnected and is trying to do?
Well, I don't know.
Do some.
You're not getting the feed, or?
Keep going.
Yeah, but so people can change stuff, delete stuff. I can, for example, remove.
Yeah. It is there.
So I remove the blue. You can see the blue changes. The colors are changing because people are doing stuff. But anyway, so what I'm trying to convey here is that I know that there's a lot of work. There's a lot of important stuff that have to be happening. But a lot of research is out there that's making it more and more easy to apply CRDTs in real time, real actual situations, even on embedded hardware, doing the memory management you need to do. And we're actually a short moment away of actually really making it practical, getting it out there, having more people use it, having more people making local first software. So that's what I wanted to convey with this demo. I hope you guys liked it. A lot of people are adding colors. So
No device crash, hopefully.
yeah, I think it's fine. On the end, I'll check if they all converge. They should have, but should be fine. But I guess this was our presentation then.
Yeah. Any quick questions?
Yes, any quick questions?
One quick question.
But we are here at the coffee break.
Yeah. Yeah, we are at a coffee break, so we can ask us there as well.
Back there, yeah?
This is right now running on the JavaScript VM?
Yeah, so this stuff, is all these devices have the Ducktape VM running, and Fleck is running the framework on top of this Ducktape VM. Ideally, I want to go to WebAssembly, so I can target more devices, and because I compile assembly script to WebAssembly, it will be much more efficient. But there are still some problems. For example, right now, there are some things with closures that are hard to do in WebAssembly, depending on the VM you're using. So it's still a bit tricky. But ideally, we have actually a platform that we can target multiple platforms with. Yes?
How much time did you spend on this project?
On this demo you mean? Or on this demo, I actually already have 2 years, and I think based on my framework, what I already had, it probably took me like 2 days to implement because I had the framework. But the framework itself is an artifact of my research, which I started as soon as I started my PhD. So that's already going 3 years, I think. So the framework now, of course, supports much more. I have stuff for handling security aspects, authorization, and so. And hopefully this will be disseminated into papers soon enough. But sorry, Elisa. But yeah.
So if people want to play around with it, are you still around for the break?
Yeah, I will be able. I can set it up there.
You can
So.
test it out locally here, and thank you very much for coffee is in the foyer. Thank you very much.
we've got Paolo Fragomeni, who will be talking about the work that they've been doing on maybe solving some of the problems that Peter outlined in his keynote this morning. So thank you very much, Paolo.
Okay, I picked fonts that everyone could read and tried to make it real contrasty and make them real big. And can everyone hear me? Okay. Okay, great. So this talk is about building web apps beyond the browser. And I noticed that, yeah, people were talking about having these needs for local first. This is me. I'm that everywhere on the internet. And this is the company that I am building. My co-founder here, Dominic Tarr. We are building a company that builds tools for a lot of the problems that we're trying to solve here at this conference. And hopefully some of them can be useful. A lot of them are open source. And a quick sort of aside, what we originally were trying to build at this company was tools for developers to deploy, and really to deploy things beyond just the data center. The data center is expensive, and we wanted to build tools that didn't have a backend at all. And we found that that was possible. We found that it was possible to build backends without infrastructure as a service. And we did that using peer-to-peer. And so the open source that I'm going to present to you today, hopefully that'll enable you guys to do the same, and then apply the protocols that you're building and iterate quickly and all of that sort of good stuff on top of some of this. Okay, so the problem. This may be an oversimplification of this, but building software is hard. And browsers made it a lot easier, and now that's really the popular way to build software. People are building software as a service. And unfortunately, as I'm sure all of you are very well aware, software as a service is a very dark pattern. It's oriented towards rent extraction. It's expensive. It's incredibly expensive. It's expensive not just in DevOps, hiring, time spent, debugging, all of that. But cloud also hides bad code, really terrible code, malicious code or poorly written code, and bad behavior. So obviously, like, we're all kind of interested in, well, what are the different possibilities? Maybe we can move away from this model, and maybe the thing that drives us away from that is the cost of infrastructure as a service. But most importantly, the browser really is the biggest problem here, because the browser has a core assumption of client-server, and this makes it really incredibly difficult for us to build things that aren't aligned with that. The assumption makes it nearly impossible to build local first, peer-to-peer types of things. So the prediction here basically is that building apps beyond the client-server model advances the web. I think that there's a lot of arguments that say that client-server model is really kind of an oppressive regime. So the overview of the problem-solution space, again, a little bit oversimplified, but browsers are the best for building user interfaces. And this is all, pretty easy to verify that this is an objective truth. It's got the biggest community. Its comprehensive documentation is really unparalleled. Like, there's really nothing documented as well as the web. And you've got all the FANG companies, all the big companies are really truly invested in it passionately. They spend a lot of money. Developer advocates. Everybody's bet on the web. And really, it's the most popular way to build software. And the developer consensus essentially is that the web is the least bad platform. But also, browsers are bad at everything that isn't client-server, right? We have this completely, asymmetrical networking stack. It's optimized for client-server, so you can't bind, right? On a server you can bind. You can listen to a port. There was a Bluetooth proposal and it really never shipped. You can go on MDN, and there's this great like JavaScript proposal for very, very, very ivory tower, very well thought out Bluetooth proposal. It only works in Edge, which is really interesting. But then the only other real option that you have for a local first networking story is local host server, which is an incredibly technical ask from users, and it's just never going to happen. You're going to get users to install an application for some specific domain thing before you're going to allow before they're going to be willing to spin up a server, and that's a very niche sort of thing. And of course, like peer-to-peer is great, but when you have routers that are restrictive, you have a really hard time connecting locally because they need to go out and talk to relay servers or introducer servers. So some people might say, well, why open a pull request on Chrome or something? Well. This is surprisingly political, making contributions to browsers even though they're open source. And we could put on our tinfoil hats and we could start talking about how if your business is an advertiser and you make your money by selling ads on a web, then client server is ideal for you. And I won't pursue that line of reasoning because Google will send somebody to murder me. Okay, so this is a really interesting kind of answer to maybe it was unintentional to this problem, but the web view is a component that ships across all of the operating systems, mobile operating systems and desktop operating systems, Linux, Windows, Mac OS, iOS, and Android, and it's consistent across all of them. So. In fact, what's really interesting here is, if you've got a Mac, what you can do is you can run these commands in your terminal, and you can actually right-click on the operating system, and you can actually start to inspect elements. And what you find is a great deal of Mac OS is actually built using this component. And so you can see over here, here's the web inspector. And here's some element that I'm looking at, and here's kind of dimensions of it, and so I'm digging into hacking my operating system. You don't really need to do this with Linux because you can look at it and you can see where they're using the web view because it's all open source. And with Windows, it's also pretty obvious where it is. You can use something like Frida if you want to instrument Windows and see where they're using WebView because they're using it everywhere. Windows is actually the operating system where people are using they're using the web view to build almost every component of the operating system. UI, in the UI. So this is a very widely distributed and well-supported component. But it's not the answer to what, okay, well, cool. Now we can build native apps using web. Okay, well, there's one other thing that's really important, which is being able to connect things together and being able to have I/O, being able to write files, being able to do these types of things from JavaScript. We lost the. Could that be?
It's my fault.
We lost the projector. Yeah.
Local first networking works great every time.
I think we're back.
Okay, here we go. So looks like there's a time limit on that thing because it's the free version. Okay, so the first step is we have something to build user interfaces with. The next step, something that we really need is to be able to do I/O. We need file I/O to do local first. We need we need potentially TCP and UDP so that we can do peer-to-peer, and we also we'll also need some other things for doing local networking, like Bluetooth, but that's not in libuv. So with libuv, we get this very, very stable, really well understood library that's very small and it's entirely portable. It's portable across all these platforms. So so the solution for us, our perspective on this is bind these things, put them together. So, Node.js became really popular 10 years ago because what it did was it allowed people to build, write scripts that, did asynchronous I/O really well. And so, that sort of applies here in a sense. We have JavaScript for building UIs, and we also want to be able to do I/O really well. And so this SDK that we've created, which is really oriented towards this, is based on some prior work that demonstrates this is an idea that people are into. They like this idea. Electron was really bloated. It was really, it was the first try. It wasn't that great, but it proved people were interested. PhoneGap, really similar. It's, I think, like older than 15 years at this point. But, people were interested in this. Then you have some new projects like Tori and Neutralino, but these are sort of things that became somehow more complicated than Electron's code base already. And so, we looked at this and we said, well, what is the absolute minimum amount of glue that's needed to take libuv and to expose those methods in JavaScript, and then add some polyfills like Bluetooth, so that you could do local discovery, and then whatever you want to do after that, whether it's like establishing some TCP connections or some UDP connections and hole punching and doing peer-to-peer stuff. That was the idea. So so we have a real-life product that uses this library, and if anybody's interested, it's right here. You can download it, you can try it, and one of the sort of interesting and sort of fun things about it is that there's no backend. So the product is a tool that allows you to do some fun things with AWS, like deploying serverless functions and a file explorer for S3, and it adds some real-time collaboration features on top of that. We didn't want to run a service around this, so what we did was we built that whole kind of like layer in peer-to-peer. So I thought what we could do is we could actually look at some of the code for this, and to just sort of show you what's going on in it, why it's so simple. Okay, so there's a repo that I have here, which is. Can everybody see this? Okay, maybe I can make the font bigger. No. Or small. Maybe I'll make the font smaller. Is that a little better? Okay. Cool. Okay, so there's this is all open source on GitHub. So there's some React as example. There's a iOS example, and so far we're just kind of working on the documentation and examples for this. Documentation is kind of just getting started. Sort of explains some of the basic stuff here, and there's also a comparison if you're sort of interested in. Or wait, that's not what I was looking for. There's a framework comparison. So if you're kind of interested in looking at some of the other frameworks and how they compare, this is one comparison, which is just lines of code. And what we're optimizing for is maintainability and readability. So I think that one of the problems, especially with things like Electron, is they become very complex, and it's really hard as a stakeholder in your project. You have enough problems with your specific problem domain. It is enough to think about where investing in a framework that's really complicated and you can't possibly understand it. That's really stressful. So we wanted to make this as small as possible so that people could feel better about using something like this and not worrying if somebody gets hit by a bus that it'll never be maintained. So that's just a little comparison about, and there's some examples on GitHub here. So you can explore kind of how to build some of these examples. Okay, so what we did was we tried to make sure that there was as little invented, as few new things as possible, so less to learn, right? So in the examples here, for instance, the layout of a project is, you can use whatever you want. You bring your own framework. In this case, like, because it's JavaScript, we used NPM. It's a way to organize modules, but you don't have to. Use whatever you want. It's just JavaScript, so bring your own framework. There's a configuration file, which has a few things that are that you'll want to specify: the name of the app, the versions, things like that. Really simple. But here's the source. This is what's interesting. So this is, you could have console.log in this file, and your app will start. There's really nothing that is expected. There's no real nothing interesting, which is, I think, really important. So here's our command. There's a couple of different options here. This is it. Okay, so if I want to run this example, I'm going to do this. So it runs my user build script, and then it compiles it, and then here we are with some different test buttons and different kinds of things, and have some UI. So one of the things that Electron can't do, and there's web browsers can't do, is drag and drop out of the browser. So what we did is we made the ability to drag and drop out, and then also the ability to drag and drop in. And so this demo code here doesn't really do much, but we wanted to kind of fix a lot of the problems that we saw with Electron, but also with some of these other frameworks, and give people the essential things that were important for building applications. So similar to iOS, there's some things that were missing, right? Bluetooth was missing. Bluetooth is a little bit hard to test because you can't test it in the simulator. Okay, what else is there to say about this? Yeah, so things like this work, right? Opening links and all this stuff that you would expect from something like Electron, except the difference is that this whole binary, after it's packaged, if we look in the dist directory here at the bundle that it created, I'm not sure how many of you are familiar with Mac OS applications, but this creates a really incredibly small bundle, very, very, very small. This bundle mostly consists of, and actually, if we use okay, so never mind. Okay, there is a way to make this binary much smaller, actually. Question?
Yeah, slightly confused. So like Tori, you're using the local web view that's present in the operating system.
The one that ships with the operating system, yeah.
All right.
Yeah. Unfortunately, with Tori, you need to learn Rust and use Rust with the backend, and it also doesn't support mobile, and it's also orders of magnitude more complicated, just in terms of its code base. And that is a really important value for us, was shipping a code base that was really, really, really small, code golfing, few keystrokes as possible. Okay, so yeah, of course.
Is that binary statically or dynamically?
Statically, yeah. Yeah, okay, so that's this example. So that's a desktop example, and then here's a oh, I want to do that with the simulator. it worked. Okay, cool. So here's a this is all just built with HTML, really simple. And I would really like to demo Bluetooth on this, but the simulator doesn't support Bluetooth on the Mac. I don't know why. But basically, like, there's a bunch of interesting opportunity here. And I'm on a Mac also, so I'm not doing Android, but the Android branch is on the way. And it's sort of in QA at the moment. It's kind of all in QA at the moment, but it's working. We're shipping a product with it, and there's just a bunch of really interesting opportunities here for building a whole new class, really, of applications that get away from using infrastructure as a service as the back end of what you're building. So yeah, in summary. The web view component provides the web stack on every platform. We bind it to libuv with the most minimal amount of glue, and I promised to actually show you guys some code from that, and I wanted to do that really quick. And so if we kind of look at the code base for this, we start off with and this is basically just accepting some arguments and constructing, an initial window, and then in the case where it's a desktop app, it will spawn a child process, and that process will communicate over std error and std out. So you can basically just communicate with raw strings. And if you want, you can build a protocol around that. We have one for Node, we have one for Zig, we have one for Rust. And so you can write any backend that you want. And so this really keeps it flexible. And so this file is really just kind of setting up the communication between those two things. And so you can kind of see was there some sort of command that was sent? Yes, it was title. Okay, I want to set the title of the window. Really simple. And we isolated all of the libuv stuff so that it could be used across platform, right? So we want to use this on iOS, and we want also to use this on Android. So we wrote this just in completely encapsulated, and this whole file is only 1,700 lines, and it provides basically most of the almost all of the same high-level APIs that Node.js does. So it's really conceptually easy to understand. You don't have to understand handles and all of the various libuv-isms. You can just sort of dive in and say, oh, okay, here's the Node docs. It works just like that. The pattern is pretty easy to understand here. So, you have a libuv, for example, UDP read start. Well, in iOS, the way that this is, so for example, I don't know, UDP send. So, TCP send. So I don't know, one of these. In iOS, obviously, you have the UI thread. You don't want to do work in that thread, so you dip out of that thread. You talk to this core, and then TCP send using the values that you were sent across the bridge from JavaScript, and then respond with JavaScript, or respond with a buffer to a XHR request, actually, which is how all this communication happens. Actually happens over XHR that's intercepted. So the XHRs, they actually never do a network request. So the web view, it has a method where you can actually communicate and eval JavaScript or eval UTF-8 strings. But this doesn't really work for byte arrays. So what we learned was that we can pretty much polyfill any node module to work on iOS by using blocking XHR requests. So this sort of emulates the sort of blocking run to completion semantics that V8 bindings have, right? Which is that, it's sort of blocks JavaScript from executing, and then so goes and does like some syscall that's actually asynchronous, and then comes back and does some magic, modifies some scope variables or whatever. But with XHRs, we're able to actually emulate that exact behavior by making them blocking or asynchronous, and then that's how we are able to pass byte arrays back and forth. So you have uint arrays, which is something that I don't think that the other platforms are supporting either. So anyways, that's a little bit of the code. That's a little bit of a walkthrough there. So the summary is that we have WebView, and we bind it to the to libuv to give you I/O, and then implement Bluetooth to give you local area, so that you can discover other peers locally if you don't have any other options. And of course, it's WebView, so you can do things like fetch. So you're not excluded from the world of client server. So if you want access to the repo, what we're trying to do is we're trying to kind of onboard people to get better quality feedback in the sort of phase of open sourcing it. We'd love for people to jump in and kick the tires on this and try it out and give us feedback. Because basically, we're just going to open it completely after, I don't know, a couple of weeks. If nobody's got any really big complaints, you need to add this feature or else it's just totally worthless. We're super happy to hear feedback like that, and make sure that we're taking into consideration people's needs. So far, we've been able to run some peer-to-peer frameworks on top of it and been successful with that. And some of the people working on those peer-to-peer libraries are like, hey, we need this or we need that. So I'm sure there's some people in here working on some open source peer-to-peer libraries or things like that. And if you have requests, then we're happy to take them. So that's it.
Adam, maybe you want to start setting up already?
First of all, nice, cool to see. My question would be, how, because from the code examples that you showed, it seems like you don't have the concept of separated contexts, right? Because that has been very important for us with Power, is that you separate context based on permissions, so that the WebView, which is problematic security-wise, never has that amount of privileges.
Yeah.
Is there anything you have
Yeah. So CSPs are super important. That you prevent any kind of code that you've code signed that's bundled in your package from trying to communicate with anything that it's not supposed to. So CSPs are the biggest. It's really the intent of how the web was designed, right? It wasn't really designed to have a lot of these new things built on top of it without consensus, right? CSPs were the consensus. So that's the sandbox really that we're looking at. Just try to basically make everything as web as possible.
I might have one quick question while we're finishing the setup. So you mentioned wanting to support various peer-to-peer protocols, and I guess libuv gives you the ability to send and receive UDP packets.
Right. Yeah, we expose TCP and UDP.
Right.
And Bluetooth. Yeah.
So how do you? What's the story beyond libuv? So what protocols do you see yourself using there? Is it?
Yeah. So we've been kind of experimenting with libpp and with Hyperswarm. And so both of these things are possible. It's just getting them to work so that they're tested really well. That's a whole job in itself. It's easy to make a little test and be like, oh, this kind of works, and then but then the thing after that is making sure all the tests and everything kind of passes. That's a lot of work. So
yes, indeed, that's what we found as well, trying to make these things work.
Yeah.
Okay, so thank you very much again to Paolo. Next up, we've got Adam Wulf from Muse. Peter mentioned Muse briefly already in this morning's talk, so it's a spin-out from the Ink and Switch Research Lab, into practice as a commercial app. So I look forward to hearing from Adam.
Yeah, thank you very much. Thanks for inviting me. I'm Adam Wulf. I'm an engineering partner at Muse, and I'm really excited to share kind of the bit about what we've done over the past around a year of creating a local first sync within Muse. But first, let's start and just understand what is Muse. Muse is it's a nested spatial canvas for your ideas. You can zoom in and out of boards, out of cards. You can pull in PDFs. You can pull in images. You can pull in text. It's really for kind of the messy middle part of your workflow. So as you're thinking through the problem, as you're still collecting information, how do you process that in a nice way? Who is Muse? We talked a little bit about this before. Muse was born out of the Ink and Switch research lab by Adam, Yulia, and Mark. Pulled it out first. Leonard and I joined a little bit later, and then Linda has joined us most recently just over the past couple weeks. But importantly, just over this last week, we have actually launched local first sync within Muse. All of your data exists inside of your iPad and inside of your Mac, and it's synced through our server, which I'll talk about. The past week has given us over 10,000 devices, over 1 million scopes. I'll talk about what a scope is, but a scope is essentially a document. You can think of that. 60 million packs. A pack is basically a record. We'll talk a little bit about that. But there's a lot of data and a lot of traffic that's already gone through that just over the past week. So to start off, I want to talk about the user experience. Marcin actually mentions here that one of the best things about Muse is not just sync, but that the progress bar in sync. So much of what's frustrating about cloud software that Peter mentioned earlier is the spinner. It's the I'm offline. It's the am I up to date? Why am I not up to date? What's going on? And so building that visibility in gives confidence to the user right up front. They know what we're uploading, what we're downloading, how much is left, what the process is. We have this debug UI here, which gives a lot more information about what's going on kind of behind the scenes. So it helps us debug what the connection looks like, but also gives the user even more detail about what's going on. But that's from the user perspective. What about the developer perspective? When we started working on sync, one of the most important things for us was it needs to be fast. It needs to be really, really fast. And that's two types of fast. There's real-time collaboration fast, where I have two devices open or there's two people using. I edit something and they see it right then, real-time fast. The second kind of fast is I just bought a new Mac. I just bought a new iPad. I want to get my data on it. And syncing the entire corpus down, all of the user's data, also needs to be really fast. And that second kind of fast has a lot more to do with the size of your data than it does about your network transfer. And so we needed to think about both of those things. Second, it needed to be simple as a rock, because I'm as dumb as a rock and I've got to program it, right? So the simpler we can make the data and the data model, the fewer bugs we're going to have, because all of the developers understand what should be happening. So our code can be very, very clear and concise. Third, language agnostic. We're currently all Swift. So our iPhone, iPad, Mac, everything is Swift. Throughout this process, we also wrote a JavaScript client. So we do have two language clients that are connecting to our sync, and that can work because we have aspirations for the web. We have aspirations potentially for Android. We don't want to lock in with our technology. We want to make sure that we have a broad possibility in the future. That said, because we are Swift, we need really good Swift support up front. That needs to be number one. And of course, we want it encrypted. The benefit of local first is the user has all of their data, and keeping that data private is a big piece of it. We have not gotten to the encryption yet, but throughout this entire process, we have built for and designed for encryption. So that's going to be the next piece that we're going to be building. I'm going to talk a little bit about how that's going to work over the network. But first, let's get into it and understand what does it actually look like? What did we build, right? This is a very brief diagram of what our data is structured like, how our data is structured. We have scopes. A scope is essentially a sharing boundary. Objects live inside of scopes. objects are built out of attribute value pairs, and that attribute value pair is where the CRDT lives. So all of those things together, the scope, the object, and the CRDT, that uniquely defines a particular register. And right now we're just using last write wins semantics. So we have a hybrid logical clock inside of that CRDT. So as new changes come in, the most recent write wins, that's it, right? It's actually pretty straightforward. But it's even more simple than that, because it's not just attribute value, but it's attribute one of 6 values. We only support 6 value types inside of that, that register. It can be a bool, it can be an int, it can be a double, a string, a data blob that are around kind of less than 100 bytes long, or a Bezier path. And out of all of these, the Bezier path looks kind of strange. It's a bit of an oddball. But because handwriting is a first-class citizen in Muse, the Bezier path is a nice, concise way to describe what that ink stroke looks like. So it's important to have first-class data representation for that. And here you can see what one change looks like. Every change is atomic, and so we call these things atoms. And this is one row in the database that lives on the device. This is one atomic change in this device. You can see it has the scope, the object, the attribute, the value, and then a few extra fields for our clock. The most recent item wins. The database is filled with rows exactly like this in one gigantic table. So I can easily query and say, give me all the objects in this scope. Give me all of the attributes for this object. Give me all the objects that have a value that matches this thing. So it's very easy to query and very simple technically to understand. This, of course, has just one value, but we have compound types as well. Here we see a color, but because we have no, just one second, because we have no color. Yes. I can zoom in a little bit. Does that help? But because we have no color type inside of our CRDT, we actually serialize a single color out as 4 different values, the RGB and opacity value. And so more complex types are built from less complex types, which are built from those core 6 types. And that's it. So how do we transfer these? We have a giant list of atoms, a giant list of edits. What we do is we bundle those up. Currently, we just encode those into an opaque binary blob. In the future, we're actually going to encrypt that opaque binary blob. We package that up in a protobuf object and send that over a web socket. So what the server sees 2 bits of information. It sees the device ID that sent it, and it sees the scope ID of the data that was modified. But it does not see the object ID, it does not see the attributes, it does not see the value, it doesn't see any of that. It only sees device and scope ID. And that lets the server know, oh, this came from Adam's device, I'm going to send it to Adam's other devices. Adam shared it with other Adam shared it with Mark and Yulia, so I can send it to those devices. And it can determine that based on just those 2 device ID and scope ID, and that's it. So the server sends those down, the receiving device unpacks that blob. It now has a list of atoms that it can apply to its database and updates its in-memory objects with. Peter alluded to this in his talk. We actually send data in 3 different ways. We have durable changes. This is when, if I'm moving a card across the screen and I drop the card, that card's new location is a durable change. As I'm drawing ink on the screen, when I lift my pencil, that new ink stroke is a durable change. That's the only thing that gets sent. But if I have 2 devices open, looking at the same document, and I draw, it sure would be nice to have that real-time information show up on that second screen. So that real-time information is sent in essentially the exact same package. It's those atoms, they're bundled up into an opaque blob, but this time they're sent inside of an ephemeral box, which is sent over the WebSocket to the server. The server knows, oh, this is ephemeral data. This is supposed to be real time. I'm going to send that out and make sure that's priority and send it down to devices. So now devices get real-time updates of those ephemeral changes, and we can see that. But the device actually just applies that to in-memory, but does not persist it to the database. It only persists durable changes to the database. And that lets us save a lot less information because it's not useful to have every little moment of my ink stroke saved permanently for the next bajillion years. I really only need the final ink stroke saved for that time. The last kind of data we send is file data. It's blob data. And for this, it's a bit of a handshake between two. The client creates an identifier that represents that new file, and that identifier is saved as a durable change as one of the attribute values. And so devices can see, oh, there's a file coming. There's some metadata associated with it. The file metadata is saved as durable attributes inside of our CRDTs. But the file blob itself, that blob ID sent to the server handshakes with S3, sends back a secure URL, and the device uploads directly to S3 eventually. That can go slower, it's not as urgent, it's okay if that doesn't happen exactly immediately. What is important is that the metadata and that devices know there's a file coming, but it doesn't need to be sent exactly in the next 3 seconds. Some files might take hours to upload if it's a particularly large file. But as part of the metadata, we also send a blur hash. And so as the user is uploading an image, maybe it's a gigantic image, maybe it's a huge PDF, we can actually hash that down to a very small string, save that string as part of the durable metadata, which gets synced across really, really quickly. So all of the client's devices see a blurred representation of what that file will become. Even if it takes 30 seconds for it to actually transfer over, even if it takes 3 hours for it to transfer over, it helps give the user confidence that, oh, okay, it knows what's happening, it knows the data is coming over, and so there's some security there from the user's perspective, even though functionally nothing has transferred over yet. So that gives a very brief overview of how it is that it works, right? It's a very simple data model. It's a very simple CRDT structure. But if our very simple data is very cumbersome to work with in Swift or in any language, then we've still lost. So it needs to be simple to understand, but it also needs to be simple to work with. So let's look at what that ends up looking like. We use 2 features of the Swift language that are particularly useful. The first is type extensions. This allows us to define custom behavior to built-in Swift types, and also custom behavior to our own custom types. The second is property wrappers, and that lets us define custom logic whenever we access, either for reading or writing, any object's property. So as a very quick example, we'll look at a little bit of code. So here we can see the Swift CG float type. This is just a double, it's just a number. And so we implement 2 things. The number now knows how to create atoms for our database. It also knows how to read a double value from a database row, essentially, from an atomic changed row, right? So that's very easy because, of course, our CRDT can store doubles. Sizes, we can't store a size in the CRDT. It's composed of 2 doubles. And so the size creates 2 values, creates 2 atoms, and can read both of those atoms to create a size, right? And of course, we can keep going down the rabbit hole. A rect is built from a point and a size, each of which are built from 2 doubles. And so we can create more and more complex types that are built from less and less complex types, that are built from everything eventually comes down to those atomic changes in the database. What's also nice is that even though we're only saving doubles, ints, strings as the value, we can still store references between objects. So to store a reference between object, every object is uniquely identified by its scope ID and its object ID. So I can store just those 2 attributes as 2 atomic values inside of an object. And then when loading it, I actually ask the context to load the object for me. And so I get essentially free object references with a CRDT that knows nothing about Muse, it knows nothing about objects, it knows nothing about our structure, but just storing this metadata, we can still create relationships between all of our object types. Property wrappers, very simple thing here, but because it's based on type extensions, we get a generic type here of value. And so this property wrapper is written once, but it applies to every single type that can be stored inside of our sync layer. And so that generic type can just ask, hey, load the value. And that calls in whatever the specific type is for this property. It's able to load it from atoms. Same thing down here for the setter. It's just a generic type, but it knows how to create atoms for our database. So it can create those rows, save them into the context, and we're all finished. And so these two things together make it really, really easy to interact with kind of the SQLite database is what's storing all of this stuff. You have these atomic rows. You have a Swift type that's maybe built from 4 or maybe 14 different atomic rows. That's really cumbersome if we have to do that by hand. But because of those two things, you can see in our pre-sync world here on the left, this is what core data used. It has a little attribute here that says this property is managed by core data. We can define that class however we like. We can then instantiate them and then set them just as we would with any other Swift type. We just use the object. No big deal. The exact same thing is true inside of our sync world now. Even though everything is powered by the database that creates these small atomic rows, from the developer's perspective, as we're building inside of the Muse code base, we're actually just building regular Swift objects. Nothing changes. The Swift developer doesn't even know or care how sync works, what happens. It's simple so they can understand it if they need to or want to, but the Swift code itself is actually really easy to use, and it's almost completely transparent to the developer what's actually happening behind the scenes. And don't take my word for it. Every developer likes their own code, but even my coworker, Yulia, has appreciated that it's nicely abstracted and it's easy to use. It's not a mind bender to get your head around. So that's the Swift user experience. So now we can kind of see what our data model is like, what it's like to actually use it, what are some of the lessons we've learned in developing this, and what has it actually been like to use it. The first lesson, almost all of the lessons are based around performance, because it's a difficult thing to have your application loaded up in memory, have some sort of change come over the network, and you don't know what it affects. And so you need to update potentially anything in memory at potentially any time, which makes planning for those updates a very difficult thing. So the first lesson has very clear definitions of what your data is and what it needs to be. We have here objects in memory. This is a Swift representation of your data. That's the nice Swift type that we all know and love. We can program with it. We've used it a billion years. But that's slightly different than what the database needs, right? The database needs something that's SQL is happy with. And that's a little bit different than something the network needs, because the network's going to wrap all this stuff up in protobuf and send it over the wire. So each of these formats is slightly different, and translating between these formats is potentially expensive, especially if you have thousands of updates coming over the wire. You need to deserialize, load it up into memory, and move them from the network layer all the way over into the Swift layer. So having very clear definitions of what that data format is and when and why you translate between formats has been very, very important for us to save CPU cycles on the client. Related to that, which is true for all of this is true for almost any software you build, but having clearly defined layers in application logic has also been very important. And so the database CRDT that I mentioned at the beginning is actually its entirely own repository. It doesn't know anything about Muse. It doesn't know anything about our server. It doesn't know anything about anything. It's only worried about databases and the CRDT and the last write wins algorithm. Separately, we have a different repository that is only concerned with tying that one into the Swift language. That's where the type extensions live. That's where the property wrappers live. That's where that code survives. And then on top of that, we actually have the Muse code base. And having these very explicit layers in where the data and where the application logic lives means that when a bug shows up or when a performance problem shows up, it's generally going to live in exactly one of those layers. And so it makes it a lot easier to track down where is that bug, and once we found where it is, we can isolate and say, okay, now we only have to care about this 15% of our code base. It's somewhere in here. And it makes it a lot easier to track down and a lot easier to manage what would otherwise be a very unwieldy and potentially scary code base. The last thing that we've learned is that identifiers are extremely useful. We put identifiers on everything. Devices and users, obviously, objects, obviously, but every web request has an ID. There's a couple different layers of the web request. Blobs have an ID. And so what this lets us do is, because we have an identifier on every piece of logic and every piece of data in the system, if something happens on my Mac and I'm making an edit, and that edit does not show up over here on my second device, I can look at the logs on my iPad, I can look at the logs on the server, and I can look at the logs on the Mac. And as a developer, I can completely rerun the history and understand exactly what happened, exactly what message was sent, exactly what message was received, and exactly where the bug is. And so having these identifiers has made what would otherwise be an extremely difficult to reproduce issue much easier to reproduce. So that's been a very important piece of our development. Next steps for us is obviously to keep at it. The overwhelming majority of Muse 1 functionality has been migrated to Muse 2. There's still small little loose ends and little pieces of performance we'd like to fix and just tidying up. The next big piece, though, is encryption. We've done a lot of work and a lot of research on how we would implement that encryption, but the next step is to just physically do it and to make sure that we can have end-to-end encryption. Our server doesn't currently look at the data, but it will soon be impossible to look at your data. And that will be the best case scenario for local first, I think. The last, you might have mentioned that I talk about, we're adding these atomic changes to the database, and the most recent one wins. That's great. But that also means that we don't currently delete anything, which is a problem for the user's device, potentially. But it's a particular problem for our server as well, because we're saving all of the logs, we're saving all of the binary. If you upload a PDF, we don't currently track when you delete that PDF from your Mac. We need to be able to delete it from the server. But our server doesn't know about the data. We can't, from the server, track who deleted what and what does that object graph look like, because we don't know what the object graph is on the server. So the next important piece of our functionality is to build in that logic on the iPad and on the Mac, so that way your devices can tell our server, hey, I don't care about this anymore, you can delete it. Hey, I don't care about this anymore, that's okay, it's gone. And we'll clean up, we'll tidy up after you. A little note here, we are also hiring. And so we need a local first engineer to come join onto the team. So if the stuff that we've built or if the problems we have yet to solve sound interesting, certainly get in touch. But with that, I will stop there. And I think we have, I don't know, maybe 1 minute, 30 seconds, something like that for a question. Yeah?
I just want to acknowledge that you gave a presentation about Muse with Muse.
Yeah, yeah. That's, yeah. Yeah, thank you. Yes?
Is peer-to-peer synchronization on the table?
It could be. And that's because the only thing that matters is that both devices see those atomic changes. And how those atomic changes arrive on those devices really doesn't matter. Every single one of those changes has an ID, so a device knows if it's seen it twice. So if you send it peer-to-peer over Bluetooth or something, great. And then if it arrives later again over the network, who cares? And so that's definitely something we'd be interested in adding. Yeah?
So you build a key value CRDT atop SQLite, right?
That's right. Yeah, it's all just running in essentially one SQLite table.
So probably you can't do what Automerge is doing, for example, that you can do like shared text editing on like
Right.
fine-grained Google Docs. Have you thought about how you might do that on top of SQLite, or how you might implement that at some point? Or
Yeah, so that's a really good point, and that's one of the trade-offs we decided that it was worth it for us, because right now text inside of Muse is at the paragraph level. So if a paragraph gets clobbered, that's probably fine, and you can work around it fairly easily. But yes, having better text editing, in that case, I think we might actually end up combining a couple different options where text is handled by something like AutoMerge, just for that text piece of the object, but the rest of the attributes are probably handled by our last right wins scenario. Yeah.
We have an open source app for didactic purposes, so for a school book, in essence for shared school book, where we do similar things. And one problem that we ran into is that we very often get a request for an undo button.
Yes.
But we didn't want to implement it because what's the semantics of it, right?
Yeah, yeah.
Do you have an idea or a story around that?
Yes, so we do implement undo. Whenever I make an edit, we save what the user's previous version of that state was, right? And so I move a card, I know it came from here, right? Mark moves that card over here, then Yuli moves it over here. I press undo, it comes back to my most recent place. It does not move back to the object's most recent place, it moves back to where I had taken it from. And then when I redo, it redos where its new location is. And so that's how that undo redo semantic works. It takes whatever the current value is, pushes it on a stack, essentially, an undo stack. And
so it also undoes other people's changes as well.
In that case, yeah, it would undo 3 levels of changes, right? Yeah.
Okay,
But for me, since I'm the one undoing, it's putting it back where I took it from. So my expectation is met, even though if Mark is like, why did that move? What's going on? It's because I undid something. Yeah. Yeah.
What are the biggest challenges that you see for enabling end-to-end encryption?
Key management. Right? I mean, that's going to be the nightmare. And that's where a lot of our work, we've worked with a security firm to help us think through that process. So I haven't been as much a part of that conversation. That's been Mark, but really careful key management is going to be the trick. And that needs to be something that, as a user, ideally, I would never have to deal with. That should be magic from the user perspective, but secure from the developer and the data's perspective. Yeah. Are we done?
Can you end the screen share and then maybe take one more quick question?
Yep. I don't know how to end it. I will kill my Wi-Fi. How about that? Yes, last question.
All right. Aside from text editing, do you see any more use cases for different kinds of CRDTs in your application that you would really like to have?
So there are some data types that are maybe a bit more awkward that other CRDTs handle. So sets and maps and more structured data types that we handle by, like a set is handled by, we have an attribute and a Boolean. If that attribute is set, it's in the set. If it's not set, it's not in the set. So other CRDTs could handle that more gracefully. But then that brings the trade-off of additional complexity. And so that's where we're handling, and right now we're erring on the side of being too simple instead of not simple enough. Yeah. Thank you.
Very much. Thank you very much. So next up, we were supposed to have Stefan Kessler, but he can't be today. So fortunately, Marc Shapiro has offered to jump in at short notice. So you will probably know Marc from the seminal papers on CRDT about 10 years ago.
There's no, okay, I got it. Okay.
Concordant to commercialize some of the CRDT work as well, which hopefully we'll be hearing about in a moment, if we can get the laptops working.
Screen?
Sorry?
Blue button?
Okay, we can ventilate for a second.
Sorry.
The select screen to share button. Yes, one. Yes.
Okay.
And now I should ask you to It's the Mac security thing. Okay, this seems fine.
Okay.
There should be. Yeah, it works.
Okay. Hi everybody. Sorry, this is a little bit improvised. If you see that I'm being slow and I'm going to go over time, please tell me. So I'm going to tell you about sharing state in local first software. This is joint work with my PhD students, Benoît Martin and Laurent Prosperi, and with the CTO of Concordant, the company that we're trying to start for local first software. And I'm affiliated with Sorbonne Université, INRIA, and the Concordant company. I guess you all know about local first. I don't need to define what it is. But essentially, it's arm's length software as far as I'm concerned. And there's a programming model which is known as actors, which is well adopted. I mean, it's just consider actors are processes that are disjoint, that communicate only by messages. And in the the standard definition of actors, actors only communicate by messages and never share memory. And I contend that that's probably that last line is probably a mistake. So the idea behind not sharing memory is, well, you want each process to be autonomous, to live on its own, to be asynchronous, and not depend on other processes, and never be blocked by locks or things like that, right? And so the idea is, if I don't share memory, then I don't have any consistency problems. But even that is not true, right? Even in a pure actor system, you have things that are what actor people call glitches. And here's an example. You have these three actors that are communicating by asynchronous messages. And here you have something that's ticking every minute, right? And you've counted 24 hours plus 1 minute, right? And here you compute the date. And because you're a little bit slow, this communication is asynchronous, you're still at 24 hours, right? So you think you're still in day 0. But this guy is counting the time of the day, and he sees the 1 minute, so he thinks you're in the next day, right? And when you bring these two things together, well, obviously there's a problem. You're going to confuse users, which might not be so bad, but you're going to confuse software, right? And things are going to crash, and it's going to be terrible. And so this is, it's not a problem of sharing memory. It's a problem that you have some data that has, and there are different paths for the same data to meet them because it's asynchronous. You haven't thought through the issues, and you have this glitch problem, right? But of course, you'll also have persistent state. Sometimes, for instance, if you have some kind of elastic software, you want it to be stateless, which means you actually put the state in a database, right? And then you have your elastic actors coming up, and they're sharing this database, right? So there's a consistency issue, and of course we all know about collaborative state, which has all the problems that we've been discussing earlier, right? So there's this dichotomy, right, between sharing data through messages, or collaborating through messages, and collaborating through shared state, right? And very often you see actor systems or stateless systems with sort of a database that is a wart that's added on later and poses all sorts of problems. And vice versa, you see people who use databases and try to do, in addition, message-based communication, and again, it's a wart and it poses all sorts of problems. So we believe that you need to actually unify these two things and come up with something that makes sense, so that if I look at the system through the lens of data, it's consistent. If I look at it through the lens of messages, it's also consistent. And if I do both, it's still consistent. Right? You need to unify. So first of all, you need a consistency model. Right? And we all know that strong consistency is not going to work with local first software. You need something that will allow your processes, your actors, to be asynchronous, to live even when the network is down. But you still need guarantees, because otherwise, again, you get these glitches and you get confused software. So I contend, I don't have any proof, but I contend that the right approach here is what's called causal consistency. So what causal consistency is, it's an asynchronous system, right? So you communicate, all the processes run asynchronously. There's no locking or anything, right? And there's no waiting, right? You can always read your data or write your data, right? And you're never waiting for anybody else. But you do have a guarantee, which is things do not arrive in random order. So if event A happens before event B, and you observe A and B, you'll observe them in that order, right? If A and B are concurrent, well, who knows? You might observe A before B or B before A, but they're concurrent anyway. So, you know, if you wanted to have a strict order, you would have to synchronize, and you don't want to do that, right? So causal consistency has been defined as the strongest consistency model that is compatible with availability, that is with asynchronous computation. Okay. But causal consistency is not quite enough because, well, first of all, it doesn't give you any liveness guarantees, right? Your causal consistency allows your systems to diverge indefinitely. So you want to add a convergence guarantee to that. But you also want a stronger, so causal consistency is sort of the distributed consistency model. But you also need a local consistency model. That is, when you are reading multiple values or writing multiple values, you want those values to be consistent with each other, right? So reading consistent local values is called snapshots, right? So at some point you say, I need a snapshot, and I want all the reads that are going to happen next to be within that one snapshot, even if things are changing in the background, right? So you sort of freeze a view of the system, and you say, that's my current view of the system, I'll compute on that. Doesn't matter what other people are doing, that's my view. And at the end, you commit, so it's a transaction. You start with a snapshot, you do some computation, you commit, and all the updates that you've done during that transaction are all added atomically to the database, if I may call it that way. Okay? So you have these intervals, which is exactly what actors do, by the way. Actors receive a message, then they have a sequential interval where they can compute locally, and then they send their messages. So it is compatible, right? So I have to be a little bit more technical now. So what is causal consistency? Causal consistency is based on the happens before relation, which I hope you know about. And the happens before is based on process order. So if event E happens before, if you have some process that does E and then F, we say E happens before F. Right? So, so this means this means some process executes E and then later executes F. Right? So if that happens, if E and F are in process order, then E happens before F. But also, if I send a message, well, that happens before receiving the same message, right? Or if I update some value, some object with some value, and I read that value, well, that obviously the update happened before the read, right? And it's transitive. So if E happens before G and G happens before F, well, E happens before F, okay? So that's just happens before, okay? And what causal consistency says is that everybody should see events in happens before order. If E happens before F, everybody will observe E before F. Now, it turns out there's actually two definitions of causal consistency. One for message-based systems and one for state-based systems. And it's amazing that causal consistency has been around for 30 years, but I haven't found a definition of causal consistency that does both. Okay? So maybe I didn't look well, but I've never seen it. So causal consistency for messages is very simple. It says, if I send some message M, and later, happens before, so sending M happens before sending N, well, if someone receives both M and N, they should receive them in that order. Okay, so that's what this thing says here. Causal consistency for state is a little more complicated because if I send a message, I expect that the message is received, right? Messages are never lost. But if I update something, there's no guarantee that someone will read my update. And I actually might update the same thing 100 times before someone reads it. Right? So I have to take into account the fact that a write will overwrite the stuff that happened before. Okay, so the definition of causal consistency for state says, if I update x to value 1, and then I update x to another value 2, and then I update something else, or maybe the same thing, it doesn't really matter, right? And I read this, right? So since this happened before this, I must read the most recent value of x, and I'm not allowed to read the older value. Okay, so that's what this clause here says. Okay, so now can we unify these two? Well, basically we need to take these two separate definitions and merge them, and it's not, it takes a bit of thinking whether this is correct or not, and I'm actually not entirely sure that this is correct. So if you see a mistake in there, tell me. Basically, the message part does not change, right? The state part changes a teeny bit. That is, if I have two updates to x and something that happens after that, right? And I observe that something, well, I must see the most recent version of x. So either I receive a message that happens after this, or I do some read. Okay. So that's the unification of causal consistency. Then I said you also want convergence. So convergence is every event is eventually delivered to everybody, and that concurrent updates are merged using CRDTs or something like that. And you want transactional. So you want these intervals where you freeze the world, do some computation, and send out the result. So that means at the snapshot, basically, it's as if all your snapshots and all your message receives happened at the beginning of your transaction. Okay? And all your sends and all your writes happen at the commit of your transaction. So the hardest part, I think, here, this is very boring, right? It's an API. But actually, I put a lot of thought into this because I want to make sure that the complicated parts are hidden. Right, so I want to make it as simple as possible. So I'm very proud of this. So basically, I said your snapshot, when you start a transaction, you want a snapshot. You want to freeze the state of the world. But of course, the rest of the world is moving on, right? So you have all these states in your database, and you have all your messages, right? But at some point, you want to say, here's my view, right? So I call this view Vista, because view has already been used for something else, okay? And as I compute, of course, my own computations have to be added to this Vista, right? So I want to read my own writes. So Vistas are always monotonically increasing or non-decreasing, right? And then if somebody else sends me some updates, I can choose to incorporate them into my Vista or not, right? So I have this operator that says, okay, now take these incorporate the remote updates, right, or the messages, right? And I haven't put it here, but there should be operators on Vista so that you can say, well, I only want to, accept Annette's updates, and I will not accept Mira's, for instance. But as long as this does not violate causal consistency. Okay, so the Vista says, here's my viewpoint, and then I can run a transaction or 2 transactions or 100 transactions before I incorporate the next Vista. Okay? And in a transaction, well, I can read, and it's as if the read happened at the beginning. And I can receive messages, and it's as if, I will only receive the messages that were available at the beginning of the Vista. Right? And I can write, and I can send, and I can commit. And when I commit, my own Vista advances with the stuff that with my local computation, with my local results, and I make my results available to the rest of the world, but they may or may not incorporate them by doing a pull Vista. Let me finish. I'll take lessons. So how do you advance Vistas? Well, you have to be aware that their new updates are available, right? So you can subscribe to updates. You can say, well, I'm interested in these 3 objects, and I'm interested in messages from these 5 guys, right? Tell me when these things change, right? But of course, I cannot directly pull in, say, the new values of the objects, because that would violate change my Vista, and it would violate causal consistency, right? So I only get the information that a new Vista is available, right? So I subscribe, 2 parts. First you subscribe, and if this happens, the callback is called with the new Vista, which then I can decide to pull. Okay? Question?
Can you explain the relationship between the message and the Vista? I would have thought the messages are incorporated into Vista already.
So all the messages that are available at your Vista, yes, are incorporated, but then you can receive them.
You could receive, they're elements of the Vista.
Yes, so just like you can read data, you can receive messages.
Got it.
Okay. Mm-hmm.
You receive and send messages in the context of a transaction, or?
Yes, this is all, that's why it's all indented. It's all in the context of a transaction. Right. These things are not in the context of a transaction. All these are in the transaction.
Do you have to receive all the messages?
No, because you can have multiple transactions. As long as you stay in the same Vista, you're okay, right? What you were not allowed to do is to move to a new Vista and miss messages, because that would violate your causal consistency. Okay, so pull Vista, here it says it fails if that would cause some messages to be lost, right? If I was in a Vista and 10 messages are available, and I move to a new Vista without receiving them, I'm violating something, right? I'm losing my messages. Right? So I have to receive all the available messages before I can move to the next Vista. Yep?
I'm being a little radical maybe here, so why do you need to send and receive messages? Can't I model everything with data updates? Because messages are there for
you
sending
could,
messages.
but again, you don't need to share memory either. You do everything with messages.
Right.
It's just
kind
a lot more convenient. And we see it all the time. And again, there's lots of actor messages systems that are message only, but you actually use a database on the side, and vice versa. There's lots of database-based systems where people actually send messages on the side. Like notifications is really something quite useful to get. Okay. And actually, the implementation is very standard. The only thing you have to be careful is, well, causal consistency, you need metadata, right? So the idea is that if something happens, if I receive an event and it comes out of order, I have to be able to say, the receiving actor has to be able to say, oh, this message is out of order, I need to put it on the side for the time being. So you have to attach metadata to your messages so that you can do that. And similarly, you need to attach metadata to your updates exactly for the same reason. This has to be the same metadata because these guys are ordered at the same time. It will not work to have metadata for messages and metadata for state. It has to be the same metadata. And anything that you would do that would violate your causal consistency. So if I try if I try to read to receive a message while out of order or dropping messages, that would violate causal consistency, so that has to fail. But usually you can just delay. So if the system receives an update or a message that comes too soon, you just put it to the side, right? And you stay in the old Vista. So your local first software continues to work, right? You don't have to synchronize. You don't have to coordinate with other actors in order to have consistency. Of course, this is causal consistency. It's not strong consistency. So if you need to do things, you need to maintain strong invariance, or you need to share a bank account, and you want to make sure that you don't overspend, then this is not good enough. It's only good enough for the things that CRDTs are good enough for. So I guess I'm done. Yeah, that was the end. I guess.
Thank you
More
very much.
questions, maybe? No?
Yes, do we have any more questions from
Yeah.
So if you have your actions in one of your previous slides, and you have some action for the message part and some action for the database part, like the lady just asked, it's like you can kind of think about the data part in terms of messages. Like when you're writing to some variable, you could think like, I'm sending a message. And then I was thinking about one of the actions seems like to prevent dirty reads, right?
To prevent?
Dirty reads. I write something twice, and then something else happens, and I read. I will never read the same value, right? So I was trying to think, if you start to think about the writing and read of variables in terms of messages, what would this no dirty read mean for the message-based interpretation? That's an interesting thing to think about.
I'm not sure I understand the question.
Neither do I.
So the equivalent of no dirty reads for messages is I don't miss any messages.
Oh, interesting.
But that's already in the sort of standard definition of causal consistency. If send M happens before send N, and I receive M and N, then I have to receive them in that order.
Oh, interesting. Thank you.
Why not? Why require that the Vista receives all the messages? Why not just leave the other messages queued for the next Vista?
Because those messages would not be consistent with the data.
Oh, right.
Because you've advanced your data, and then you have these messages that belong to the old Vista.
Right.
That are still there.
Right.
Still
So you have to receive the new messages before the data would be valid. Otherwise,
of course, you can drop them.
Yeah.
That's your privilege. But
Definitely.
One observation that I make, maybe I'm wrong there, but people that tend to have worked also on formal models, correctness, invariant preservation, static checks, and so on, seem to have a preference for snapshots plus transactions, whereas other frameworks that we've seen today are very keen on having updates propagated as fast as possible, getting things out synchronized as fast as possible, using last writer wins versus causal consistent approaches. Where does the schism come from? Like, are snapshots, for example, are they really useful in practice? Or is this something that we tend to like because they are so nice for theoretical and formal discussions?
do I have an answer to that?
Maybe we keep that question for the panel later. You don't have to answer it on your
But it's a good question. Yeah. Certainly, if you do causal consistency, messages can be delayed, right? Then there would never be a delay more than you would get with strong consistency. So there's this argument that strong consistency gives you, there's this argument that with eventual consistency or causal consistency, you never know when you're going to get your update, right? But you wouldn't get it earlier with strong consistency either, right? So, I guess I'm not answering your question at all. It's, sorry, sidetrack. Which is better? I think that eventual consistency sucks, right? Because it's totally confusing. You don't know, something happens and then it doesn't happen anymore, and then it happens again. That's awful, right? I do an update, I see the consequence of the update, and then I don't see the first update, right? That's totally confusing. So users can deal with it, but software can't.
But you don't need snapshots for that, right? So that's just causal consistency.
That's just causal consistency, right?
Maybe
but
cross objects.
Causal consistency without snapshots, I think, is hard to use, but that's my own personal preference.
Maybe the question is what's the scope of the snapshot? So maybe you can define the scope. Kind of more fine-grained to get a middle ground between no snapshot.
Well, I mean,
you leave it open in your model.
I leave it open. I think you need operators on vistas to be able to say what exactly you want to incorporate in your.
I mean, this was in Adam's talk, right, where you were describing how to compose the different atomic updates into the objects, which then become visible in an atomic transactional-like way, right?
Yeah. So for us, let's say device A creates 10 updates, and device B receives those 10 updates, but in a random order, right? Device B state is only ever going to move forward because if it's going to say, oh, this was done at time 10, and I just received a message at time 7. Well, I don't care about that anymore. I'm already at time 10. And so that's how that system works on the last rate wins. Because
that works for last rate wins.
Right, but it happens to work for Muse, but I can absolutely understand there would be systems where you really want causal consistency. If I'm building medical software, if I'm building something like that, where I really have to have correct rows. So I think it just depends on the application for which one's better.
I mean,
because there's different trade-offs for each one.
I think what makes it work for Muse is that your data is almost never interdependent, right?
Yeah.
Like you can move 2 cards, and it's not like, oh, this card has to touch that card, or the position of this card is calculated to that other card. So it's okay if they, smear it.
Yeah, it is very kind of, the data is very spread out as opposed to very, very intricately linked. So that's true.
Actually, by dropping kind of messages that come out of order because they're already subsumed by others, you keep some form of causal consistency, kind of, but with holes that are not important for the user facing app, right?
Yeah.
Right.
Yeah, last writer wins is causally consistent by definition.
Yep.
If your clocks are properly synchronized.
Right. Yep.
So there's no more active discussion. I think there's lunch now.
Okay.
One thing, speaking of lunch, we will have a dinner, but we don't have much space for more participants, but we have some open seats for
The workshop on programming local first software. And just as Peter Hardenberg this morning has proposed his list of open topics and unsolved problems, I'm very happy to welcome Kuessner here from TU Darmstadt in Germany, who's collaborating with Ragnar, Mira, and Anna-Katharina Wickert, who's I don't think here. He will present his work on encrypted replicated data types in REScala, and will tackle, I guess, with this the unsolved or open problem of security and privacy.
Well, thank you for the introduction. As you heard, I'm Kuessner, and I want to talk to you about how we bring encrypted replicated data types to REScala, a project that's developed at the Software Technology Group. So let's start this talk with a bit of imagination. Let's say that you have a new doctor, maybe because you've moved to a new city and you want to get optimal treatment, so you want to share your medical records with your new doctor. So you probably don't want to print them all out and hand your new doctor a pile of paper, right? So for this talk, let's assume that we have an application that allows us to share these documents with your new doctor. So because these medical records are kind of sensitive, you ask yourself, does this mean that now I need to upload all of my medical records to the cloud to be carefully protected by Amazon? Well, for this talk, let's assume that we have a local first application that allows us to store these records locally. Now, what happens if you lose that device, or the device that you bring to the doctor ran out of battery once you arrive there? Maybe also the medical records are kind of large and you can't really store them all of the time on your local device. So maybe the developers were smart enough to figure out a way on how you can store these records, how you can share these records with your doctor in an indirect way, simply by handing over a key to the data. Now, you ask yourself, are these developers, or were the developers of the application distributed systems experts that know how to deal with the resiliency and privacy issues around? Well, I don't know. But what I know is that we believe that application developers should not need to be distributed systems experts to write these kinds of applications. And this is where REScala comes in. REScala is a functional reactive programming language, or rather a language library extension to the Scala language. And the functional reactive approach works really well with integrated distributed programming. So for this talk, let's just look at enough of the basics of REScala to understand the extension that we made. So at the core of REScala's application model is this continuous flow of external interaction that then trigger internal state updates which result in live feedback. This is basically the definition of a classical reactive system. So because we want to here you see these REScala is based on reactive function composition, and here you have these functions A and B, and you write a system in a way where you can simply compose your behavior using this reactive function composition, which basically is function composition only with the exception that you automatically trigger updates to the function once the depending data changes. So here we have function A and B, And we define function C by simply specifying f of A and B. Now, what's most important for us is this enables us to do automatic state management and composition. So let's pretend that the blue and orange modules or functions have important state. Now, REScala needs to manage, and that means storing and replicating that state of these functions. So REScala knows this by the construction of our program, and it also knows how the state is connected. So this allows REScala to conceptually extract the application state into a single entity that you can see there. And REScala then manages this conceptual state with techniques known from replicated data type, specifically state-based CRDTs. Now concretely, let's consider the example that you have two devices and each run some part of your application. And both parts of the application make use of that orange function which carries state. So REScala knows which part of the application needs what state, and this allows REScala to do automatic synchronization of your state across the devices. And since REScala knows how these functions are connected, it can also provide you with automatically updating the changes that happened on any device locally. So this essentially allows us to provide end-to-end consistency from the interaction to the end-user feedback. This is essentially what's done by REScala. And for this talk, let's focus on that automatic synchronization. And specifically, let's see at how this interacts with secure sharing of private data. Now let's zoom out a bit and look at a practical example. You have two users, Alice and Bob. And these users have mobile devices. And they interact with their devices, meaning that the state of the application changes locally on the devices. Now, this means that we now need to send the update to the other device. So this is handled by REScala. And by sending the update to Bob, Bob can now receive the update, and REScala then merges the update into the local state of Bob's device. And the update that originated on Alice's device is now displayed to Bob. And this goes in both directions because Bob also updated his local state. The device would then send Alice the update that happened on Bob's device. And since we use CRDTs for the synchronization, we have strong eventual consistency, and also through that strong eventual consistency, because we use REScala, we also have this end-to-end consistency of the application, because now both devices provide end-user feedback and this displays the consistent state. Now let's look at a more practical example, because as I said, we use mobile devices here, and as you all know, your mobile devices are actually offline most of the time. So let's consider that in our example. Here, same users again, Alice and Bob. Now both devices are asleep. So Alice interacts with her device, which means that she wakes the device up, then interacts with the device, meaning that the local state of Alice's device changes. And then we would assume that we can simply send the update to Bob. But as we assume, Bob is asleep, so he will never receive the update. And after some time, as is normal, Alice goes back to sleep, and Bob did never receive the update. So when Bob now wakes his device up, interacts with his device, updates the state, then sends the update to Alice, same thing happens here again, Alice never receives the update. And we have strong eventual consistency here, in theory, but this is not really a practical solution, because unless both devices are on at the same time, we really don't reach anything that is perceived as consistent for the end user. Now, what's typically done is by introducing a third party into this equation. Let's call this third party an intermediary, and you see this all of the time. For example, think about Git, where everything happens offline, but you still usually rely on a central code hosting platform to collaborate with your colleagues. Now let's try to adapt our example, let's put this intermediary in the middle. Here, Alice is updated her device, and Bob is asleep. So now, after that update, we would then send the update that happened locally to the intermediary instead of directly to Bob. And this intermediary can then merge that update into the local state of the intermediary, and then Alice can go back to sleep again. Now, because the intermediary stored that update, once Bob wakes up, the intermediary can then send that update to Bob, and Bob now sees the update that originated on Alice's device, even though both parties are not online at the same time. And because we use CRDTs here, we can also do concurrent updates, and the replica would then the intermediary would then simply need to merge all of these updates into its local state, and the intermediary also knows which updates are missing on what device. So this is pretty much what we wanted, right? But what changed? Well, we introduced that intermediary. And if you think about it, in the beginning, I said you wanted to share your medical records with your doctor. Why didn't you simply email them? Well, because you were afraid that by emailing them, the email provider would then store your medical records. They might look into your medical records and put advertisement for medication directly into your inbox. So this is not what we wanted, right? Okay, so now let's try to figure out a solution here. Well, why don't we simply encrypt our updates? We could then allow only these the trusted replicas, so the end user's devices, to encrypt and decrypt the updates, meaning that now we still have the same properties, except that the intermediary cannot read the updates. And we can use authenticated encryption for that, and this means that the intermediary cannot even modify our updates. So let's apply this to our example. Here now we send encrypted updates to the intermediary instead of unencrypted updates. But this is different. The intermediary cannot merge these updates into a state because it cannot make sense of what's inside these updates. So it simply stores all of these updates in an encrypted form and then simply forwards all of these updates to all of the replicas because it doesn't know which replica has what state, what update does what, etc. Now, I think you see the problem. This really does not scale well because now you need to store each and every update. And imagine like a new device joins the synchronization, and now you need to send a lot of updates to that device. Now let's try to improve that. Let's look specifically at these encrypted updates. And what we conceptually know is that these updates, they correspond to parts of the state of the application. So what typically happens in an application is that over time we update that state, meaning that often updates subsume older updates, meaning that the state is in some sense, the newer update overrides the older updates. But this is not known by the intermediary. So the intermediary cannot really do something else besides storing all of these updates. So let's try to get around that. What we could do is simply attach a tag to each and every encrypted update. And this tag contains a subsumption metadata of the updates, subsumption metadata for the updates. And here in this example, you see that encrypted update, and this encrypted update subsumes the effect of update 1. And when we overwrite or subsume that update 1, we simply add that to the metadata or the tag that we attach to the encrypted update. So now, because here in this example we have the effect of update 1 and update 2 in that encrypted update here, the intermediary can now discard the updates that are subsumed by the newer update. And this means that the intermediary now only needs to store the minimal set of updates that are required to recompute the global state of the application. And these tags allow us to optimize our replication for different deployments, and it also can be extended to ensure causal consistency of the replication. And there's really no big downside to this because the metadata can be quite efficiently encoded, so there's no big overhead here. Now let's look at the security aspects of this. what we want is that the intermediary can only read that metadata, but not the update itself, so the state of the application, and should also not be allowed to modify it or the attached subsumption metadata. So this translates to the authenticity and confidentiality of the data and the authenticity of the metadata. And this is what's typically provided by a crypto system that's widely used and widely available, called authenticated encryption with associated data. So this sounds pretty simple, right? I can just use this to encrypt our updates, but there's a catch. Because the crypto libraries require from the end user from the user of the crypto library to provide so-called nonce for each and every encryption. The nonce is basically a globally unique number for this given key. And since we have multiple devices sharing the same key in a decentralized fashion, we need to ensure that this number, this nonce, is globally unique, and we cannot rely on coordination because we're in a local first setting. So this is really important, because if you fail to provide a unique nonce and like have two devices here, and both devices encrypt some update with the same key and same nonce, and then send that to the intermediary, the whole crypto system breaks, because now the whole crypto system breaks, which does not provide our security benefits anymore. So this non-selection is quite important because without it we don't have security, and it's also maybe kind of a hard problem because it's classically a coordination problem. Because we cannot simply have a counter where we count up all of the time, because like you have independent devices. So we figure out a way on how we can do this probabilistically so that it's still secure without requiring coordination. And for this, there are really two variables. One is the number of the replicas that we have that are concurrently encrypting, and also the number of updates that happen locally. And we should be really conservative with estimating how big these numbers should be, because replicas can be started independently, so we cannot really say, well, there are always only two in the usual, so normally. And also replicas can stay offline for a long time and communicate quite a lot, so also this should be large. So why not simply choosing random nonce? This is probably the simplest solution. However, it requires relatively large nonce spaces, and this is typically not provided, at least by AES-GCM or other widespread implementations. However, there are crypto systems that provide relatively large nonces, like the extended Chacha crypto system, where we can, like, say we have 4 billion replicas that communicate once or 1,000 times a second for 8,009 ideas. So this should be enough, I'd say. So if you cannot use that extended Chacha crypto system, you can still do a bit of trickery and figure out a trade-off. So you can conceptually use replica local counters, so that every replica has a local counter, and this ensures that locally it's unique. And now we combine that local counter with the replica ID of that, with the replica ID, and basically append that counter to that replica ID. And then we need to ensure that the replica ID is globally unique, and with AES-GCM, you can, like, if you choose 64-bit random replica IDs, you can securely start 92,000 replicas that communicate once per second for 132 years. So this should be fine for a lot of use cases, I'd say. Now let's look at how practical this solution is. And for this, we simulated a to-do list application. And in this to-do list application, in the simulation of the to-do list application, we interacted with this application, and we had 1 million interactions with updates to the to-do list entries, with additions of to-do list entries and removal of to-do list entries. And you can see that this is a typical scenario that you add and remove stuff, so your state doesn't grow over time, but it progresses over time. And here you can see that it goes up and down and up and down, but it doesn't grow unbounded. So this is what we want here. On the upper graph, you see the completed to-do entries, or the total number of to-do entries over time. And here you see how our system behaves. So how much time we need per interaction on the intermediary and on the trusted replica. And you can see it's always below 4 milliseconds in our example, and it doesn't grow over time. So there's no problem if we have a long-running application. And here, the same graph, the same upper graph again. And now here is the size of the state of the intermediary, so how many states it needs to store in kilobytes, and also it correlates directly to the size of the state of our application, so the number of to-do entries. And it's not unbounded growth, so that's practical, I'd say. Also, the size of the causality info, or the subsumption metadata, is not too large, and the bandwidth, we need to scale up 100-fold in order to make it visible. Okay, so now let's go a bit back to the beginning where I showed you that slide, and something changed, right? We now have this encrypted synchronization in the middle, but what's nice is that other than that, nothing really has changed much. So REScala allows you to simply swap out that middle part, the synchronization, and conceptually the programmer doesn't really need to adapt too much to that new situation. And this is pretty much what's this is like in some sense an enhancement for free, because we used a programming model that suited our use case. Now, to go over what I covered, we introduced this privacy-preserving replication using these untrusted replicas, and to make that secure, we used authenticated encryption with associated data, and used that probabilistic and coordination-free non-selection. And to make that efficient, we attached these subsumption metadata tags, and we showed that it's a practical solution. And what's the best thing about this all is that this can be transparently handled by REScala. So we don't need to implement this ad hoc. And if that sounded interesting to us, to you, look at our preprint that's available on the ECOOP site, and also the rescala-lang.com website. And that's it for me.
Thank you very much, Christian. Questions?
If I understand correctly, metadata is not encrypted?
The subsumption tags are not encrypted because the intermediary needs to.
So what stops me from doing a denial of service attack by saying, oh, I subsume everything, throw everything?
No, that's the part because we use authenticated encryption with associated data. This associated data provides has the authenticity property. So the replica in the middle, so the intermediary, could simply change everything, but then we receive, once we receive that modified update, we wouldn't accept it. So we cannot enforce anything on the intermediary, but we would then notice that something has changed, and we would simply discard that message because the crypto system provides us this.
By subsuming everything, I'm forcing the intermediary to throw away all its data.
Yeah, sure. If your end user device says I subsume everything, then that won't work.
You're subsuming stuff from your device, not from other users, right? I think that's.
Well, that's a design solution. So you could say that you subsume everything all of the time. That's pretty much what state-based CRDTs without any delta stuff does. Like you send the whole update, and then every update that came before that state, then. But that's only one option. Like you can always say, I subsume every update I did on my local device.
Maybe to add, you just can change the metadata if you know the key.
Yes, only on trusted devices. So if I trust you and you say I subsume all of your stuff, but you don't and you update, of course that won't work. Yes?
It's not clear to me why you need subsumption.
So why do I need subsumption? Well, the thing is, that if you don't subsume anything, or the replica doesn't see what's subsumed, it needs to store all of the updates in order to reach the complete, recreate the complete state of the application. So if you like have, yes?
You don't need to discard, right? Like I was thinking of the Git sync protocol.
Yes.
Right. It uses the tree metadata, the graph metadata to decide what to sync. That doesn't mean you check out the repo, you get the whole repo. But if you do a fetch, it just calculates what you need and sends it to you. So you don't need to throw anything away. You're just calculating the dependencies the client doesn't have.
So regarding the client, why doesn't the client fetch what it needs? Well, on a abstract level, REScala does that for you in the sense that it decomposes the state into parts, and then only the changes that are required on your local device for your application or part of the application is synchronized. But the parts of that state, they are fully replicated, so you probably could also figure out a way how to only replicate parts of that state. But then again, that's pretty much what REScala's...
Maybe to give the Git example, right? So Git stores kind of full trees, and then for efficiency compares these trees and compresses them into something very efficient. But you can only do that if you can look at the trees. So if you encrypt each tree individually, you would have to store for each version of your repository, you would have to store the whole tree, and that's just too much space. That could be like 10,000 times bigger if you have 10,000 commits in your current status. So that would be like gigabytes of repositories, and it's just too much data. Right? So it's about extracting the information of which things are out of the encrypted part and doing that systematically. And you could probably do that for something like Git. I mean, this is something like Git.
Git does, yes.
Julian?
Yeah, we actually have two questions from the live stream chat. So the first question is, what transport mechanism does REScala use, or is it agnostic to that?
Well, it's agnostic, but there are several ones implemented. Maybe Ragnar wants to say something about that?
We do TCP, UDP, WebSockets, WebRTC, and some DTN experimental stuff.
So if the mic didn't pick it up a lot.
Okay, and the second question is, why could you not just use a globally unique ID for the nonce?
So the thing about the nonce is that this needs to be globally unique per encryption. So if you encrypt two messages, you always need to use another nonce. And like that's why in another scenario you might use a counter where you simply count 1, 2, 3 and ensure that you never use 3 again then. Yeah, so it needs to be globally unique per encryption per key. Well, the thing about
add something from a security perspective in this implementation.
So I'm not sure if I understand correctly. You asked why we use nonces.
Yes, because the nonces are used now. Typically, in a security perspective, you ensure that they're associated with a particular operation you can execute. Here, a node generally can generate a random nonce, whatever, as long as it's unique to the work. So from a security perspective, what does it add?
So again, why you use nonce? Because the question is simple. The crypto systems all use the symmetric key encryption systems all use nonces, and I can't come up with a way on how to do it without nonces because I'm not a cryptographer. But all of these crypto systems require explicit nonces.
That concept of nonces they have there, the same like the concept
Well, sure, yes. You just need to have some parameter that's globally unique for every encryption. So each encryption has its own nonce.
Maybe we use the same. We just look at how to make the synchronization that you need, or how to optimize that synchronization that you need to make the nonces global. And in theory, we don't make them global, but the number of replicas and interactions that we enable are big enough to consider it as being coordinated globally. But we just reuse, so to say, the crypto system.
Yes, we didn't change anything inside. This nonce is explicit.
Thank you very much, Christian. If there are further questions, maybe you can grab him during your next coffee break. We'll be happy to answer, I guess. Our next speaker is Clemens, coming from Aarhus University, and he will present his work on local first Webstrates, which has something to do with dynamic media sharing, as far as I understood, right?
Yes, I'll get to that. So yes, hi, I'm Clemens, and it's a pleasure to be here. I'm a researcher in human-computer interaction at Aarhus University, but do research that sort of intersects with distributed systems and programming languages and whatnot. And what is Webstrates? Well, Webstrates is a web-based platform that we've developed to do research on software where real-time collaboration and also the barrier between using and developing software is thin. And it's a platform for creating software that's for more personal use, but that's also shareable between people. And what I'll do in the first part of the talk is give a bit of an introduction to what Webstrates is. And then I hope to engage you in a discussion about the challenges that there are in making Webstrates local first, something that I've just scratched the surface in. So a proper title would be with a question mark here, because I'm not there yet. But hopefully I can get closer through this talk. So in Webstrates, changes to a web page, which we call a Webstrate, and they are stored on a server and then synchronized to all clients of the same page. So here we have two browser views. Looking at the same blank Webstrate, and on the left I edit the DOM through the developer tools, and then you see these changes synchronizing between the browser views. I can add a content editable attribute to the DOM node, which will then give us a $1 or €1 implementation of Google Docs. And that's the basic idea of Webstrates. Behind the scenes, synchronization happens using operational transformations on the DOM, using the Share.js or now ShareDB framework. And the way we do that is that the DOM, or the document object model, for those that are not familiar with the abbreviation, is stored in something called JSON-ML, which is a lossless representation of HTML in JSON. And you can see an example of some HTML translated to JSON-ML to the right. Then in the browser, we use an API called the Mutation Observer API to observe changes to the document and then generate operations on this mirror image of the DOM in JSON-ML. And the backend is running in Node.js with a bad database, the MongoDB databases. So the backend is used for synchronizing state and persisting documents. I'll get back to this backend in a bit. The principles in Webstrates turned out to scale quite well. We've used it to build sophisticated collaborative software like this collaborative cross-device whiteboarding tool. And now I think Webstrates has been used in some capacity or the other in more than 25 research papers from our lab and from colleagues' labs since we published the first one in 2015 for a lot of different things. Webstrates has some interesting qualities. So it's actually possible with Webstrates to introduce a traditional application-like relationship between two Webstrates using an old hypermedia principle that's called transclusion. And for those that are not familiar with that concept, that means the inclusion of part or all of an electronic document into one or more other by reference. Okay, so what you see here is that to the right over there, you see an unstyled document Webstrate, and to the left we have an editor that then transcludes this unstyled document in, provides some styling and some tools for editing it. So here you saw I wrote some text in the abstract, and used a tool to bold the text. And those changes were synchronized over in this, this document Webstrate over here. What's quite neat with this is that the synchronization of content happens through this document Webstrate. So users can share a link to the document, but then open this document in 2 different editors that then just interoperate through the document. So let's have a Bob and Alice scenario again. So we have Bob over here, he's a professor, and he prefers a traditional what you see is what you get editor, and his grad student Alice likes a more LaTeX style light on dark editor. So they can collaborate. So here Bob edits the abstract, and the changes appear up in Alice's different editor. Now, Alice could, for instance, also use this mechanism to distribute work across multiple devices. For instance, to have a live print preview on her iPad while she's working. But you can also take this transclusion business a bit further, where you might have a figure in a paper that's in itself an independent Webstrate, and then open it on different devices with different types of editors. For instance, a bitmap-based drawing editor on the tablet that you do a sketch in, and then a vector graphics-based editor that you do the final figure in on a laptop. And while you edit it, you see the changes in the document up there being applied. This here is Alice's editor from before. And while it's visually different from Bob's editor, it's also functionally different because Alice has a small citation tool, so she can go, when she's writing in the text, she can write a keyword down here. It's not important what she writes, you probably can't read it, but she writes Weiser here and hits the cite button, and then reference to Weiser's 91 paper is added. And this actually uses another Webstrate, that's a bibliography Webstrate, that's transcluded behind the scenes to import BibTeX into a format that the tool understands. Now, you could now imagine that this guy Bob, he would be interested in having this tool as well. You could also imagine that Bob is not super technically savvy, so he wants Alice to install the tool for him. You could also imagine that an ocean or a long distance separates them, so it's not too easy to go for Alice to go over to Bob's house. So instead, he shares a URL to to his editor that Alice can open on her computer, and he gives her write access to it. So what Alice does now, it's a bit crude, it's just a prototype, but you get the idea, is that she exports, let's see if I can get this to play. Oh, I think the sharing stopped. Ah, oh no, 1 second, I lost the connection. Are we back?
Give it a second for...
Yeah, we're back on my machine. Should come back in a second. Maybe refresh the page.
Something's happening. Okay, where were I? Yes, so Alice extracts a snippet of code from her editor, opens up Bob's editor on her machine, and then pastes this in a magical area in this editor. And now immediately the tool is available to Bob as well, and he can go down into the text and write a keyword and hit the cite button, and then the reference is added to the text. So what you saw here was collaborative extension of a user interface through composition live during a runtime. And that's possible because the editor or the application is also a Webstrate, so it is as malleable collaboratively as a document is. So Alice can edit Bob's interface remotely while he is using it, in principle, for good and for ill. So with Webstrates, what's application and what's document starts to blur. So CodeStrates here is an authoring environment for Webstrates that we built that allows mixing traditional media with executable code. It's sort of like a Jupyter notebook, if you're familiar with that, but where it's also possible to create real-time collaborative applications within the notebook. Could, for instance, be an interactive physics report like here that can collect and analyze accelerometer data from a phone when you load the notebook on the phone. And then the students here, they can collaboratively program the analysis of this data in the notebook. It's still running. We've used the CodeStrates and the Webstrates platform to explore, for instance, a computational lab book for a group of nanoscientists at our university. And this prototype mixed the idea of a lab book with tools for the computational part of the research in a web-based environment. And this prototype shows how a lab book can be sort of reimagined as something that breaks the boundaries between applications and documents, and actually also sort of between the user and the developer. Now, these were molecular biologists, so they weren't so fond of the traditional computational notebook idea of seeing the code all the time. They just wanted something a bit more drag and drop, but they wanted to be able to edit the scripts. And this video doesn't show it, but it's possible to open up each of these components and actually edit the scripts behind the scenes when that is needed or at new. Recently, we've developed a second version of this Webstrates authoring environment that takes the principles of the first iteration and creates a general framework for developing reprogrammable software on top of Webstrates. So it comes with a more conventional IDE, you can sort of see it over there, that can be always opened in a Webstrates v2 based app, sort of like the inspector in Smalltalk, but also allows for easily showing editors for code inside an app. So with this Webstrates platform, it's very easy to build something like a collaborative computational notebook, and I built a Jupyter-like JavaScript notebook in less than 200 lines of code on top of this. And the stack is here. I won't go into much details, but one thing that we have built is a transclusion-based package manager in the spirit of for instance, NPM and stuff like that. Now I'll get to the local first bit in a second, but I'll just talk a bit about the latest work we've done on this, which relates to that throughout us working with Webstrates, we've experienced that it's challenging to do live collaborative programming. That probably doesn't come as any surprise for any of you, but if you actually try to do it, it is quite challenging in many different ways. It's something as basic as handling event listeners when doing live collaborative UI programming is quite difficult. Also, these kinds of things that we built with Webstrates, they kind of organically grow over time, so they turn into this incomprehensible spaghetti that's difficult to extend. And this has motivated us to explore new ways of programming, and our first foray in that direction is the VARV programming model. Here, interactive software is described through declarative rules that can be edited collaboratively and live, and where software can be changed through addition rather than modification. I won't talk much about this now, but I will return to a point about it for future work. I'll just show you a brief video. It's just a 30-second teaser for the paper that we presented a couple of months ago in New Orleans. Let's see if it plays. So here we see a simple to-do app, very original, being extended with an assignee field while it's running by adding some declarative rules and extending it with a bit of templating in HTML. And then it immediately runs. And then we can explore also building domain-specific models for instance, expressing multiplayer board games. And we also explored the ceiling of this programming model by building something sophisticated, like sort of a Figma clone in it that went very fast. Sorry about that. But in the context of this workshop, Webstrates in its current form has a significant limitation, because Webstrates is based on OT through the Share.js, ShareDB implementation, and that relies on a central server, both for handling persistence in the database and also being the authority when it comes to edit conflicts. I want a local first version of Webstrates, and I also believe that the software model of Webstrates lends itself well to it, because basically the server only handles synchronization and persistence, bit of file storage, and very rudimentary access control using external access providers like Twitter or GitHub using OAuth. So it's very application agnostic. Another way of looking at Webstrates in comparison to the idea of local first is that Webstrates is what I would call document first software. So one thing that characterizes Webstrates is that a program cannot exist without being part of a document first. And the way that you make something is your own is typically by just making a copy of it and changing it. Also, data and tools, they can coexist in the same space, in the same document, but also be conceptually separate. So for instance, in the Webstrates example you saw with the notebook, they coexisted, but they could also be conceptually separate, so you could copy a tool between two editors, for instance. Another salient point is that software in Webstrates is built out of stuff. So you first create the stuff, the document structure, and then algorithms and interaction, that's secondary citizens to the software world. And this stuff is then persistent over time and can synchronize across users and devices. Yes, and finally, what's traditionally considered applications and documents, they're shared and referenced in the same manner. So local first software, you own your own data, works with no internet connection, has distributed and collaborative functionality. Webstrates has the last, but it doesn't have the two first points. So if I were to make a local first version of Webstrates, these are some of the critical features that I'd have to figure out how to preserve. So first of all, this document first approach where everything is stored as a document in a document structure. I would have to figure out how to do DOM synchronization, so just synchronize the document structure with being oblivious to the application model. I would have to figure out how to do transclusion, and while I do that, I will reload this one. Am I back? No? Yes? Maybe? Okay. So transclusion is the premier composition mechanism in Webstrates. We have the same address space for programs and data. Everything is identified with a URL. We have history keeping using the OT log, also used for versioning. We have zero install. Everything runs directly in the browser. We handle transient as well as persistent data. So some DOM elements, for instance, for transient UI can be UI can be made transient for relaxed. What you see is what I see, so you don't have to see the same thing all the time. We have transient messaging between clients, for instance, for sharing cursors, as Pete also talked about. Some basic access control and some asset management of file storage. If we were to make this local first version of Webstrates, how would this be possible? I think actually the document first approach is very compatible with a local first approach. I don't see any challenges there. I have a running prototype of DOM synchronization using auto-merge with Martin's help. I got that to work. And that works well when you are doing real-time collaboration, but merge conflicts become very, very problematic, because when you are working on software where both the application and the user document is kind of mushed together, then how can the user ever be in any position to resolve a merge conflict? Even the programmer who might have written the software may not be aware how the document is being manipulated by the programs. So merge conflicts get very, very hard to solve.
Question?
Yep.
Is the problem discovery of change, or is the problem that it's messy and hard to resolve the change?
Also, what are the consequences of changes? Are they software breaking if you mess them up? So if you merge something in a document,
there's no undo, and you can't see what merged, and there's no way to go back. Kind of thing.
Well, you can go back and you can undo, but you still might be in a situation where you might merge something wrong, and then you have a piece of software that may throw an exception based on the way that it has now been merged, because it's not only user state, it's also application state that's in the document that can create some dangerous situations. Then we use transclusion, and there's of course challenges with remote dependencies if things are offline, and if you need to have permalinks to things, so you would need to have a local cache of everything that you need on your device. Same address space for programs and data. I don't think that's a problem. History keeping, can just use the CRDT log. That shouldn't be a problem. Zero install is also a bit more challenging. So there's the file system API was mentioned, and that could be a possibility. I have it actually working with the auto-merge prototype. It's a bit hairy to use, but there's potential there. But offline peer discovery is much more challenging, at least with the current browser model. We saw some software that might do different things differently earlier, so that could be a solution. transient as well as persistent state and transient messaging. Peter, you also mentioned that, and you worked with that in the pushpin, so that's not a problem. Access control is an open problem. It might be, you could do some public key-based encryption scheme that might work for write, but read access is something that I have no idea how to handle with that. Asset management, again, file system API to store images and videos and whatnot. So some of the initial efforts I've been doing, I have this proof of concept implementation of Webstrates style DOM synchronization using auto-merge that seems very promising. Also where the document is stored on the disk using the web file system API. So that is at least possible. Now for the merge conflicts resolution, I think I have to go in a completely different direction. And one potential is to leverage our new programming model, varv, that separates document state from application state. So in varv, you actually have you express semantically meaningful application state in a declarative fashion. And most of the changes to a document will happen within that state. So instead of trying to handle merge conflicts on a document level, you would only have to handle 99, I guess, % of conflicts within the application state that has semantically meaningful value to the user. So that might be easier to merge for end users when there are conflicts. Okay. That was sort of a quick tour de force of what Webstrates were, and then some of the thoughts I've had around making it local first. And now there should be some time for some of the questions and ideas that might arise from you. Yes, Peter?
I'm really interested in these like conflicts and problems, because this is, I'm very interested in this like CRDT for code.
Yeah.
Is this, how do you think we could solve this? Is this a better representation of the program and state? Is it better transactional semantics so that at least you have a, like a cleaner mess that's easier to reason about? Do we need like typed holes and the kind of like Hazel-Lang stuff? Like what do you see as the way forward?
So one way forward is sort of the Muse approach, where you have you fix the data model to the application model, and then it can become relatively easy for the user to handle conflicts. That I don't think that with Webstrates it's sort of more like the computational media approach. You have this software infrastructure where you can build various types of applications. And you can't necessarily fix what it is to a specific domain. This ability of creating somewhat stable domain models for the user over time might be the approach to go. Whether the user then has to also annotate it with some sort of rules for merging, I don't really know. It's a bit unclear to me. For the question relating programming, I think. That's also a very open territory. How do you how do you program local first software, and how do you do real-time collaborative programming of local first software? And you might say that the last one isn't something that you would ever want. That's true from a software engineering perspective. So if you're building systems for people, you probably don't want to do that. But if you're, for instance, working on an experimental notebook, and I'm sitting and debugging a problem as a chemist or a biologist, and I need help, then I want someone to be able to come in and program with me. Yeah.
Okay. I have interesting observations from our formal writing studies. You generally don't have simultaneous authoring, even when you have simultaneous viewing.
Right.
And in fact, even in informal or a relatively casual but serious authorship, right, like a computational notebook, a surprising number of users expressed a strong desire to work in private and share when they were ready.
Yep.
And so I think even in the case of this computational notebook, like if you ask someone for help, you're not typing while they type. You take turns.
Yeah, absolutely. Yeah.
So I think this maybe gives you a bit of an out to some of these challenges.
Absolutely, yeah. I think it's still, if you then yes, it does.
There's
yeah,
still
yeah,
problems, but it maybe changes the character.
Yeah, absolutely. And that's also what we've been experiencing. It's the same also with the collaborative writing. It's most of the time you also take turns and rarely write the same place, and that goes for writing software together and all sorts of other types of collaboration. Yeah.
Yeah, I'm interested in what you said about access control. You said that controlling write access would be easier than controlling read access. So for write access, I could imagine that you have a causality problem. And when I revoke your write access, and then you sync your writes, then they fail.
Yeah.
But for read, you just if somebody doesn't have read access, then you just don't send the messages. So why do you?
Yeah, so I have a very rudimentary understanding of cryptography and security. So the way that we've implemented write and read access now is that we annotate the document with who has read access and who has write access. And then currently when an edit comes in, the server checks with an OAuth thing whether the one who's doing the write has rights to do that. And I had in my mind that would it be possible to do something to just store the public key of the users that have and their access rights in the document as well. But if you do that, then they should also then you would have to encrypt all the documents with so keep a copy encrypted with each of their public key for them to decrypt with their private key. And perhaps there's something that I'm thinking too naive of it, but definitely I can't really see how it could be done. Yes.
What I have seen, we haven't done this, but it's just lockboxes. So you have like for read access, you have a read key, and then you encrypt the read key to each user.
Right. Okay. Yeah. So it could probably be done.
There's subtlety to this, but that's kind of a model.
Yeah.
I think if you look at lockboxes, I think that's the entry point.
All right. Okay. Good. Thanks. Yeah.
I thought you mentioned it at some point, but is there any connection between the VARF programming model and having code as CRDT?
Could you repeat the question?
Oh yes, sorry. Is there any connection between the VARF programming model and code as CRDT?
You said it's a declarative programming
yes,
model? I thought you made a connection, but I'm not sure.
Yeah, so there might be indirectly, and in that the approach that we've taken with VARF is to have the program expressed as a declarative data structure. Yeah. And basically it can be thought of sort of like you program the abstract syntax tree instead of writing a textual programming language. And there you could in principle have a CRDT for the program, but the thing is that the program is just JSON. And it doesn't diverge from JSON syntax in any way. So if you have a CRDT for JSON, you have a CRDT for the VARF program. But you can of course then make changes that break the program, because not all JSON is a valid VARF program. So I would have to think a bit about that, but yeah, potentially. Yeah.
We have one more question from the chat, and the question is, could you elaborate on the need for semantically meaningful application state?
Yes. The DOM, if you're familiar with it, has relatively light semantics, and a lot of the elements in there, like a div, has no semantic, well, very weak semantics at all. So if you have to merge changes between two versions of the DOM, then you don't necessarily know how the JavaScript that has been written interprets that structure. It might interpret semantic meanings to div being a sibling to another div or something obscure like that, that as a user you have no idea of. So with more close to the application model, so for instance, if you have concepts of a to-do list with to-do items that's in a sequence, then it's much easier for the user to reason about that than if they are in some kind of complex DOM hierarchy that has to be merged. And it could be something not so dangerous that would happen, like for instance your count or filter mechanism might break from the merge, but it could also be something that would render the application completely useless.
would say further questions for the coffee break. Thank you very much, Clemens, for this
thank
very
you.
nice insight. And welcome to the third speaker of this afternoon session, Geoffrey Litt from MIT, who is going to present their research results on building data-centric apps with a reactive relational database. And I hope this will shed some light on the question of how to do queries and these types of computations on shared data.
Great. I plug in. Sorry.
Do you have HDMI?
Yeah.
It's building up maybe as a reminder.
If you can share the screen anyway, that's really good for the live stream.
Yeah, I'll also share.
So maybe you want to prepare the questions that are burning under your nails for our panelists. Later on, we'll also try to include you as the audience into the discussion. So if you have something maybe provocative, maybe thoughtful, maybe just observations that aren't related to a specific talk that you saw today, but on a higher level or so, you might want to prepare and keep them in your mind. Okay. It's always virtual.
All right. Thanks for that introduction. It's great to see you all here today. My name is Geoffrey. I'm a PhD student at MIT, and I'll be talking about a project called Riffle, which is a collaboration with Nicholas Schiefer and Daniel Jackson, also at MIT, as well as Johannes Schickling, who's based in Berlin and is here in the audience today. So one of the parts of local first software that speaks most to me personally is something that Peter mentioned this morning. You know, can we go from the aircraft carrier to the bicycle, right? Simplify down, make software something that's more personal, easier to build. But I'm very, very worried about something. Does anybody see the trap that is going to happen here? In the history of technology, there's this tendency for complexity to just build and build in this strange evolutionary way. Oh yeah, let's just stick an aircraft carrier on a bicycle and call it a day, right? I really don't want this to happen. And I kind of want to use this talk to figure out with this community, you know, can we find a way to leverage local first software to truly simplify the development of user interfaces? I think this goes really well with Clemens' talk that just happened about, you know, can we actually find a way to simplify down, right? So that's the prompt. How can we simplify UI development by building on a local first architecture? And I'll show you one example of how we're thinking about it on our project. So I want to start with just a brief recap of something that's been mentioned already today, which is just the sheer complexity of modern web development. So before research, I spent a bunch of years building web apps, and often you'd have, you know, a front end and a back end. You come up with a REST API. You have an ORM in your web server. You're writing Ruby code to query your data, and that's talking to a relational database through SQL. Oh yeah, now our client has rich, you know, stuff going on in the browser, so we're writing JavaScript code to filter our data. And this, you know, we think of it as just the normal state of affairs today, but it's very, very strange that we've ended up with this. We have lots of redundant data representations in different places. We have multiple query languages that we have to learn to manipulate that data in different ways. And there's network and process boundaries in multiple places. So there's a lot of asynchrony. We're building these distributed systems that we have to reason about a lot of the time very manually. So with local first, the promise is this, right? So simple. Database in your client. From a developer perspective, you just read and write directly to that local database, and replication's handled for you. We're done. Great. Okay, there are still some questions here, right? So let's think about what we need to figure out. Well, I would contend that it's actually kind of not obvious what exactly this database thing is. What does this thing do, right? There are a lot of questions. What is the data model? Is it a document? Is it a relational database? What's the query language you're using with this data store? What even is its scope of responsibilities, right? Is it, you know, a UI framework? Is it like a sync engine? Is it a persistent database? We kind of have settled on some conventions with traditional web apps, but in this new world, we still need to figure this stuff out. And what I want to propose is that we can use this as an opportunity to rethink the boundaries a bit and sort of come up with some creative ideas for how to combine things that used to be separate. All right, so that's the idea behind Riffle. Riffle is a system and an architecture where the idea is to build a UI declaratively using a database and a bunch of queries as kind of the basis for the entire interface. And the hope is that if we lean heavily on databases, where people have thought a lot about these really tricky questions like query planning, transactions, efficient persistence, even fancy stuff like incremental view maintenance, then we can leverage those techniques to build better UIs more simply. Another really important piece is that we get to assume local data, right? Because we have async replication happening in the background, this is a huge difference from normal web apps, and we're going to really lean heavily on that assumption. So with Riffle, we've decided to try a particular thing. We call it the reactive relational model. Very simple. We have a relational database model, and we have reactive queries. So what does that mean? When you want to read data, you use SQL. You're querying a relational database. If you want to do sort of downstream derived data and transform your data more, you can use JavaScript, but you can also just use more SQL if you want. The SQL is running directly in your client, so it's all right there. Of course, we want reactivity, so when we change the data, all your queries automatically update. That's the guarantee that the system provides. And again, replication, sync, you don't worry about it. The framework should deal with that part. And I'm actually not really going to talk much about sync today, even though this is a local first conference, and obviously sync is important. I want to focus on the bottom part of what can we do when we have local data. What does that enable? All right, enough pictures. Everyone wants to see a demo, right? It's late in the day, it's getting hot, so let's see some demos. So what we've done is use these basic ideas to build a prototype of a real piece of software that I'm going to show you. First, I'll show you the basic architecture of the prototype Riffle system. So what we've done is we've glued together two existing things. React.js as the most popular web UI library out there on the one end, and SQLite as a database on the other end. If you're not familiar with SQLite, it's a really nice embedded SQL database. Brings a lot sort of for free out of the box. And Riffle sits in the middle and kind of creates a UI state management framework that helps connect those two pieces. So let's see how that works. So as a demo app, we've chosen to build a music player called Overtone. And the development of this is being led by Jahns. And I can show you, the basics of what you can do in this thing. It's a music player. You can scroll around, choose different playlists. You can find the song you want to play. You can play it. It syncs data from Spotify and plays music on Spotify. So you can, I guess I don't have audio on this hooked up, but you can play music on it. It's really nice. Much faster than the Spotify native client. Right? Which actually is very related to the architecture because Spotify is very cloud first. It's great, and even though there's been a few people working on it for less than a year, it's a pretty fully developed app. There's actually a lot of complexity in there. So now I'm going to show you a few glimpses of how we've built this thing to give you a sense of how it works. All right, idea number one. We think that managing all of your state in your UI in a single system provides you tremendous flexibility in how you design your UI. So traditionally, you often have this split between at least two different types of UI, or of state. You have app state, things like the tracks in your library, persisted in your database. Then you have UI state, typically ephemeral, like the contents of a text box, right? And there are good reasons to think about these types of state differently. However, we believe that they often are kept too separately, and it requires you to reason separately about all the state in different places. So what we do is throw all the state of the UI into a single database. And you'll see some of the benefits of this kind of as we go along. So for example, when I'm clicking around, let's say, choosing playlists, right? Every time I click anywhere in this UI, that's round-tripping through my database. So I'm writing an event that says I selected this playlist. And then on the read path, we have a query that looks like this. It's a SQL query that gets the tracks. And the important part's at the bottom here, where we say only show the tracks that are in the current playlist that's been selected. It's super easy to query that UI state because everything is in the database, right? So by having everything in this one system, we can conceptually query it all together. You also get this nice side benefit, which we didn't think was that important at first, but was actually kind of nice, which is that all of your UI states actually persisted by default because it's in a database. So for example, I can go, pick a playlist here. I can sort it however I want. And then I'm going to refresh my app from scratch and blow away all the in-memory state. And I'm right back where I was. The pixels on the screen are just a function of the data in the database. And this actually is a really nice touch in a lot of UIs that people often don't implement because it's kind of annoying from a developer perspective. But when it's the default, it's really nice. I can even send this database file snapshot to you. You can open up the app and see this exact state, which is kind of fun. All right, so that was idea one. Second idea that we have is that we think that declarative queries and modeling a user interface as a composition of these declarative SQL queries is a really nice way to clarify the structure of your application and not have it just be this ad hoc, mess of imperative code. So concretely, we do a lot of chaining of SQL queries in this app, which means that we have SQL queries that depend on the results of other queries. So for example, here I have a query that's loading some tracks, and we want to sort them in some order. And what we do is we just do some string interpolation to interpolate the property and direction that we want to be using for our sort order. And that's coming from another SQL query that also is querying stuff in the database, right? And so what you end up doing is chaining these queries together. And there's actually a last step to that, which is you can almost think of your view template itself even as a kind of query. It's just a pure function from some data in your database to a DOM tree. And when you take that perspective and you kind of zoom out on the whole thing, you get this really neat picture of what's actually going on in your app. So this is kind of a directed graph of data dependencies. The sources are the sort of raw state you can think of. So things like the tracks in your music library. You can also have local component state in our system, like you often have in a React.js app. So these little red bars here are local state in your components. And then the sinks of this graph, what comes out at the end, are these orange bits, which is just your view templating, right? And all the dependencies in between are these arrows where you can trace how did this view get computed? Well, it came from this query, which came from that query, which came from a combination of your tracks and your component state. It gives you a lot of visibility into your data dependencies. And we found that this is really helpful for kind of figuring out what's going on in your UI. It kind of feels like using a spreadsheet almost. And we've actually built some debugger UIs where you can trace back these queries and see what's going on. All right, idea number 3. We believe that fast reactive queries provide a really nice, clean mental model for thinking about how an app behaves. So I've already covered reactive, but the fast part is very important here. So the idea is that if you have reactivity and it takes a few hundred milliseconds to update, that's one thing. But if your reactive engine can update all your queries in a single frame, that actually completely changes the kinds of ways that you can use your database. Because again, every single thing can round trip through the system now, right? And you can still have a fast app. So let's take one concrete example of this. Virtualized list rendering. It's a very common technique in UI development. If you have too much data to render in a super long list and it's going to slow down the UI, you only render parts of the list so that you can keep things snappy, right? And traditionally, in a web app with a backend, you might do something like, start scrolling down some rows. When you scroll too far, talk to a server and load some new rows, cache the rows you've already seen. But this starts getting really complicated when you think through, what happens if the data on the server up here changes as I'm already scrolled down in the list? Do things update? There's a lot of caching and stuff to think about. With Riffle, there's no caching. Never do any caching. Rely on the fast reactivity. So you always have a single source of truth. What that means for virtualized list rendering is, every time the user scrolls at all, we write the scroll position into the database. Now, the query that generates the currently visible list of rows, that's just a normal SQL query, which interpolates the current scroll position to fetch the rows you should be seeing, right? And as long as that reactive engine is fast enough, this query is constantly being updated as we scroll. There's nothing really complicated here, no caching. And I can show you, here it is, I'm scrolling. There's actually tons of database queries running, dozens a second here. And it's totally fine, feels super fast. So again, a point I want to kind of drive home here is that the ways that we're using this database are so different from the ways that you would think about using a database that's, across an ocean or even, any kind of network boundary, right? This is a completely different usage enabled by having the data locally. So I think that's a super kind of neat thread to pull on. All right, so that's been kind of a whirlwind tour of the basics of Riffle. I want to talk a bit at the end here of some of the things we've found as we've been working on this and some of our next ideas. So I just covered the first one. We think fast data access through local first software really enables new programming patterns, and it's that there's interesting space to explore there. A second thing that's actually come up a couple times today is that transactional updates have actually been super useful. So SQLite, like many SQL databases, has transactions. You can atomically commit a bunch of writes. And that's actually really nice in a user interface because you can batch together a bunch of updates, transactionally commit them, and then you know that on the next tick of your reactive graph, you'll have a fully updated state. There's never, you never end up with parts of your UI inconsistent with each other. That's really nice. A third thing we found is that SQL is kind of a mediocre language for UI development. You know, at the very beginning of the talk, I showed all those layers, right? The ORMs, the JavaScript stuff. And I think one of the reasons that those layers exist is because of the limitations of SQL for powering UIs directly. There's a lot of reasons for this. Probably the biggest one we run into is that UIs are trees. There's a lot of nesting, but SQL can only produce tables. And so already there's kind of a mismatch going on there, but there's other reasons too. Importantly though, we think this is probably solvable with new relational languages. So we can think separately about, you know, the relational model as a fundamental idea versus SQL as a particular language. And people have been experimenting with interesting, you know, other relational languages that do things like produce trees out of SQL and so on. So, finally, one more thing I'll mention. Migrations came up earlier in Peter's talk as well. And yeah, this one's really tough. It's super tough when your UI state's in your database, because now anytime you change your UI at all, you're dealing with this persistent state from your old UI. And of course, if you're in development, this is happening all the time. And so this has been a pain point for us that we're still figuring out. There's one last finding which I think is super cool, and I reserved a whole slide for it. It's this idea that data-centric design promotes interoperability. So once all your data is local, even your UI state's local, and everything's reactive, then you start thinking about, can you just have multiple applications talking to the same database? What does that look like? So here I have, this is an older version of Overtone, and what I'm going to do is just drag in a SQL editor, and I can view all the data in the app. I can even view the UI state and edit it. So I can enter a search term, save into the database, UI updates. I can like sort by some different sort order, save that into the database, and the UI reacts, right? And so we think this is kind of neat because you've basically created this data-centric scripting API almost, where anyone who has access to that database can manipulate this user interface. Anything that you can do on screen, you can do in the database because everything has to round trip through this data layer. So we think that's kind of cool and could point to future interop possibilities. All right, how am I doing on time? Cool. So I want to close with one last thing that I haven't talked about yet, which is so this is already kind of extreme. It's kind of weird, right? Taking this super query-driven, database-driven approach to UI development. What happens if we take that way further and just take it to 11? So far I've shown you reactive relational queries, and what they've been is kind of taking what you might call base state, like the tracks in a music library, and queries to get derived views that you use in your UI. Things like filtered and joined views, right? But at that point, we've handed off those derived views to React.js and said, hey, go render them. It turns out this gets annoying for a lot of reasons. One of the main reasons is that React has its own entire reactivity system, so we kind of have two different reactivity systems going on, and they don't always match very well. And so you could imagine a future where we get rid of React and just go with relational queries all the way through to the DOM. Now, pretty cool, right? Yeah. So there's actually even one more part to this, though, which is, I haven't talked about sync today, but in any local first software, what you typically have is some events at the very base of your system. We're exchanging a monotonically growing set of events, right? And somehow we need to get those into a base state that converges across all replicas. Now, typically you might do that with a CRDT. And there's an interesting lens that some people have thought about, in terms of a new way to build CRDTs, which is to represent CRDTs themselves as a form of relational query. So you could even imagine implementing CRDTs in some sort of relational language. Now, okay, what would you get if you went full stack here and super integrated across this whole thing? Well, we think there's a couple interesting things you could get. One is, if you apply incremental view maintenance techniques across this entire stack, you could imagine when we get one new event in here, can we efficiently compute what effect that one new event should have all the way over in the UI, sending deltas all the way through this stack, instead of reifying a bunch of new states and diffing at multiple layers in this stack, right? Another thing we think could be cool is provenance tracking. So could you do something like point to an element in a user interface and say, why is this button yellow? Well, it's yellow because yesterday Peter added this event. This is all pretty speculative, but I think the point here is to illustrate that maybe by rethinking the boundaries and integrating more across layers of the stack that were previously separate, we might get some interesting stuff out of it. All right, so that's pretty much all I have. To close, I just want to reiterate this prompt and hope that we can get some good discussion around it, of how can we simplify UI development by building on top of a local first architecture. There's a lot I didn't have time to cover. If you want more details, we've written an essay at that URL that you can go read. And yeah, that's it. Thanks so much.
Just two areas, I don't know if you ran into these while you were working on this, that I worry would add complexity rather than take it away. One be, if you're replicating UI state, you can frequently end up in situations where people have menus popping open and buttons clicking on their screen that aren't supposed to be doing so because they're getting someone else's UI state replicated to them.
Yeah.
And also that generally, like, there's kind of an assumption of privacy when I'm of what my UI state is up to when I'm in an app. You know, I even get bothered sometimes when someone can see that I'm typing them a message on my messenger and I haven't completed the message yet. Yep. That's now potentially being replicated. So at least my temptation would be to solve this by having a local database that isn't replicated for my UI and a local database that is replicated for my application state. But yeah. I can certainly see how that could cause problems. And then the second thing being that, and this is solved also by just software being better, and maybe that, we'll get that, is that so often an application UI gets into a messed up state, and then the solution is to kill the damn thing and start it up again. But if everything's in the database, that doesn't save me anymore. I'm to uninstall and reinstall in order to fix a UI, a UI kerfuffle.
Yeah, these are great questions. On the first one, I'm not that worried about the question of sharing UI state, because you definitely should be able to configure UI, what state is being shared or not. That should just be a checkbox, right? And so the intention here isn't that you should constantly be replicating all your UI state. It's just that it should be in a system where if you choose to replicate it, it's just a setting. It's not like this entirely different system. And it's actually been interesting. I've talked to a couple people building multiplayer Canvas apps who've talked about things like they have a menu, and when it opens, they actually want to share that state so that everyone else in the app can see what I'm looking at as I move my mouse around the menu. But if you've already modeled that menu state in your UI ephemeral world, it actually can be a lot of work to move it over into the replicated world. And so the hope is that if you have it all in one system, it's easier to move back and forth as desired and sort of be flexible about it. Same thing with what you mentioned around blowing away the state. Like at any point, if you want to blow away all your UI state, you can just delete the data out of the database. You can still absolutely do that if you want to. So I'm optimistic that you can sort of deal with those kinds of questions through configuration.
Actually, add to that, since I'm the developer who's mostly dealing with that, and I cause the app to end up in a messy state. And what I actually do is in the old world, I would think, now I'm in this weird state that I don't know how I ended up in. I want to get back to building things, so let me just clear everything, but then I don't know how to reproduce it. But what I can do now is literally just copy paste the database file into another place, and when I'm talking to Geoffrey, loads it in again, and we're in this old world, which is just an amazing quality.
So, did you think about whether some of the complexity you save is because you start trusting the client software? Because usually in web development, there's this big assumption. You never trust anything coming from a browser and from a client. And that's why you need to duplicate all of the logic, writing into databases, validating data, whatever. You always duplicate that on the server where you trust the environment. Whereas here, I believe you assume that you can just trust whatever the client is doing.
Yeah, that's a great question. Repeating the question. So the question was, are some of the simplicity gains here simply from ignoring a lot of the concerns around validating input, where in a typical web architecture, the backend does validation and doesn't trust the browser? I think to some extent, yes, that's absolutely true. One thing we really have not thought at all about is access control. We've been assuming every replica has a full copy of all the data. And the moment that's no longer the case, things definitely get more complicated. Another thing I'll say, though, is that one thing I didn't really show is that our write API actually isn't raw SQL writes. It's an event-based API with sort of semantic events. And so you could imagine, another client emits events, and then when I'm applying them, I could do some validation on my client. Again, it's that thing about paying attention versus validating on write. And maybe that would help, but it's sort of slightly uncharted territory. Yeah. Yeah.
Could you explain a little bit more about the reactive engine? So, for example, do you detect which components depend on which data? How was that designed, or do you pre-render the entire application as soon as anything in the database changes?
Yeah, great question. So there's two answers to that. Oh, sorry, repeat the question. Explain the reactive engine more. How does it work? So the answer for how we do it today is very, very dumb. Every time anything gets written to the database, we refresh all the database queries that have been registered. And it turns out SQLite's pretty fast. And so even with a relatively complex app, that just all happens in a few milliseconds. And then we do some diffing to figure out what changed. And for the things that did change, we then pass those updates on to React. Answer two, I guess, is that there are much fancier things you could do. And there's a lot of database research that's gone into solving this exact problem of tracking, propagating change through queries. And we plan to do some of that, either building with existing tools. There's a really neat incremental database called, I think it's called Skip, that we might try using. But for now, I guess the point is, SQLite's very fast. It has a nice query planner, and so it can do a lot in a short amount of time. Yeah, I guess that does answer your question. Great. Yeah.
Yeah, speaking about the speed of SQLite, you showed that your application looked really cool and snappy, but I was still wondering if you ever encountered, or if you ever felt like the SQLite database in the background was slowing you down, because if you persist everything, you basically write to disk all the time, right? Because your SQLite database is just a file, and that must take its toll to some extent, right?
Yeah, so the question was, doesn't it slow you down to be round-tripping through SQLite because you're persisting to disk? Yeah. So the answer is, we definitely don't want to block on disk. That would be deadly. You can't block your UI on a disk flush. So what we actually do is we run SQLite in the UI thread of the browser in WASM, and we actually just do everything synchronously in memory there. It's actually very important that there's no async in that UI loop. And then separately, we asynchronously send updates also to another SQLite instance running in the backend, meaning a web worker or a native process, and we persist there. Technically, that could result in issues where you did something in the UI and your computer crashed right before it wrote to disk or something, but people don't typically expect everything they do in a UI to be immediately saved. So we think it's kind of fine. But yeah, perf has been a bit of a challenge. We really had to move to running SQLite in the UI thread to get this all to work reasonably well. Michelle?
Have you considered using Cambria for migrations?
Yeah, we have. We don't know yet exactly. I don't know how that would work exactly in practice, but yeah, it's a possibility. Yeah, just haven't worked on migrations yet. Yeah.
I think a lot of web apps are structured in this query-centric way already. Is the real innovation that you're using SQLite instead of a normal ad hoc in-memory thing? Or I'm trying to figure out exactly which part's new and where you can lean on precedent, because I think there's a lot of precedent for query-driven UIs.
What do you mean by, when you say they're normally query-driven, what do you mean?
Meteor was doing this kind of thing, Asana does it. I think there's a whole family of web apps that work this way, because we've all hit the thing where in order to have rapid updates locally, even if you're actually cloud-centric software, you need to have a data model that you can run queries against. And so you end up writing live queries, and I think doing something very similar to this, but not with a real database.
Got it. Yeah, so the question is, aren't a lot of web apps already built like this, in a query-centric way, things like Meteor? There's a ton of related work, and I think, yeah, it's many parts of what we're doing have already been done in various ways. A lot of what we're doing is very similar to existing state management frameworks in React, for example. Many people have thought about, how do you deal with derived data and keeping things up to date. I would say probably the biggest difference is throwing a real hefty SQL database in there as opposed to doing stuff with your queries in JavaScript, right? And our belief is that for certain domains, SQL is a much better language for expressing your data transformations than, implementing hash joins in JavaScript, that sort of thing. There's definitely some similarities to Meteor. I don't know the exact, compare contrast, but yeah, I guess there are definitely parts of this that have been done. I would say leaning on a real database is kind of the important difference. Martin?
You mentioned earlier that you have this idea of a registered SQL query, so which queries need to be recomputed when the underlying base data changes. Does that mean the application code has to keep track of which queries affect the current view and then register and unregister those queries as needed? Could there be a risk of memory leaking those registered queries essentially?
So that's all automatically handled by the framework. So the way the currently registered set of queries is essentially driven by the set of components that's on the screen. So what happens is when let's say you click on the tab that shows the track list. The track list appears. And at that point, you've declared this track list depends on this query as just a declarative dependency. And the system knows, okay, we rendered the track list, better go set up a query to get the tracks and keep that updated. And then once that component goes away from the screen, we know that we can throw away that subscription safely. So it's all automatically managed as sort of a function of what's currently visible in the React components.
Nice.
Yeah. And if our framework has no bugs, then you will not have memory leaks, which I can't guarantee right now, but that's the hope. Yeah.
Last question.
Have you considered just selecting SQL straight out of the database? Just template with your SQL queries? Why mess with all this React stuff in the middle? You've got queries. Just return HTML.
We have, yeah. The SQL gets really gnarly.
That's a syntax problem, right? Gussy it up a little. There's this guy I know who has done some weird ORM stuff that you could maybe work with on a project like that.
Again, I think the really tricky part though is nesting. So nested tree things get really hard.
And I think this is where the relational versus the document model really goes, right? And so we see some local first apps like Actual Budget and, I guess to some extent Muse, just by nature of the card structure that Adam presented, they do well with this relational model, and other ones less. And so it's interesting to, it's not clear to me whether the hierarchical document model is going to be dominant or this SQLite embedding or son of SQLite, whatever embedding model is going to be dominant. Do you have a sense of what you expect in the long term? Are you going to feel pain and be like, I need Bongo?
So I guess I should repeat the question. It's basically, talking about document representations versus relational representations. I don't know. I think this debate has really played out over the past decade in web backend, right? And people have gone back and forth and thought about the comparisons. A couple of things I would say is that I think having well-normalized data representations can be very useful for sync, because the moment you have denormalized, if you have a document structure and you have copies of data and you have derived data in different places and that's saved, then I think sync can get very tricky. And so I think it's really nice to have a model that pushes you towards normalized data. Also for interoperability, I think it's nice to have sort of, the whole idea of the relational model is normalized data, and that can be queried into any shape you want, right? It's not this one specific document shape for this one app. So I think those are points in favor of the relational model. And I don't know. You're still right there that I think it depends a lot on the domain. Some domains are a really good fit, others are harder.
Any shape that you want, as long as it's a table.
Yeah, exactly. Yeah.
Okay, thank you very much for the lively discussion. We will meet in half an hour, so I guess we can start a few minutes later for the final session, where we have a panel consisting of Mira from TU Darmstadt, Marc Shapiro. We will have Kevin Jahns from as the YJS man, and Adam Wiggins, who's here in the front. Prepare your questions, keep the lively discussion up, and get some strength from your talk. And thank you very much, Dr. Litt.
definitely get those questions, and if not, I forced it.
All right.
How many people will need to learn how to program in 10 years? I mean, over and you kind of
out. That's why you are here. So if they don't. Thank you very much for the panel session. Well, to be back for the panel session. Before I introduce the panelists, I really have to say, I was told yesterday if the workshop failed, I should just blame the speakers. So it's my pleasure to say I'm very thankful to all of the speakers. It was amazing. I'm blown away for a first-time workshop. I never imagined everything to go so well. That was great, so thank you everyone, and thank you for being a great audience. And now, we have all 4 panelists, but this is also I guess the audience is a 5th panelist. So you are encouraged to participate if you have something interesting to say. Just let's keep things moving and don't we don't need your sales pitch, okay? But we do value your experience and opinions. So with that, our panelists are Marc Shapiro. He already talked, so I guess you know him. We have Mira Mezini from TU Darmstadt, who, as I said, is kind of the sponsor of this event and the head of my research group. We have Adam Wiggins from. Are you still with Switch? Yes.
I'm on the board, yeah.
You're on the board and on Muse and on all of these things, so I can't even, I even don't know what all else you did. But I hope we find out some more. And we have Kevin Jahns, who on his website says he's made the fastest CRDT implementation of them all. So.
Whoa. I don't say that explicitly.
You just said no sales pitches.
He did it for me.
That's why he did it for you, yeah. So, as I can't introduce them as well as they will be, we'll start with a short round for you to getting to know the panelists some more. So let's start from the left to right. Marc, you've seen CRDTs from before the beginning, right?
Yes.
So
what they were called OT.
yeah. So what do you think? Like, how are our current approaches that are, like, all of them say they build somehow on CRDTs, but is it still the same? Are they different?
So I'm really glad that the idea of CRDTs caught on. It's wonderful for my ego that I've contributed something. But in some sense, it's great that there's so many implementations of CRDTs and people using CRDTs, etc. But in some sense, we're still at the same place where we were in 2011, which is, okay, we have these data types, now use them. Right? And we haven't really figured out what they're good for, and we haven't really, and I think that a lot of people have this sort of naive approach, oh, I found the silver bullet, just use CRDTs in my software and everything will go well, and then they discover that no, that's not good enough, okay? And so CRDTs just solve a very small part of the problem, right? They're sort of like networking. You can send messages and you can share data, right? But then what do you do with it? There's so many questions about how do you compose CRDTs, how do you enforce structural invariance on your data, how do you make sure everything is correct, and all the things that Peter said at the beginning, like about access control and all these things. So we've made a lot of progress, but still, we're still at the very beginning.
So you gave me the perfect serve to hand over to Mira, because I guess Mira has pushed her research group for quite a while now to actually work on things like composability and usability of CRDTs in a larger application context. So,
well, not only this, but I mean, Peter said it in the morning that we are in a new era, or we have entered a new era of software architecture. So, what the question that I pose to myself and to you guys is, how do we program software for this new era? And we heard a lot about CRDTs today, and they are one ingredient of this, if I may call it, programming model. What are the programming models for this new era? And I think CRDTs, or in general replicated data types somehow, are one ingredient, but then there are a lot of open questions in there, like you mentioned a lot. One that concerns us also, we are interested in, is how do I support software developers in designing and implementing their own application-specific replicated data types. So I'm concerned that we might end up into this impedance mismatch 2.0 at some point, because if you take a library of CRDTs as it is, then you have your application has needs for other kinds of data types, represents the data types in a different way. How do we match between these two layers? So which goes a little bit in the direction of Geoffrey, kind of can we bridge those two layers and have the application developers develop their own replicated data types, but this is very challenging because it takes systems people like Marc and the like to design correct replicated data types and to make them composable. Can we have our language runtimes support, I mean, I'm a PL person, so support developers in, for example, automatically generating correct merge functions out of existing simple types. When you use compound data types, can I generate the merge of the compound data types out of their ingredients? So I have to start with a recursion anchor with some data types that are given, that are replicated, but then how can I build on top of them and do this automatically? This is one part, and we heard about the encryption part that we are looking at right now. But on top of this, I think there are other aspects, like we heard about interactivity or reactivity, whatever you call it. So this is, for me, also an essential part of the design of a local first software. You are talking about users collaborating, so you need to support reactivity, and nowadays typically we use callbacks and all that. And we heard in Peter's talk also that we want to avoid this complex callback structures. If interactivity is important, then we have to have it first class citizen in our programming frameworks or languages. And this is something that we are very interested in. We are doing in REScala, like we look at the application from the point of view of interactions with the user. So a whole interaction going from pressing a button to some view somewhere in the world being updated. We look at this as if it was a transaction a little bit to make the analogy with the database, and then we want to have consistency, whatever level it is, that at this scope, whole interaction offers some kind of consistency guarantees, and ideally not at the level of causal or strong, because the application developers, I am assuming, have no idea or limited expertise when it comes to the consistency level. So we want to have them express invariants that are important for the application and then map that down to whatever consistency level fits those invariants the best. And then there is another thread which we haven't been looking yet, but we are looking at, like, what's the counterpart? If we go away from the cloud era down to this local first era, what's the equivalent of running features, software apps that someone else wrote on our data? How can we ensure that this runs? I mean, we have the right access controls there, that we say what a feature can see, read and write from our data that is stored locally. And also, how can we ensure that nothing harm is happening to our local devices if we run external software? But yeah.
So, Adam, you said you are the least technical person here, and now you have basically a very solid foundation and people that extend this foundation to make it more usable. So what are you trying to build on top of these things?
Yeah, well, I realize the name of this day here starts with programming. And I do think that the developer experience is incredibly important because how developers build applications and tools they have, that actually shapes the end result. But I came at this from the complete user perspective. How can software and computers and the internet work better for us all to allow us to achieve the things we want to achieve in our lives? Indeed, I even thought of this as the syncing problem, and it was Peter many years ago who said, you know, there's this technology called CRDTs that might actually help solve this problem that you have. So I started with the problem of I want computers to work differently, and then only came across the computer science in search for a solution. So the things I'm most interested in is, actually you kind of said it there with this button click all the way to the end thing. So how does it feel? Okay, we know cloud software feels a certain way. We know that local, you know, Microsoft Word felt a certain way. And there's pros and cons to those feels, and user has a certain mental model about how they interact with it and about their work. If I'm writing my PhD dissertation with Microsoft Word, I have one mental model for it. You know, back it up in 5 different places, keep a hard drive here. Whereas if I'm putting it into Google Docs, I have a different mental model for it. And you can talk about the trade-offs there, but local first will bring a whole new mental model for users, a whole new set of trade-offs, a whole new way that the software will feel, which I think can be much better than either of what came before. But we need to discover that and prove that out, and that's why I'm really interested in seeing that end finished software and using it in real life and discovering all those nooks and crannies about how we will interact with it and how it changes our world.
So, Kevin, I guess you're kind of like in the trenches in some sense of this endeavor. Do you want to share a little bit of your experience from your work? I mean, also the others during the workshop, I think a lot of the things were covered, but we didn't really talk about the kinds of things you work on, I think, yet. So here's a chance.
All right. I think my background is very unique because I'm not associated with the company directly. Right. I was a freelancer most of the time. Maybe I should start with how I got into YJS, right? So I saw this problem that I wanted to solve. I just wanted to have collaborative editing over WebRTC, and I thought, how hard could it be? Yeah, next, as I spent 8 years working on YJS, so here I am now at a conference talking about it, and I think my scope ever increased, but I've always focused on, getting something done with CRDTs directly, right? I love like the big plans of, local first software, decentralized, and this problem space is huge. I mean, I think all of you have like hundreds of years of work to do, so good luck. But I'm working directly to solve problems for companies, and that's also a way how I get paid. But also YJS itself is, in a sense, a foundational tool to build local first software, right? It's also a foundational tool that you can use to build decentralized peer-to-peer software if you want to. I see this as a small cog in this whole ecosystem of what we want to achieve with local first. So my problem space was always mostly about collaborative editing. I solved, in a sense, peer-to-peer editing using over text, and then later on rich text editors. And continued my journey also to build collaborative drawing apps and more complicated applications based on CRDTs. And now I see other people building new abstractions around YJS that allow you to, for example, synchronize React state. And there's so much to do, like on these concepts, right? On the concept that Marc created back then of basically data tapes that synchronize automatically. Some of you maybe don't even care too much that it's decentralized. It's really just about, this is data that you have locally, but that's synchronized to the cloud, which is an amazing thing to have. Yeah, so my background, this is where I wanted to go, and how what I'm doing. I'm not associated with the company or, with profit plans. My goal is to build software for the public good. so that all of you and companies and can use my software to build amazing projects. I'm mostly interested in collaborative software because we need to work together if we want to achieve more, right? And CRDT is our way to allow you to work together basically on software, right? And build collaborative software itself. So yeah, that's what I'm doing. That's my background.
So now would be a great chance if the audience has any questions related to the speakers. If not, my question would... Well, look. Look. While I'm talking, but I don't have anything important to say anyways. So if you have questions, just let me know. I also, in between they're talking, I may register that. But otherwise, I think the
We got one here.
Yeah, so I have a question primarily to Adam. So the reasons for local first are very compelling to the users, but I'm wondering if you gave much thought to what arguments would be convincing for example, SaaS providers.
Well, this comes pretty quickly to the sort of business model question. Peter alluded to this a bit. Tends to come up. I don't know if you go back and read the comments for the various times that the local first essay has been posted to Hacker News. Quite a good subset of them is how can we as developers get paid if companies don't get paid by holding everybody's data ransom? And undoubtedly the SaaS model where the application and the data are all managed together there's a really good, well-defined business model around that. And I don't even think it's a bad one necessarily, but I think there are probably other ones we can discover if we experiment. I do think also the B2B SaaS model is tied very much in the venture capital, unicorn in 10 years kind of scheme. And I think there's probably a wider diversity of types of software that we can build and create funding models and business models necessarily. That's one of the things we're trying to do with Muse that's different, is to pair it with a business model that we think will better match or better align the incentives we think of creative people and the software creators. But the answer is we don't know necessarily. We have to try stuff. So that to me is just as much an area of research, discovery, and innovation as any of the technical aspects that we're talking about.
Yeah, please.
So, I don't know why it shouldn't be possible to, it's just flipping the coin, so to say. Why shouldn't it be possible to build decentralized SaaS platforms? So there's someone that we invited actually, but he couldn't make. There's a startup company here in Berlin, and they are trying to, so to say, have a decentralized infrastructure where everybody keeps his or her own data on their devices, and then have companies develop features that run, instead of running at Google or Facebook, they run on this platform, so to say. And then I think software developers would have a chance to develop such features for companies, for, let's say, decentralized customer relationship management. It has several, principally, we will see whether their business model is a startup. But kind of, there are several advantages to it. So the data is not replicated all the time, or duplicated, let's say. It's not about replication, but duplication. So I have my data, the company X, Y, Z have my data. What about I have my data? It's one copy, replicated. But then different companies can write customer relationship management software features that run on my data pod, let's put it this way. And they don't need to keep my data, so are GDPR compliant by design, need hopefully less servers. And then data is consistent by design. So if I change my address, I don't have to notify all people that have my address, all companies that have my address, that I changed the address. I still have some, like Lufthansa Miles and More, has still my old address, because every time I see it's the old address, I think I have to change it, and I don't change it. So they send letters, and then they go lost, and they get the letters back, and they have to, so they have costs even with this. So maybe there is a way to develop new business model. I do believe there is a way, but we will see.
So, So Kevin, I think you kind of do make a living developing local first technology. Do you want to share a little bit more about, like, say some more words about how that actually works for you? What do you earn?
I'm very fortunate that it does work for me. I get my income mostly from GitHub sponsors, and we also have an open collective that I use to finance software around YJS. And how it worked for me is that I talk to companies directly and tell them, all right, there's kind of an incentive that you want the software to survive, right? If you want to use software that was written for the public good, right? You don't need to give a lot, right? You don't need to give like thousands of dollars a month or something, just a small contribution, because there are a lot more users of YJS and this public good software than we need maintainers, right? Otherwise, every company would need one developer to write the software individually. So basically, my business model is, all right, I ask them directly, hey, just give a bit. It kind of works. I'm not too happy at the moment. I think a real business model would be awesome. I just haven't figured it out yet, right? Because I mean, something that you could do is sell a cloud service, sell to store data and stuff like this. But at this point, if you do this, right, you're not the person anymore that wants to develop offline first, a local first software, decentralized, right? And I'm certainly interested in building all these things and the foundation for this.
So your GitHub sponsors are mostly companies?
Yeah, mostly companies.
So maybe one more direction, Marc, Mira. We are basically, I think, working full-time on local first software, right? When we do have finance positions basically financed by the state, who's willing to pay for our work. Right? What do you think? Could that be a realistic future?
What do you mean by what is that in the sentence?
So in the sense that it's clear that like local first has benefit for the public as does research, and like the public state is willing to finance this kind of thing, right? And from your experience dealing with like big projects, a lot of money involved for certain things, do you think this is something that might be thinkable?
Well, I mean, the state pays for research. It doesn't pay for developing real software that people will use. And the state pays for the state,
yeah,
the
public,
EU, the public, right?
Money, the public.
Taxpayer money.
Taxpayer
money. Yeah. And they're willing to. I'm very thankful that they're willing to pay for stuff that they don't know whether it's going to come out or not, and a lot of the taxpayer money seems to be wasted because it goes to blue sky research, which you don't know if it's going to have an outcome, and sometimes it does. Most often it doesn't, right? But that's not a solution, right? That's just a way of generating new ideas and new, solutions in the sense of let's say new algorithms or new whatever, but it doesn't build systems, right? It doesn't get into your iPhone.
Yeah, not a question, just a comment. Like, I hope that local first software can compete, like based on merit. Like, for example, I'm happily using Muse because I like it more than competition based on local first features. But the problem is that people are used to cloud software already and conditioned to all those like hacks to work with it.
Well, first of all, thank you for your usage/patronage, but additionally, I'll say that actually it's even worse than that, having spoken to tens of thousands of customers and prospective customers over the last few years, which is if they think they're just paying for software, they get very offended. But as soon as they think you're running a server for them or shepherding the data in some way, oh, now it's worth it, which is hilarious if you look at the numbers. The cost of running that server is like trivial compared to the cost of software engineers, especially in with today's salaries. But there's just a mental idea that software creation labor isn't worth paying for, and services are worth paying for. So part of that might be a retraining to some extent, but I really do think it is on us to create these kinds of institutions, experiment with new business models. I do think patronage is one. I think the success of Patreon, GitHub sponsors, and some others is very promising. But I think, yeah, new kinds of institutions, new kinds of business models, and if you pair that with software that's truly better, where someone uses it and they go, actually, I really like the benefits here. A good inspiration to me is Signal and OpenWhisper. Signal is basically a worse messaging app than others because of some of the technical challenges of end-to-end encryption and the way that history can be propagated and whatever, but they have successfully helped people understand the value of end-to-end encryption and why you would want that. And so therefore they're successful, at least in the sense of software that a lot of people use, because they have managed to surface some of those more philosophical things in a way that people care about. So I think it's on all of us to, this is again why it's a whole package. It's not just technology, it's design, it's business, it's society. All of it has to be innovated on kind of holistically and together.
Elisa, you had a comment.
Question on that. So looking at the development of data protection laws like GDPR and so on, is local first software especially fitting the European mindset, or is this really a global thing?
I think it does fit the European mindset for sure, which has a less of a sort of trust of sort of commercial entities, as well as, yeah, in general, data privacy is just way, way more of a topic. I say that as someone who was born and raised in the United States and has lived in Europe for a decade, and yeah, the contrast is sharp. But that's okay. There's different values in different places. Maybe those different places want different software. Maybe we find a balance globally that the Germans are super into privacy, the Americans don't care at all. Maybe somewhere in the middle is the right place to be. That's what we're all innovating towards as a society, I hope.
Julian, there's a
question on the chat. Did you see it?
Our chat works. Great. What's the question?
So, question for Adam plus panel. What are your thoughts on projects like Solid as repositories for personal data that can be accessed with permission by systems, SaaS providers?
What was the last part?
SaaS providers. Yeah,
SaaS providers, yeah. Yeah, I don't know the Solid project super well, although I think this is the kind of the semantic web evolution. Right, okay. Yeah, so it's harder for me to comment on that. I do see one piece or one compelling part of the local first story is obviously the data ownership. But we also need to be able to combine our data with that of others, so it's not just keep it on my hard drive. So I think that's another area to innovate on. Is there good ways to have my stuff, but there's also other people's stuff, and how do they come together? But I can't comment on that specific project, unfortunately.
Okay.
Someone else.
Well,
just to add one point to this, are Europeans more sensitive? I mean, is local first more? I do believe it's the case, but then this doesn't mean that when it comes to implement the idea, the vision, like our governments really understand what it takes to somehow. So take Gaia X, which was this, or is still this big, let's have the European cloud, decentralized clouds, and then you hear politicians say, but take Google on board. And I'm like, what's the point here? Like, you want to build something that is different from that, and then you cannot give up the old model somehow. You have to also, this kind of technology is not enough. You have to have the society and the politicians, the political decision makers to also understand what's going on somehow. So it needs a lot.
And I think it's not just because of protection laws, like that Germans want their data to be protected. Like something that I personally find annoying is that all my favorite note-taking apps host their data in America, and I have like, response times of at least 500 milliseconds or something, which, could be prevented if the data would be hosted in Frankfurt, or even better, at my home computer, because my internet always fails. So that's what local first is kind of to me, right? I decide where the data is hosted. Maybe I can find a way to do it completely decentralized, but I can also host it on my home server, definitely, right? Or I can host it on my own server that I host somewhere. And for a person that is not living in a awesome country like Germany, maybe some companies, you have large firewalls that protect their governments. They can't access data outside of their country. So for them, it plays a very technical role that they need to host the data themselves and maybe in a secure location. So that makes a lot of sense for them as well.
Yeah, we seem to have lots of comments on that. So
yeah, just to follow that, I think there's something interesting about, you said to store data where you want and make that choice. There's like a proprietary component to that where, like notes are stored like at Apple. And I wonder, is there a future where data is truly portable and you could store it really wherever you want at like, company X or company Y or company, Z?
I don't want to speak for everyone, but my vision has always been that, like for YJS, YJS is a data type that you can use to build a lot of different kinds of collaborative software, but very well suited for note-taking applications and drawing stuff. And then there's a network, how you synchronize stuff with other peers, and that these are very separate problems. So in theory, it is not just in theory, it is super easy to just exchange the provider that you use that synchronizes with some kind of company that hosts this for free, for example, Google, because they want your data. I can just switch that connection to my own implementation because the server is for free. Or I can use a complete decentralized approach that synchronizes using Bluetooth directly phone to phone or something. Or I can use all of them together. I can use several providers at the same time in YJS, which is, I think, one of the most valuable ideas I had in the YJS project, that you can just switch and combine providers together, and then you synchronize using Bluetooth and WebSocket and WebRTC all at the same time, and whatever succeeds synchronizes. So yeah, you can really choose it, and maybe at some point this will be part of a browser interface, right, or something like this, right? That would be my dream, and then you can just say, okay, I paid for this super private server in Germany where I want to host my data, or I just host it myself. I set up the server, and the backend is really only storing data and incremental updates. So that's very easy to maintain.
We have one more in the. Oh, please go. Yeah, yes, you.
Maybe sort of a response and a request or a wish. So I also work on the Solid project, so that's a personal data store, right? So you can.
So the speaker is working on a Solid project.
So one thing you can do is bring your own data. So you have a local first app, and then you say, I connect my data store, and then from your browser sync to your storage. Now, and I think the exciting thing is that you can do right now with local first is if you have an app that only runs in the browser, you can connect to your data store, and then your data is persisted to some server where you control. Right. But I think the only way we can make that work now is if that's just a dumb storage, and if the data is stored.
Basically argues for a data storage model which kind of automatically synchronizes with the cloud.
It's a folder where it can store data, and that's the data of that app. And I think CRDTs are sort of in one app. So the CRDT is designed as part of one app, and where it becomes interesting, if you think about bring your own data and separating app from data, is you say, well, I'm going to have this one data store with multiple apps. So then I guess my wish is, could we make CRDTs or build something on top of CRDTs where you add some sort of access control and some sort of semantic understanding between different apps and data portability, where you can actually say you can sync with multiple apps.
Mark, I think you.
Well, I mean, this all sounds wonderful to have all these options, but how are you going to deal with this? I mean, my mother cannot set up email, right? She doesn't understand the difference between IMAP and SMTP. And she doesn't understand all these numbers that she has to type. So, you know, how are you going to make all this easy?
Fair question.
Email.
Well, one question I would hope this.
User experience, right? So, I mean, yeah, we have to distinguish between making it easy for programmers and making it easy for the real users, and the programmers of a certain application then will be responsible to make it easy for users, right? So that your mom and my mom and maybe even us have to click only some buttons, and it's very easy to, yeah. But
absolutely, and I also think it's important to differentiate for who. It's another quality, I think, of the cloud and mobile era software is that there's the one thing that everyone uses. One email, everyone uses Gmail, everyone uses, you know, there's basically, there's a little bit of diversity, but not that much. It all comes from the same companies. Everything rolls up, winner take all. And one thing that I hope Local First might bring, or separately from that, something I'm just interested in, is a let 1,000 flowers bloom. The world is a big place. There's a lot of people in it who have different needs. This guy wants his private server in Germany. Yeah, my dad just wants email to work without too much complication. And maybe they use different software because they have different needs, and that's okay. And different companies can provide different things, and they may have different business models. And if you get away from the one giant company that gives the one email program that everyone in the world has to have their needs served by, and that there may be hundreds or thousands of these that serve different needs in different ways. And so for me, when I think about Local First software we're making with Muse, the kinds of software we want to enable with Think and Switch, and what I see elsewhere as well, is I'm thinking about particular kinds of creative tools and productivity tools by kind of more sophisticated users, and they just might have different needs and different desires from their software than the ultra easy one.
Actually, I would like to address like a bit of a different direction here, because Marc, you said that you kind of want to think about building systems instead of programs, right? And now we hear a lot here about like plurality and lots of different implementations. Do you think that conflicts with building systems? Is building systems something that you do for just a big cloud, or is building systems also something that's successful for more of a local first setting, successful more for a variety of topics?
So building systems is really hard. Distributed systems, it's really very hard, right? So I've heard lots of very good ideas about programming languages for developing applications, and I'm not worried about that. I'm sure that as there's lots of good ideas and something's going to come out of it, but people dealing with how do you build systems, I don't see very many of that. And building a system is really hard because there's lots of interacting pieces, there's lots of moving pieces, there's lots of things that happen, and the big thing, the sort of the history of computing has been, let's abstract, right? Everything gets more and more abstract, and all of a sudden we're dealing with the real world again. It makes a difference whether you put this piece of software here or there. Okay, it makes a difference in performance, it makes a difference in reliability, it makes a difference in fault tolerance, it makes a difference in semantics. Okay, and I think that, I'm happy that people are working on software, but working on systems is sort of they're systems people, but they don't have much tools, right? We just cobble things together with a bit of JavaScript here and a socket there and a file there and a database, and I think we really need better tools and languages for systems, right?
So maybe to clarify, are you saying that kind of the current approaches have too much abstraction to build good systems?
No. They're doing abstraction. So the way you do abstraction is by you simplify the problem, right? Okay.
Oh, okay.
So you do, I'm going to do, I don't know. Well, whatever. You understand what I mean, right? So you try to divorce the user from the physics, right, from the physical system. But system builders have to actually deal with the physics, right? They have to deal with the machine that's gonna fail at exactly the wrong moment.
So the abstractions hide too much, I guess.
Yes.
We had one, yeah.
Yeah, we talked a bit about this idea of like having a personal storage somewhere, but especially the Muse team has also gone through this ideation of like, should we go that direction? But instead you went for like priority custom sync service that you host on your own servers. So I wonder why was the user experience the influence here? Do you see this as just a step along the way, or how did you get to that decision, and how did you get there?
Right, and should we be repeating the question here? Yeah, so the question is just, why did the Muse team decide on what's essentially a centralized server, even though also all the users' devices have a complete and canonical copy of the data? Yeah, so this is what I would put in the realm of technology transfer. So the idea is that there are things, to me, that are still in the research world and we're still figuring out, and there's so many unknowns on them that were you to try to build a commercial product on it, you would fail. And then there's other things that have advanced far enough that they're ready to be commercialized. So because the people on our team, including me, had worked on a number of research projects that tried peer-to-peer networking and more choosing where your data storage is and various kinds of ways to build this, we plucked out the parts that we felt this is ready to go to production. This isn't quite there yet, but we'll try to build the system in a way we can bring that forward. And by the way, local first was not part of Muse version 1. I always wanted it to be, but we felt it wasn't ready at that time. So we built the app first, but we always had it in our mind that it could be that way. And yes, a Muse 3 or 4 or something, I don't know what, that has different data storage backends is absolutely something that very much is something we'd like to do or we could build, but I have to, we kind of try to do things in the order that is pragmatic for building a business and a working product, and then that straps us to that level, and then we're at a position where hopefully we can pull in that next round of research.
We have one question in the back. Yeah?
Yeah, and going back to the question about business models that could support the creation of local first software, I want to follow on something Kevin said. He said that with local first software, it's really easy to change providers, because synchronization is so basic in software. I mean, maybe today I'm using some provider to sync my stuff and keep it online. Tomorrow I could just use another one. So I want to draw a parallel with Linux, the Linux kernel, about how, say, in the 90s you had several companies that provided server-side operating systems to compete with each other. And at some point in the last decade, Linux got so good that the game theory of the situation changed. And it was better for them to collaborate their changes back to Linux, just use Linux and provide services on Linux, instead of having their own thing. So what I was wondering is if you think that it would be possible for other domains, say like Salesforce or things like that, could be replaced by open source solutions that are local first, and this would enable several providers to actually provide the operating part of the business while collaborating in the same code base. Do you think this could happen? Well, it's just a miracle for Linux. It just happened once in the history of humanity.
Should I repeat this? I'm not sure if I can repeat this completely.
If you can do it in 3 words, do it.
Oh, right. That should
Done.
be easy. Can you?
I can't.
Okay. So the question was about, the advantages of changing providers, and the questionee compared that to Linux kernel that basically abstracted this in a common interface, right? I hope this is where we are going, because this is not just, from a UI perspective, you're right that this might be too complicated for my grandma to, change providers. It's too complicated. Even if we provide a really nice interface, she would be like, why do I need to change the provider, right? Email is also really complicated because there are so many providers, and how do these providers communicate with each other? But another thing that it offers is that software can be written for one provider, not just for one provider, but for all of the providers, right? I can be the Silicon Valley startup that open source is maybe a drawing component or something, right? And then in my cool decentralized indie hacker project, I can use this drawing component, right? Use it in my app and use a completely decentralized hacky provider, right? Just as an abstraction, right? And this is, I think, one of the main advantages. Although I really hope that we eventually find the UI components so that even my grandma is able to change providers to maybe the host or that to my server or something, right? Maybe all of this will be easier in the future. Maybe it's not. But you know, we have more options by separating these.
So directly related, we need standards.
I think I really think we shouldn't have standards at this moment. I hate it because then everyone will standardize on this one weird protocol, and then next algorithm will come up and doesn't support this protocol because it's too advanced, because we missed something. I think at the moment we really don't need it. Like we can just have separate protocols. The same goes actually for many people ask me, should we make YJS and Automage compatible? I don't think we need to. We can just use them alongside each other if we want to. We can have even YJS, a lot of users use the awareness CRDT alongside YJS, which is a completely separate CRDT which synchronizes over the same provider. And the same can go with different CRDT implementations if we ever want to. So we don't need a standard, I think. I think, yeah.
In these early stages, a common open source implementation would be like a poor man's standard, right? Everybody just agrees on the release for the same open source.
Yeah. Or, just this, there's this one person group organization that creates a provider that just works with these CRDTs, and, that's just how they think. I think these kinds of standards can be developed eventually, but at the moment it's way too early because, YJS has one way to synchronize stuff, and I know that Automage are working on a really different way to synchronize and a very different synchronization protocol that has many different advantages, right? So I'm not sure if we should standardize on this one synchronization protocol that has a very specific layout.
Yeah. Maybe a concrete question because I'm interested. Mira, you've heard now a lot about standards and technical differences, but in language research we do abstract away over these differences, right? Is that something where we have something to offer, maybe?
Well, I hope we do, but actually he also mentioned, as far as I understood, sorry to say, but I don't know YJS as good. I've only heard about it, but the way I understood what you were saying is that you have this abstraction when it comes to the message dissemination layer, I call it. So which network protocol do I use to disseminate my update, right? Mm-hmm. And I understood you as saying that YJS allows you to configure that layer to say, I want now this provider, or even a combination of them. Mm-hmm. And this is something that programming abstractions, at least this is what I understand under programming abstractions. I mean, you have built them in your framework, in languages, we try to build them in the language so that the programmer cannot get things wrong. Like the abstractions come with the support for encryption, and encryption is very hard to use for developers. So it's better you get the experts, build it into the language abstractions that the developers use. Mm-hmm. Of course, this comes then with a little bit of loss of flexibility for those that are expert enough that want to get their crypto trick themselves. But that's the thing between, I don't think there is a contradiction between software and systems, because at least all we try to do is to build abstractions to make building systems easier, because they are super hard to build. I fully agree with you.
I have a question from the language perspective. What are some existing languages that you think might be inspirational examples to look at as we're thinking about what these new language features might look like for local first, for CRDTs, for these kinds of new rendering pipelines, whatever that looks like? What references should we go dig around in and look for?
Oh, I have to be biased.
Yeah, that's great.
Well, functional reactive programming languages, and you mentioned them already in your talk. You mentioned Elm, for example, but well, I'd like to mention REScala also, because we go a step further in building in support for distributed systems. So REScala is not only for UI design, but it has built-in support for example, having interactions that go from pressing the button to changing some intermediate state to the database, to the other side, changing the UI in one run, in one snapshot, as you call them, somehow in a consistent way. And consistent can be eventual consistent, or it can be even a little bit more than eventual consistency when it is not enough. So we derive the consistency level from application invariance. Again, to have the developer not be confronted directly with, does it have to be causal consistent, eventual consistent, strong consistent, because this doesn't say much to them, I mean, to the ordinary programmers, not to the, what they care is about the bank account shouldn't go minus, right?
The button should be blue and have corners that are 3 pixels in
Or if I have a shared calendar, the concurrent changes shouldn't end up having an appointment that ends before it starts, or things like this at the application level. And then there is some, and Elisa also talked a little bit about this, the difference is that we look at this interaction, so we do it end to end. How can we derive the consistency level from there? So I think there are not many, surprisingly to me, I have to say, there are not many groups working on functional reactive programming languages where you build these interaction concepts into the language natively. So Elisa's, I mean, no, we are doing some Elm, of course, but yeah, I don't know.
Yeah, so I completely agree that the important bit here for developers, I mean, consistency is consistency is one perspective, right? Yeah. The perspective that the developer of an application or of a database really cares about is whether the data is correct, right? And we can translate that to invariance. And then we can say, oh, this particular invariant requires this level of consistency. That's what that's the sort of the hybrid consistency approach. And we sort of know how to do that. We sort of know how to do static analysis of an application and derive from that the consistency levels, right? But it's still extremely experimental, and it's very hard for developers to express their invariance in the first place.
That's a good point. Yeah.
I want to offer actually a bit of a disagreement, which is what we found with Postgres. Right, Postgres is a pretty good database. It has a lot of control over, various concurrency levels and locking semantics and all this kind of stuff. People use it because we gave it to them. You give them a Ferrari and they like drive it like a golf cart, right? Like it's, and that's fine, right? But like I think people use programming languages that give them abstractions that are intelligible to their daily needs, right? They have a job to make a web page for a golf course or a bank or a startup. They don't think about concurrency at all. Like they just want to get a div into the browser. I think this work is important because when we build good abstractions, they take advantage without knowing it. I think that's true. Yeah. But I think in terms of what they think about, these developers, we talk to a lot of them, they're not even aware that these are problems, so they don't know to go looking for solutions.
Right, but when you do need a solution, how do you do it, right? So if you don't have language support, or if you don't have tooling support, it's all manual and you can make mistakes. So,
and then they do.
I mean, at the moment, I agree with you that what all you said. So otherwise, we wouldn't have JavaScript all over. Okay. But if we say we want to do something in an application-specific way, application-specific specific means only the application developer knows what are the needs of the application, so why not support him or her in expressing this and deriving all the technical concerns from that level. But as I said, I'm biased, and I have been told lessons all my life, like JavaScript taking over the world or something, that I would, as a language designer, think there are many better languages out there, but this was the one that the developers somehow felt.
Well, it's in the browser, right?
Yeah, I agree.
Brand is destiny.
I agree.
Anita, you also have a...
Yeah, so related to these tools that you mentioned, people use types and they have their own application-specific data types kind of developed and are able to use type checkers in order to make sure that certain problems don't occur. What is needed to make static or maybe even dynamic analysis tools for local first software that is as easy to use as a type checker?
But this is one of the points. Once you have higher level abstractions, it's not only for the developers, I forget to mention this point, but it gives a lot of power to the language runtime also, because if the language runtime has the dependency between computations explicit, then it can do easy static analysis on them, it can do optimizations, it can insert transaction boundaries out of the box. So it's also a lot of power to the compilers and runtime machineries to optimize or to introduce, to do static or dynamic analysis. Which developers, again, maybe do not care, but the tool builders would care.
Maybe there's a parallel here between the developers and the users. Everyone's just trying to solve their problem, and most of them don't care, for example, something like data locality or like local first, but you have to put it in terms of like, how does this help you? How does this help your life? And for an end user, that might be something like, I can use this offline. And for a developer, it might be something like, yes, you're working in a particular domain, you know your domain, it has these particular constraints because you're making a piece of software that's used on a construction site and there's less connectivity. But you do see it still need to synchronize between it, and it's really a hassle, and it gets out of sync, and your customers complain to you, and you're working late nights trying to fix these bugs, and we're offering you something that will take that pain away, so that they can care about how it solves their problem, not the maybe more abstract stuff that we all tend to think about.
Anita, you have also.
Your critique on JavaScript is absolutely valid. I just want to say that. But something that JavaScript does in a way well is that, if you want to write software for the browser, which is like the environment, if you want to build something, you have to do it in JavaScript or something that compiles to JavaScript and can execute and modify the DOM. And also, JavaScript libraries are usually compatible and interact with each other, right? So I can use this cool React framework, and this has a lot of cool UI tooling. So even though this specific programming language is much better, I would need to spend a year just to write the UI components for it, right? How would you integrate with the web?
So the approach that we take, that's why the name says it REScala, we built on Scala, because it allows you to pretend you build languages, but those are libraries. So the whole REScala language is actually a Scala library. And it means that you can reuse all of the ecosystem of the JVM, actually. So it's not really a language, but it feels like a language because Scala enables embedding abstractions in a way that feel like being embedded by a compiler, not as a library.
I mean, maybe a suggestion. So something that I do a lot for companies is build these shared models, the data source, basically, if you want the database of their application. And usually it's really not too complex. Often it's just a list of cells, basically, and cells are text documents and something. Then I create an API around it, and then I integrate it into their application that might already exist. So if you can write a language that compiles to WASM and generates these interfaces, you would make me rich as a contractor, because that was all my job, like for 2 years or something. Everything that I did, and I think. The more collaborative applications we create, right, the more we need tooling, and as you said, right, we want tooling. What do you think about that?
So just to complement Mira, REScala does also compile to JavaScript, which means we can also use all of the JavaScript frameworks on the client side while using all of the Java framework on the server side. We also compile to Scala native, which kind of does compile to Wasm, not quite yet, but will be soon, maybe. So these things all work on high-level language. Like if you have a high-level language, you just compile where you need to go. It's not that hard to compile and use the ecosystem of that platform. It's not, like, languages are pretty compatible in that sense. And now I've overstepped my bounds as a moderator.
Oh, that was a good answer.
Just to add a completely new, different aspect to it. So we're talking about where to store data and that it's cool to have data at home and so on. Looking into the future, our CRDT-based or local first-based software, is this an ecological good thing to have? Aren't server farms like the cloud that has dedicated shared resources with good energy provision and so on, aren't they maybe the better choice?
Yes.
Yeah, you go.
I don't know, maybe I can start from what I think that local first or local management, decentralized management of data can help actually with, because I've heard, there are studies, it's not anecdotal, that like 50% of the data stored in those data centers is dark data, so nobody knows why the data is stored. And another, or 30% of it is rote data, so completely rubbish.
So just like on my laptop.
Yeah, just in our laptops, exactly, but replicate this to...
You have to have your laptops.
So the hope is that maybe if the data is only with me, my data, your data, his data, then this is unique and can be reused by several providers. Nowadays, whatever, Google has my data, I don't know, I'm not on Facebook, but I'm on WhatsApp, so they have my data or some part of my data, PayPal has some data. So there are silos of data and it has to be duplicated. So this might help. And also this infrastructure, we have it in place, so why build servers, farms again and again, and we don't use this infrastructure. So this thing has, I don't know how much, I don't use it. It's like you said, Ferrari being used as a bicycle actually, because I just make phone calls and some WhatsApp. So I believe that it can help even in reducing the CO2 emissions due to.
I don't know if we can answer that question. You know, like when I started computing, there was, you know, one computer for my whole, you know, research lab, and we used VT52s, and you know, sure, that used a lot less energy than cloud computing does. But can we stop people from buying laptops and a laptop and an iPad and an iPhone and etc.? So we can do things. We can try to not send data to the data center. We can try to reduce, you know, the duplication of data. We can send deltas instead of sending whole data. But that's probably very marginal in terms of savings compared to the fact of having a laptop in the first place. So, I mean, I don't know the answer to the question. Until someone actually does the study, I don't think there's any clear answer. Maybe yes, maybe no.
Yeah, I want to give another answer to this. I think that was a really interesting question. Is it monetary? Like, it doesn't make sense economically to write local first software. I would say that's a definite yes. Like at the moment, if you're a startup, a company that builds software, right? You set up on AWS or something, then use DynamoDB and Elasticsearch, and you know, a lot of custom tooling. You build on their infrastructure. You build all this logic on the backend, right? So so that your clients can get served data. But if you think the other way around, you have all this logic on the client, right? You already have it there, and the cloud, in a way, is only there maybe to store the data, right? And you can switch the cloud easily by moving the data to a different place, right? It's a very much less logic. So for the company that writes this application, it definitely makes sense economically to have less logic on the back end, right? And that's what Peter said in his presentation at the beginning. Yeah. So yeah.
So sticking with the kind of looking into the future theme, I had this one question prepared, which I would pose to Marc first. From the things you've seen at the workshop, or maybe things that the workshop invokes, what do you think from your experience is the thing to go forward with in the future? Like, where would you point your finger to and say, I want to look at this some more?
Are you asking me to predict the future?
Yes.
Let's restrict it. The future of local servers.
I mean, the list of open questions that Peter listed earlier, I think, I agree a lot with that. Some of the things I personally worry about is the interaction between access control and consistency. What happens if I accept some update and then later discover, because of asynchrony, that update was actually illegal? Am I going to roll back? Am I going to, I have to violate something, right? Because I made a mistake. So what do I choose to violate? So that's one question. How do we build systems? How do we build systems that, of course, are self-managing and self-repairing, and then are look simple to people, but are internally complicated. Let me stop there. I think Peter wanted to say something.
I was going to say, I think Pat Allen's memories, what was it, building on quicksand, memories, guesses, and apologies, right? Like, we have to make the best decisions we can in the moment, and sometimes they'll be wrong. But it's the same outside of computers too. And when we screw up, then we do our best to make it right. Or, well, hopefully, right? But if you make a bad decision and you accepted data that was wrong, now what, right? Like, we know we can't prevent it. This is sort of one of the themes of the opening keynote, was like, well, we can't stop time, and particularly because it's an open membership system. So we don't know what we don't know. So we can't wait forever because data could always arrive later. And so that means, since we cannot assume global consistency will ever form, we just have to do the best we can, and we will have to be able to compensate. And that's inescapable. We have to plan for that from the beginning.
Sure, but the question is, how do you translate that into technology?
Yeah.
That people can understand.
Well, we're going to have to systematize the apology or the reconciliation, right? I don't know what it means yet.
And ensure it converges.
Yeah.
Do you want to say?
Yeah, just a quick maybe question about, you were talking about the ecological impact of cloud computing. I wonder, is there going backwards, and maybe going back to the beginning of the day when Peter was talking about running a game in an emulator, like in a Windows 95 machine. Personal computing has evolved to a point where we're almost obligated to buy a new laptop every year or 2 or 3 because the software demands are so they escalate and increase exponentially. And so with local first programming, is there a balance to be struck with the performance demands where we're not required to or dependent on the latest technology, where our software can run on a 6-year-old iPad, or maybe a Windows 95 machine or whatever? I don't know, this was more of like...
It was more of a comment than a question. That's fine. Martin, you said
Yeah, one thing I would be interested in the opinions of the panel about. So one thing of the GDPR which often seems to get forgotten is the right to data portability, and the way that often seems to get implemented is you can download a zip file of JSON from one service and then you can't import it into any other service, and so it's a bit useless. However, if we have local first software, that already implies that there's some kind of data synchronization protocol for getting the data from one device to another. Do you think it would make sense to use that same data synchronization protocol to synchronize your data from one service to another, so that you could actually, not just have a one-time export, but actually a live synchronization of your data across potentially different user interfaces, different views onto the same data? I'm not sure exactly where this goes, but maybe some of you have ideas on this.
Doesn't it go towards standardization?
Say again?
Doesn't it go towards standardization?
It probably does, yes.
I think for some kind of data, it would be awesome to standardize on a certain format, right? If we find a standard for simple rich text, right, it would be super easy to just share normal text documents, like really, really easy ones. But I would say like there are also some more complex types of rich text, like the stuff in Google Docs, for example. It's very complex, but personally I would do it differently than Google Docs, right? I want different properties on my rich text editor. So it's really hard to standardize these ones, right? But for certain, I'm thinking calendar data, for example, iCal. Can we have a CRDT version of that, please? So how awesome would that be?
Standards.
Yes, for that, definitely. Definitely. Yeah.
Although I will note that iCal is another place where when you go and look at a lot of these services that use what would totally be a use case for the streaming synchronization, like the Calendly class of applications. Calendly and SavvyCal and all those others, they actually don't use iCal, they just integrate to the Google Calendar API, and maybe they support Outlook as well. It's typically the way that it works. So somewhere in there's an open standard, but in the end, everyone integrates custom APIs, which is like a failure state as far as I'm concerned, but it points to something that as an industry we've kind of never really done well outside of maybe very, very technical areas like plain text and code, that sort of thing. Clemens has his hand up.
I'm chewing on the interaction between a bunch of different statements that we've heard today. We're excited about local first software because it feels simpler than the entire stack of cloud plus clients today. But it's a lot more complicated than the client today. A single page web app, that kind of thing. And we've also thrown around the comment that the web apps that we have today are broken, you can't trust the client. When it gets broken, just reload and maybe that'll fix it. So as we talk about making the client more complicated, it's going to become harder to debug, and it's a lot further away from our control and what we can see into than the servers that we have trouble with today. So, and then the React people have clearly settled on a model where your UI emits events, you have a reducer that updates the data store, and then spits out a new version of the data that you render. So when I listen to all the stuff that you guys are excited about, actors running between different clients, programming language features, that kind of thing, I hear a lot more complicated than the broken clients that we have today. And I wonder why we're not just talking about a model where the UI emits events, it updates the data store, those events are used to synchronize to other computers, and we stop there because that's already about the limit that we've managed, and is a lot of what people are talking about already for decentralized local first software. It seems to me that that's the consensus model hiding underneath all of this.
You may like the model of REScala, by the way. Anyways.
No, but basically this is what we do, but we hide. You shouldn't be forced to manage this at the client, at the application code. You're not the programmer, the language should, or the language runtime, the framework, let's put it this way, because I think I confuse people when I talk about language. Should do it for you.
But the React community is totally happy without language extensions to do this, and they're basically solving the same problem.
Right, I mean...
It's not a language extension.
So React has this JSX, which is its own compiler, just saying.
Yeah, and we don't have a compiler. So, I mean, we take it offline. It's too much technical detail about this. Basically, the whole, I mean, it's the same idea, trying to make it easier for the program. The thing is, these updates shouldn't be managed at the application level because this is accidental complexity. The developer should be able to say that there is A is equal B plus C, that's it. And how A is kept up to date to the value of B or C, the machinery should do it. We have call by, what do we call, eager evaluation of functions. We have lazy evaluation. We should have reactive evaluation. I mean, we have it. It's not so difficult.
To jump in here, I think this is also exactly the area where React is hitting the limitations, right? So if you see the amount of state management frameworks that have come out and are being about, there's a new one every week. So I would note like React arguably has solved a lot of issues around JavaScript and UI development for many people, but I wouldn't say that state management is necessarily the main one of there. Still a lot in flux.
But I think we are leaving the level where you're trying to get us higher up in the.
We have to close soon anyway. So, maybe some short. Clemens, you had a.
Yeah, just connecting to the discussions about the GDPR, there was recently the Digital Markets Act that tried to quench the dominance of these different messaging platforms, so Messenger and WhatsApp and whatnot, and have these interoperability requirements if your app has a certain size. Do you think these regulations around interoperability, which I believe we've just seen the beginning of, is an opportunity for open source, local first software?
I do think it is, but the question is as short as, I mean, I believe it is an opportunity.
Yeah, personally, I'm probably a bit skeptical of the stick approach to motivating software development, and I'm more interested in the carrot. So what benefit do users get? And that includes both what benefit they actually get, which I think a lot of us can see things that maybe many users wouldn't, even fairly sophisticated ones, wouldn't understand. But we need to help them understand. Again, I come back to the Signal example on encryption. What's a version of that on integration or data interoperability, where you can make a business case or a personal case where you say, because these two services can talk to each other, it's more valuable to you as a user. Both of those businesses are more effective and more successful and make more money. Like, I think that's how we get there, rather than.
And to add one sentence in that direction, I wanted to mention before, I don't know whether things like IoT or agriculture 4.0 so aren't the killer app for local first software, because their intermittent connectivity is given. It's not like local first is nice to have, local first because it has to be, because you don't have the connections to the centralized internet most of the time. So maybe like autonomous driving car, collaborative robots, drones, whatever, that space.
And maybe embedded in that statement is an important point. I don't know if anyone's made, which is local first still needs its killer app. We haven't found it yet. That's a combination of developing the technology far enough and then finding the ways that the very incomplete technology that we have can be applied to a domain where the users and the customers really value what they get.
What about Git?
Git is certainly one of the ones we cite in the local first essay as being about the closest you can get in many senses, and is an inspiration, right? Like when I switched in my former life as a developer from Subversion, which is more a centralized system, and where I'm tethered to the server if I want to make changes to the Git model. It was this revelation. It just felt fundamentally different. I didn't understand decentralized. I didn't understand the difference in like how it worked on the inside, but as a user, I felt liberated, and it was faster and freer, and I'm like, this is great. Give me more of this. So, what's the equivalent of that for other kinds of software built on this?
Do I have one more question in the back that's still there?
It was a little bit political. Although GDPR, some of us talked a little bit about this before, that technically GDPR should allow us to get our own data and to transport it to a new app, maybe even a local first app, which might be a nice way to create lots of brilliant local first versions of formerly more centralized apps. But in practice, that doesn't seem to be possible at all, and it doesn't seem to be enforced in the law that it's actually possible automatically to get that data. So it's always very hard. The user has to go through many steps, and it goes through its email, their email and stuff like that. So what do you see as a solution for that problem? Like, how do you create like local first versions of centralized apps?
I think Peter has an answer.
We looked at this with Cambria. I think our hypothesis, which remains very unproven, but I would encourage anybody to explore, is that we could build bidirectional synchronizing lenses between cloud services. Right? The dream is like, you have an issue tracker in Trello, and you have issues tracked in GitHub issues, and you should be able to drag something in Trello and see it update in GitHub issues. And one of Clemens' students wrote a paper about how knowledge workers are forced to use the tools of their employers and not the tools that they bring. Carpenters, writers, other kinds of people, they can use their own tools, but graphic designers, project managers, there's a lot of these kinds of work where you're just forced to use the place you go to. I think there's an opportunity with some of these tools to help do that, and I hope more people will explore it, though there are definitely some problems.
So one more in the back before we do the closing round.
Yeah, I was going to add on to that. So Clemens already mentioned the Markets Act, and I think it'll be interesting to see what sort of solutions come out of the messaging space where effectively this Markets Act requires interoperability. So, I mean, someone is going to have to devise these solutions if they're going to follow those regulations. So it'll be interesting to see what kind of techniques they come out with in that space.
Okay, so there was one mentioned thing in one of the talks, sorry I forgot which one, which is like, I'm scared that Google will come and kill me because I work on something competing. So I would like to hear your answers. Kevin, will you start? Do you fear the pressure of the big companies?
Why would they be interested in killing me?
Metaphorically speaking.
This is something bold to say, but I don't think that Google could compete with the CRDT implementation. Right? And the reason for that is, as it also was mentioned in Peter's talk, Google kills projects like flies and mosquitoes in the summer. Google had a really awesome collaborative editing framework, basically, that they hosted, they had a service, and everyone was able to use it. And a lot of people built collaborative applications based on it. And then just, they didn't want to maintain it anymore, and they killed this project. And now we have a lot of applications that were collaborative, but are not anymore. And a good example for that is Jupyter Colab, I think it's called. It's not collaborative anymore. It's so sad. So you want an open source solution, definitely. And you want something where you can switch between providers. I don't just want to maintain my data only on Google as a company, but maybe it should be easy to switch, right? So I don't think that Google can compete, or a single company can compete, unless they are willing to work together with many other people.
So the only way they can compete is doing the same as you do.
Yeah, or as also Automage is doing, right? Being open and having open standards and an open interface. Yeah,
thank you. So Adam, you're trying to build a business. So are you worried about the big tech companies?
Yeah, I'd probably go back to the classic disruptive innovation, Clay Christensen kind of model, which is that in the beginning, when the thing seems so trivial, it will not be on the radar of the bigger companies. And then by the time it has established itself well enough to be a real movement, it's sort of too late for them to do anything. And I think it's good to, Peter used this framing of the different computing eras. And if we look at cloud era, what were some of the killer apps back in the 90s? It was like Hotmail, right? When Hotmail came along, you don't look at this and think like it was worse in many, many ways than, the email clients that were already out there, but it offered some truly unique benefits that you couldn't get in another way. And so I think coming back to that killer app point as well, we're trying to find some of those early footholds, and those will grow and develop with time. And I guess by the time it's big enough for the tech giants to care, then I guess they show up and try to require you. But hopefully by that point, the era has already begun, and it's not about any individual company or product and its ability to compete, but that we've just changed computing overall, which is what I care about way more than my individual business or paycheck or whatever.
Right, so you think the ideas will prevail?
Yeah, call me an idealist.
So Mira, we're also like kind of competing with big companies. You mentioned that even the financing kind of says we should work together with them, and this doesn't quite make sense. What's your...
That's the luxus of being in research and being paid by taxpayers' money. That, of course, I mean, for our research outcome, it is a factor because these big industrial research labs, I mean, Google doesn't, but even the numbers and the resources they have, they can be much faster. But the same thing applies, I think, that if you have an idea early enough when it's not in the radar and it's not in there, they have the everyday business. They want to keep the ad, let's put Google income going, so it's not in their radar to innovate programming support in the first place. So, and if you get fast enough, I mean, and Scala is the example, I mean, it's a language, but there are a lot of open source programming tools out there which made it so. And I think what is important, we are not forced to collaborate with them. I mean, what is a very important factor, I think, is interactions like this that we have today here, which I'm very happy that it happened this way, because it's not usual anymore in research conferences, in academic conferences. When I entered academia, this was different. So early days of UPSLA, they were all together, academics and practitioners, all thinking about the future of programming at that time. So, and this has went lost, at least in conferences where I go. So I was very happy that you guys managed to bring us together today.
Yeah, thank you. Marc, what's your...
Yeah, I think there's room for everybody. You know, I mean, the world is big, and you know, Google does many things right.
Yeah.
And you know, that's how they became a big company, but they cannot cover everything. On the other hand, Google gave us some money at the beginning of the CRDT research, so thank you, Google.
Yeah.
And it's interesting that, I mean, CRDTs became popular really by word of mouth, and there was no, you know...
Do you know of any adoption of CRDTs in like large companies? Because there was a lot of operational transform, right? But
well, Apple apparently uses CRDTs in Notes. You know, I mean, there's quite a few examples.
It's a give and take, basically.
I mean, Microsoft? What's it called? Cosmos implements CRDTs. Why not? And Redis uses CRDT, so yeah.
So I guess with that, we're at the end of the panel. I would like to thank our panelists. Really, but also thank you for...
If you don't mind, I'd like to thank our organizers.
Yes.
Yes.
You were much faster than me, and he said it twice today that I sponsored this, and I looked at Annette and was like, what did I do? I didn't do anything in terms of sponsoring, except that you brought some microphones from our lab with you.
Mira, you're technically paying me, so...
The government is paying you, not me. The taxpayer is paying you.
So,
but, I mean,
thanks to the taxpayers.
All I did was the idea. I said, guys, why don't we have a workshop on local first, and you did it, and you did it so nicely, so thank you very much.
That is great. So I think the workshop was much more successful than we expected, so we may have to do it again. So I will try to put a feedback form on the website. It's not on there yet, but I'll try to do it soonish. So please check out the website tomorrow or so and leave your feedback if you have something, and also maybe give a chance to leave your email so we can contact you in case we have any further developments that are unexpected. With that, we can close the workshop. I would ask the speakers that attend the dinner and everyone else who wants to join maybe to meet at 6. Julian, that's right? At 6 in the foyer, maybe? In the foyer.
So downstairs.
Downstairs where the coffee breaks were. With that.
Downstairs.
At the main entrance.
Yeah.
Main entrance. Okay.
First floor, right? First floor.
First floor, okay. Main entrance at 6. That sounds good. Thank you very much, everyone.